This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today. Okay, now it is time to talk about networking and the fundamentals of networking. Again, this is not going to be a replacement for Network Plus or anything like that, but it will be fairly comprehensive, and we're going to go through a lot of the fundamentals as well as some of the commands and tools that you will need to navigate the network and the network connections and the interfaces of a Linux environment. So first and foremost, let's go into some basic networking concepts. IP addressing. So IP addresses are unique identifiers assigned to devices that are connected to a network. They allow you to communicate with each other and are very important for network management and communication. So anything, when you hear something like a network, or anytime that you hear the word network, think IP addresses. And IP addresses are very much the main, the main identifiers that are assigned through various devices. So your TV has an IP address, your phone will have an IP address, your computer obviously will have an IP address. Anything that's connected to a network, anything that's connected to the internet will have an IP address. IPv4 is the original IP address, and it's a 32-bit numerical label. What you see right here in the green right here, that's traditionally what it looks like. It's separated by 3 dots, and it has 3 digits, or it can have up to 3 digits on each portion of this thing, and it can go from 0. It can go from 0 and go all the way to 254, I want to say. We'll verify that in a couple of slides. So what it does is it provides approximately 4.3 billion unique addresses. But then what happened is that a lot of devices were developed. So, the average household has, or the average person even has multiple devices that are connected to the internet. And quickly, way faster than I think people anticipated, the IPv4 addresses ran out. But what happens is that each ISP, each internet service provider, assigns a series of private IP addresses to each individual person. And for the most part, you will not run across a duplicate IP address, although being that there's only 4.3 billion unique variations, it can run across. So it can actually have duplicates. And that's one of the issues that resulted in them developing IPv6. So IPv4 is the most commonly used version of IP, but because of the fact that there were so many devices, they developed a new IPv6 format. And the IPv6 format looks very different from what we saw previously. It is 128-bit, whereas IPv4 is 32-bit. So when you have a 128-bit identifier, it obviously looks a little bit different. So in this particular case, this is a sample of an IPv6 address. And instead of offering the billions, this actually offers 340 undecillion addresses. And I had not even heard of this word prior to looking at IPv6 IP addresses. Clearly, it is way more than what is available with IPv4. So it's designed to replace IPv4 eventually. But your current computer and my current computer, they have both of these. So they'll actually have the IPv4 as well as the IPv6. But ultimately, at some point, not exactly sure when, IPv6 will replace IPv4 IP addresses. To understand networking and IP addresses, you also need to understand subnetting. So what a subnet is. And subnetting is a method that's used to divide a larger network into smaller chunks so that they're easier to manage. And those small chunks are called subnets. And it improves the network's organization, the efficiency of the network, and the security of the network. It also helps to reduce the congestion of the network, meaning that there won't be too many things happening at the same time. It won't be blocked off or clogged, so to speak. A subnet mask is what you can see as an example in this particular case in the green right here. So subnet masks determine the network and the host portions of the IP address. So for IPv4, a common one is what you see here. Now, the network portion are these first series of 255s, and then the host portion would be this very last thing that is represented by a 0 here. So in this particular case, we have 3 octets that represent the network portion. So that's one octet, that's another octet, that's another octet. Altogether, you have 4 octets, and 4 times octet, so octet is 8 bits, right? So when you have 4 times 8, you have a total of 32. So this is a total of 32 bits. Now, when you have the first 3 octets that are represented by the network, that means that these are the network itself. So in this particular network, these 3 portions are going to look exactly the same, and each device is going to have a different number at the very end of it. So the first 3 portions will be exactly the same because that'll be that network that they're connected to, and then that last bit is what's going to change. That last octet is what's going to change to assign a unique identifier for each one of those devices. So for example, in this particular case, we have 192.168.1.1 was a subnet mask of 255.255.255. So the first 3 octets are exactly the same, which means that this portion 192.168.1, this first 3 the numbers right here represent the network, and then the last piece would be the actual host. And then if there's 3 hosts, presumably it would be 1, 2, and 3. So 192.168.1.1, 192.168.1.2, 192.168.1.3, so on and so forth. So this is the subnet that is represented with this mask right here. We have this subnet mask. Now, if we wanted to expand this, this is what it actually looks like right here. So the binary representation is we have 8 ones here, 8 ones here, 8 ones here, and then we have the zeros at the end representing the portion that can change. And this is the subnet mask right here. The network bits in this case are 24. So you have 8 times 3, which would be 24. The host bits would be 8, this last 8 octet, or this 8 bits right here. The calculation, it's a little bit complicated, but not really. So you have the number of the hosts per subnet, which would be 2 to the power of the number of host bits. So the number of host bits in this case would be 8. So 2 to the power of 8 is what we see here, minus 2. And I'll explain what this means right here. But 2 to the power of 8 minus 2 would be 256. So 2 to the power of 8 would be 256 minus 2, which ends up being 254. So this particular subnet can have 254 individual IP addresses, okay? So 254 hosts can reside on this particular subnet mask. That's how it breaks down. Now we look at the next sample of this, where you have a subnet mask that actually has the first 2 octets reserved for the network, and then you have the next 2 octets reserved for the hosts. So you have 16 bits. This portion, 2 times 8, is 16 bits. You have these 16 bits reserved for the network, and then you have these 16 bits reserved for the host. And when we actually do the calculation here, it would be 2 to the power of 16, which is 65,536. 65,536 potential hosts, except you have to subtract that 2, so it ends up being 65,534. So very different from this 254 that is on this one octet right here. If you just free up 2 of these octets for this particular subnet mask, you now have 65,534 potential host IP addresses that you can assign to people inside of this particular subnet or this particular network, right? So this is what it looks like. Now, why do we subtract 2? This is a very important question. So there are 2 addresses that we need to reserve for any given network. And the first one is the network address. So the first address in the subnet, which is reserved for the network itself, which ends up being represented by just, it could be the 0, right? For example. And then the next one is the broadcast address, which is the last address that's represented in the network, which would be technically the 256, for example, or 255, excuse me. So the 0 and then the 255, for example, would be the ones that are reserved. So you actually can go up to 254, right? So go from 1 to 254 as an example. But for the most part, and you can assign this when you're actually assigning your gateways and you're developing your network subnet and the mask itself, you will assign your network address, and then you will assign your broadcast address, and then that'll take up 2 of those variations, and then the remaining 253 of the variations will allow for the rest of the devices, the rest of the hosts that can reside on that subnet. So as a summary, we can have this subnet that allows for 254 potential hosts to reside on it, and then you can have this subnet that can allow for 65,534 potential hosts. So this would obviously be a company. This would be probably a home or a company that has less than 254 devices. And being that each employee might get, let's say, I don't know, their cell phone would be one, their work cell phone would be another one, their computer would be one, maybe an IP address or a iPad or something like that, a tablet, that would be one, their TVs, that would be, if they have any smart TVs sprinkled around the office, so on and so forth. So for the most part, you're going to have maybe around 50 employees that can reside in a network that looks like this. But anything more than that, they would have a larger subnet because there's just multiple devices per employee, per person. And so you just need more than 254 potential addresses. And this is how subnet masks and the calculations of those hosts work. When a device connects to a network, it is assigned an IP address. This address can either be IPv4 or IPv6, depending on the network's configuration. Subnetting helps organize the network by breaking it into smaller segments, making it easier to manage and enhance security by isolating different parts of the network from each other. So this is the whole purpose behind it. Number one, to make it easier to manage and enhance the security by isolating different parts of the network from each other. So when you have multiple subnets, it makes it easier for you to find out which host was, for example, exploited and which host was hacked into. And because they reside in their own little segment, they won't affect the rest of your network, and it can be contained within that specific segment. It can be isolated within that segment. The domain name system is the next level up when it comes down to addressing. So it's basically the phone book of the internet. Typically, domain names are related to actual websites, but each website actually has an IP address as well. So what happens is that most people aren't going to remember the IP address for the website. So the IP address for Google, for example, is whatever the series of numbers are, but you're not going to remember that. But you will remember Google, so you can remember example.com in this case, but example.com actually is pointing to an actual IP address, right? So even websites have IP addresses. Web servers, web applications, all of these things actually have IP addresses if they are connected to the internet. But for the most part, people aren't going to remember the IP address. Most people aren't that good with numbers, but they are fairly good with names. Everybody can remember facebook.com. They won't remember the Facebook IP address, but they'll remember the .com version of that IP address, which would be their domain name. And so the domain name will go through the DNS port as well as the domain name system protocol, right? And so this is how IP addresses get translated into domain names. Now, how DNS works is that when you type something into your browser, the computer needs to find the IP address that's connected to that actual name, the domain name. So because they're most easier for us to remember and we enter that, the computer, however, works with the individual IP addresses. So it needs to resolve that domain name to some kind of an IP address. So what it does is that it'll send out a query, right? So it'll looks like this, right? You will put your input as the user, you'll enter a domain name, and that'll be example.com, and you'll put that into the browser. You press enter, and then the resolver of the DNS in the computer sends a query, right? The computer will send the query to the DNS resolver. The resolver is typically provided by the ISP, the internet service provider. And then if the resolver doesn't actually have that in its cache, so if you don't have it stored in your cache or if the ISP doesn't have it stored in its cache, then it performs an actual lookup and it finds it for you, and then it stores it, right? So it'll query multiple DNS servers to find the correct IP address, and then once it finds that IP address, it will resolve it and it'll connect that IP address to the domain name so that the next time that you go and enter that name, it'll just load it for you quickly. If you clear your cache, then it'll perform that process all over again the next time that it goes through the search for the DNS resolver, right? So you enter something, the computer will send that query to the DNS resolver that's typically with the internet service provider. So if AT&T, for example, it'll send it to AT&T's DNS resolver, and the AT&T's DNS resolver will go through its database of all of the IP addresses that are connected to domain names, and if it has it in there, it'll just send it, and it'll send you to the website that you're trying to go to. If it doesn't have it, it does a recursive lookup and it'll try to find what that IP address is connected to or what that domain name is connected to, and then it'll load that IP address onto your browser. All of this happens in a matter of a second or two, depending on how fast your internet service is. So all of these things happen very, very quickly, and you don't really see them in the foreground. All you see is you typed in the IP address, you pressed enter, a second or two later a website loads, but this is what's happening in the background. The DNS server hierarchy is connected via the resolver itself. So the resolver will contact one of the root DNS servers, and these are at the top of the DNS hierarchy. So these are the actual .coms and the .orgs and the .nets. So these servers are at the top of the DNS hierarchy, and they direct the query, that DNS query that you made, to the appropriate top-level domain server, which would be any of these guys. So if it's a .com website, it'll go to that domain server, and then from that list of domain names, it'll find the IP address. If it's a .org, it'll go to that server, and from that list will pull whatever it is, right? So there are individual servers, typically because of the fact that there are literally probably billions of domain names at this point as well. So there's a bunch of different .coms, .orgs, .nets. Now there's .co and .io, .us, .coffee. There's a bunch of different top-level domain names now. So because of the fact that there's so many different variations, each one of them are going to have their own server. And then when you send that query is going to go to the appropriate server so that it can find the domain names. And this is mainly to make the process a little bit faster. If they were housing .com, .org, .net, and every other top-level domain name, if they were housing all of those things on one server at AT&T, it would probably take a much longer amount of time for that domain name to be pulled up and for that IP address to be found. So the TLD DNS server, once they're contacted, if you're looking for example.com, it would find the contact. I already explained all this, so I'm just gonna breeze through this particular portion. I got a little bit ahead of myself, but again, so if you're looking for the .com, it'll go to the contact of the .com TLD server, and it'll direct the query to that specific authoritative DNS server to get you example.com. The authoritative DNS server, which is the final step of this whole thing, is the one for this particular example for example.com. These servers host the actual domain name itself, and then they have the actual DNS records that map that to the IP address, and then that's where the data gets pulled. So it goes from the top level server, the TLD server, it'll find that, and then from there it'll point to the authoritative DNS server that's actually hosting that domain name, and that could be at AWS, it could be at GoDaddy, or a variety of different hosting providers. Once it is found and once the data has been pulled, it returns that to you, right? It sends it back to your computer, and then it just populates it onto your browser so that you can actually look at whatever you want to look at and watch the video or watch Netflix or all these things. So all of this stuff is happening so that you can get access to the data that you want to get access to. So to give you a visual representation of everything that we just talked about, typically these things are a little bit easier when you look at kind of the flow of it like this, right? So on your computer, you would look for self-repair.apple.com. So self.repair.apple.com, right? So where is this particular domain? And then what happens is that will go to your local DNS server, which would be either the cache that you have on your computer, the cache and host file that you can see on the left right here, or it'll be with your ISP, right? So if that doesn't exist, if you don't have it, if you haven't checked it, Then what's going to happen is that this local DNS server is going to send that question out. It's going to send that query out. And it's going to say, where is this place? Where is this location? What's the IP address of this place? And it'll go to the root server. And then the root server says, I have no idea. Try the authoritative server for the .com people, right? For all the .com domain names. And the authoritative server is going to be at this particular location. So that gets sent back to the local DNS server. Local DNS is like, all right, fine, you don't know, so I'll go to this guy. And this will be the .com top-level domain authoritative DNS server. So it'll go to those guys, and it'll say, hey, where is this thing? And they're like, I have no idea. Why don't you try Apple, right? Why don't you try the actual Apple server so that you can find out what the self-repair apple.com location for that IP address is. So that would be the TLD authoritative server's response. And then that comes back, and then the local DNS is like, oh, okay, fine. Let's go to Apple. So and every single time you see that this one says, I don't know, why don't you look for the .com server that's hosted at this IP address? And then this is like, oh, okay, so let me go to that IP address. And they go, and then this is the top level domain authoritative server. And then this thing sends a response back. I have no idea. Why don't you go to this IP address, which belongs to Apple? And it's like, oh, okay, fine. And then it'll come back and it'll be like, hey, Apple, where is this particular thing? And then Apple says, I don't know, why don't you try the authoritative server for repair.apple.com? So now there's the extra piece that comes in for this. And then it says, that is housed over here. And then finally it sends it over here. And it says, okay, fine. Hey, where is this thing? And then this says, oh, no problem. There is no self-repair. There is no self.repair that awful. And it will send it back. And then the website says, oh, okay, there is nothing. And this is where like you probably will get an error or something on the screen that doesn't load it. Now, if there is something like that, then what will happen is that it'll say, oh, this is the IP address for it. And then it'll send it to the DNS server, and the DNS server will send it to your computer, and it'll load it for you, right? That's the process right here. I just think that this is so funny that it sends this on this wild goose chase, and you go back and forth, and then you're like, oh, there is nothing here. And it's like, oh, Jesus. And so presumably, right, so if this particular location was not self.repair.apple.com, if it was, I don't know, repair.apple.com, it would stop at this portion, right? It would stop at this place, and it would be like, yeah, okay, here's the IP address for repair.apple.com. If we were just trying to go to apple.com and you send it, hey, where's apple.com? And it'll say, I don't know, why don't you try the .com server? And you'll come to the .com TLD authoritative server, and then you say, hey, where's apple.com? It'll be like, here's the IP address for apple.com, right? So it depends on how deep we're trying to go with this inquiry that we're making, and where we're trying to land, obviously. But it goes from your local DNS server, it'll go to the root server. The root server will send you to the .com TLD server. That place will send you to the potential authoritative server for that actual domain name, for that actual website, right? And this is the process of literally everything that we just talked about with this whole DNS part. So just to give you that explanation, we have the DNS servers, which are the specialized servers that are responsible for handling the process of translating a name to an IP address. And there are different types of servers. So you have the DNS resolver that we just talked about, which is the recursive resolver, and it receives the original query from your computer. So that was that thing in the bottom left corner. It receives that thing from your computer, and it handles the process of contacting everybody else to find that for you. And then finally, it'll send you, if it finds it, it'll send you to the page that you were looking for. From that, the DNS resolver, from that location, it'll go to the root DNS server, which was the thing in the top right. And then it'll say, this is the first stop, and this is what we're looking for. Why don't you go to the appropriate TLD server, which one might be .com or it might be .org or whatever. And then that will go to the actual .com or .org or .net, whatever, that top level domain server. And then from there, it'll redirect you. If it has the address, it'll redirect you. If it doesn't, it'll send you to the authoritative DNS server that will help you find the other thing. But typically, this is where it stops. So it'll go from the TLD DNS server, and then it'll say, okay, this is the .com location for the authoritative DNS that you're looking for, and then you can go to this particular place. And these are the servers, the authoritative DNS servers are the ones that actually store the records for domain names and provide the final IP address in response to what you're looking for. In that particular case, we were trying to go to store.apple.com, and then we were trying to go to repair.store, and so that went a little bit further. But typically, this is where it stops. You'll go from the TLD server, which is like, it's a .org website. Oh, okay, I want to go to a .org website. It'll send you to that particular authoritative server, and then that .org server will say, oh, okay, this is the address for this particular website that you're looking for. It makes it a lot easier. So instead of you having to remember IP addresses, you just remember a name. That's it. That's kind of one of the biggest benefits of DNS, right? Once you get past the user friendliness, it becomes scalable. So if you wanted to look at all of the freaking devices that are on the internet and the domain names that are on the internet and the IP addresses that are connected to these domain names on the internet, and you want to expand that, then you're looking at scalability. So DNS supports all of the massive number, and it's constantly growing. So it supports the growing number of devices that people keep buying, and they'll add another TV to their house and all of the domain names that people keep buying. So it supports that scalability, right? That the massive number that keeps growing and gets bigger. And then when you're considering the amount of queries that are being made to the internet. So imagine how many billions of queries are being made right now as you're watching this. How many millions and billions of people are trying to access millions and billions of locations across the internet. When you consider the massive amount of traffic that's just going back and forth as you're watching this right now across the internet, you need to also consider, well, these things can't crash, right? There needs to be some kind of a redundancy, means there's a backup server for Microsoft, for example. So if their initial server, there's some kind of an earthquake at the first server's location, and that particular building has a power outage, there needs to be a backup server that kicks in immediately so that Microsoft.com doesn't crash and you can still go and access that website. That was actually something that happened relatively recently, where the Microsoft service and all of the computers and all the devices that relied on Microsoft couldn't work. And this was like a couple of months ago. It was pretty recent that actually happened. And then that day, Microsoft lost over, I think, $150 million, something like this, some crazy number that they lost during that one day that they had an outage. So this is where redundancies come in. This is where reliability comes in. The DNS system and the variety of different TLD servers. So it's not just one TLD server that houses all of the .com domains. It's literally dozens of them, probably in the hundreds, that are across the globe in different locations. So just in case one crashes, you can go to another one and you still get reliable connections if you wanted to. And just expand that, extrapolate that to the .orgs and the .nets and all of the different countries and the different cities and so on and so forth. This is where redundancy is a big deal. This is where this structure, this hierarchy of structure that's available is a big deal, and it provides that reliability that people actually really need. Because, I mean, what would you do without the internet? And once you get past DNS, once you understand DNS, then you go into DHCP, which is the Dynamic Host Configuration Protocol. And this is a network management protocol that's used to automate the process of configuring devices on IP networks. So this is essentially what assigns the IP addresses to any new device that's connected to your router, to your internet, right? So when somebody comes and connects to your Wi-Fi, this is the protocol that assigns the IP address and any other configuration parameter to that device that just connected to your Wi-Fi. So it's DHCP that assigns the IP address to your Wi-Fi, to the device that just connected to your Wi-Fi. The way that it works is that a device, like a computer or whatever, connects to your Wi-Fi. It connects to the network. When it does that, it doesn't have an IP address. So it sends out a discovery broadcast message to a DHCP server. The DHCP server makes the offer, and so it receives that discovery message, and then it responds with the offer message, and it says, hey, here's the available IP address that we have on our network, and the network configuration information that you need, like the subnet mask that's connected to the default gateway that would exist, and any DNS server addresses, so on and so on. And most people really don't give a crap about this. They just want Wi-Fi. So most people really don't care about this. And of course, the devices don't display all of this stuff to the person who's connecting their cell phone to the Wi-Fi. They just say, oh shit, I have Wi-Fi connection. But what happens is that your cell phone sends out the request, and then the DHCP server actually responds with an offer and says, this is the IP address that I got for you, and these are all of the rules and configuration details for our specific network. And then the device receives that offer and responds with an actual request message that says, hey, I accept the offer that you've made. Thank you for this IP address, and thank you for giving me connection to this network. And finally, the server will acknowledge that request, and it'll say, all right, cool, this is your actual IP address from now on. And every time that you connect to me, this is the IP address that's going to be assigned to your particular device. And now the device can actually use the internet because it has its official address, and it can communicate with the network, the vast, wide network of the internet, the World Wide Web. There are a lot of benefits to this, obviously, right? So it simplifies the network setup. Imagine if you had to be the one to assign an IP address to every single device that connected to your network. And believe it or not, at a certain point in the history of the internet, this was actually the case. And people had to manually assign IP addresses to the computers and to the devices that were connected to the network. So especially when you have a massive network where configuring each device would not be possible, which is what Microsoft has or what Amazon has. They have literally tens of thousands of employees. So imagine if somebody had to sit there assigning IP addresses. That would be like a full-time 24/7 type of a job. So it avoids the conflict of addresses. This is the other piece that is very much prone to human error, right? So somebody might forget that, oh shoot, I already assigned this address to this other device, and now I can't reuse this address, and now I got to go do this other thing and try to find a new address, so on and so forth. The DHCP protocol, the system itself just keeps track of all these things and avoids any conflict. So it assigns an actual unique address to the person or to the device that's being connected to the network. And then there's the management of the IP address. So people want to use their IP addresses efficiently. If there's any kind of a security issue or a disconnection from the network, the IP address can be reassigned to another device. If it has to do anything with firewalls, which we're going to get into a little bit as well, it helps with the management of IP addresses and blocking, or meaning denying access to the network via the IP address, or allowing access to the network, so on and so forth. So it's the management of these IP addresses that comes in. And again, it has to do a lot with networks that have a lot of temporary or what they call transient devices. So if you go to a coffee shop Wi-Fi hotspot, right? So if you go to a coffee shop and you're connecting to that Wi-Fi, that specific Wi-Fi at that coffee shop has probably seen tens of thousands of devices that just roll through, and they're there for just one day because they need Wi-Fi, and then they leave. You know, the person came into town for a trip and then they left, and they're never going to visit that Wi-Fi spot again. But that IP address that was temporarily assigned to that person now needs to be freed up so that it can be assigned to somebody else, right? So this is how these transient devices or these temporary devices get managed through the DHCP protocol. And this is very important to understand, especially when you just go into a large enterprise environment. These are the types of things that are very, very useful. So when you're thinking about the management of IP addresses, what assigns the IP address inside of the network, that would be the DHCP protocol. What assigns the name to an IP address, that would be the DNS protocol, right? What types of IP addresses are there? IPv4 and IPv6, right? So these are the key things that you need to remember when it comes down to the networking fundamentals when you go further along with this. The DHCP lease is basically the time, the temporary amount of time that IP address will be assigned to that given device, right? So in a public Wi-Fi environment, the DHCP lease time is obviously way less than your personal home internet. So when the lease time is about to expire, the device has to renew the lease by sending a new request to the DHCP server, and then the DHCP server will send the offer. If it stays connected to the network, the server typically just renews the lease, which extends the time that the address is assigned so that you don't have to get a new IP address every single time for your laptop to be connected to your home Wi-Fi, right? So if it's constantly connected to it, or it's connected perpetually, like you never take your desktop computer out of your house, it stays, right? The laptop might be put in your backpack and it'll leave and it'll come back, but the desktop will never get disconnected from that Wi-Fi. So in that particular case, it'll just renew the lease and it'll just keep granting access to that particular IP address. But when your friend comes over and that you don't see them for the next 3 months or 6 months or whatever, that lease time will lapse, and then they'll need to reapply. They'll need to submit a new request to the DHCP protocol, the DHCP server, so that they can get assigned a new IP address when they come back to your house. So as a summary, DHCP streamlines network management. It assigns IP addresses to devices, making sure that the IP addresses and any conflicts and everything are all handled without you even having to worry about it. It also simplifies the process of connecting devices to a network by making sure that the network efficiency is overall just running smoothly. It's enhanced. And again, you just don't have to worry about it. All of these things happen behind the scenes. You don't even think about these things for the most part. If you don't know anything about networking, you probably have never even heard of this. And you are like, oh, wow, I didn't know all this was happening. But yeah, there's something that assigns the IP address to somebody that gives them access to your Wi-Fi. And that is called DHCP. All right, now we need to address what a network interface actually is. So the interface configuration legacy, meaning the old school version, and actually this is what's running on my current MacBook. So this is not legacy in the regard that it's no longer being used. There's still a lot of computers that use ifconfig, but this is the interface configuration that happens with this particular tool or command. So ifconfig, short for the interface configuration, is a command line utility that is used to configure your network interfaces on Unix-based operating systems. So for example, Linux or Mac OS. It creates those interfaces. It configures the network interfaces to the actual IP address. So it's been deprecated, supposedly, but it's still very much in use. So when I tried to run this just to test on my MacBook, and I ran IP, it didn't work. It said IP doesn't exist. When I ran ifconfig worked. So it's not as deprecated as they make it sound, and it's still very much in use. When you go to Windows, ifconfig is ipconfig, and it serves the same exact purpose. The simplest version of the command is to just type ifconfig and press enter, and it lists all the network interfaces that are on your system along with all of the current configurations, meaning the IP addresses that are assigned to them, if there are any network masks or broadcast addresses, and everything else that would be appropriate for that particular configuration. This is an example output right here. So ETH0 is the actual interface in question. These are all the flags that are attached to it. So it's up and running. It has the broadcast, so on and so forth, multicast. The iNet IP address for this is this piece right here. The network mask for it is this. So this is the subnet mask that we were talking about. And this is the broadcast IP address that's assigned to this particular network, right? So this is this is just a sample of the output of what would happen when you ran ifconfig. Now, if you wanted to configure the IP address, then you would do sudo ifconfig and then that specific interface that we were just talking about, and then the IP address that you would want for it, and the net mask that you would want, and then you would do up to just make sure that the IP address has been assigned to it, and the subnet mask is what it is, and then the up keyword brings the interface up, meaning it actually activates it, right? So if you wanted to take it down, you would just type down. But this is a configuration command. So you say, this specific IP address is what I want to assign to this particular interface, and I want it to be on this type of a subnet mask, and I want it to be up. I want it to start running, right? So this is what how you actually configure something like that. You don't have to necessarily do it because typically the DHCP protocol will do it for you. But in case you actually need to do it manually, then this is what it will look like to configure an IP address manually for any given interface, which is in this case the ETH0. And this is the detailed breakdown of everything that I just said. So maybe I just should like click forward and see if I actually have these notes in the future slides. So sudo would be running the command as a super user, which is the administrator privilege. The ETH0 is the network interface that you want to configure. So it could be anything that has to do with your interface. It could be ETH1. It could be typically not LO, which is the local host. You typically would not modify that. That ends up having the same exact IP address on every single machine, which is 127.0.0.1. So ETH0 would be the particular interface in this case that we're going to be configuring. This is the IP address that we're going to assign to this interface. This is the network mask, the subnet mask that we are going to assign to this interface. And then we want to activate the interface and make sure that it's up. And just like you can bring an interface up, you can shut it down or you can deactivate it essentially. And so without having to configure the IP address or anything like that, if you just wanted to make sure that this particular interface is active, you would do ETH0 up. If you want to take it down or deactivate it, you would just do ETH0 down. They control the state of the interface itself. When you bring it up, you activate it. When you take it down, you deactivate it. Bringing interface up or down, the usage itself as an example over here would just be exactly what we repeated in this particular case. And so these are just some examples. So ifconfig ETH0 up or down in this particular case. So in conclusion, in a summary, we know that ifconfig is supposedly deprecated, but it is not because it is active and running on my computer right now, on my MacBook right now. It remains a widely recognized tool for managing network interfaces on Unix-based systems and allows you to view the interface configurations, assign IP addresses, control the state of interfaces. And that is what ifconfig does. IP is supposed to be the modern replacement for ifconfig. It's part of the iproute2 package, and it basically does everything that we just talked about with ifconfig, except the command in this particular case would be IP. You would just do IP space A and press enter, or you would just do IP space address, so ADDR, and then press enter, and it'll just display all the network interfaces, very similar to what ifconfig would do, including the IP addresses, MAC addresses, and any other detail that is relevant to them. And this is what the example output looks like. So this is very similar to what we talked about previously. The local host right here is what this is at the very, very top right here. And the IP address, as I mentioned, for the local host on every single device that I have scanned and pen testing or anything like that, this is the local host IP address. So this one is universal across every single machine that I've ever messed with, okay? Then there's the ETH0, which is the actual interface that is being assigned an IP address on your Wi-Fi, on your local network. And in this particular case, this is the IP address for it, right? So this is your actual IP address for, or in this particular example, this is the actual IP address for this particular machine, right? And so this would be the broadcast address. And then where's their inet mask? We see the mask, or no? I think the mask is not available on this particular example, but you see the MAC address as well. You see so this is the MAC address that is connected physically to the Ethernet, and the MAC address can be spoofed. That's a whole other conversation. But MAC addresses are not permanent. Neither are IP addresses. You can also spoof an IP address. I don't know why I even said that. Anytime I think MAC address, I'm like, oh, MAC address spoofing. But this is typically what it looks like. So it's very, very similar to the ifconfig output. And in this particular case, what we're seeing over here is the MAC address as well. And honestly, in a lot of cases, when I run ifconfig, I also see the MAC address for my devices on ifconfig's output. So this is not just limited to the IP command itself. You have the assigning of IP addresses very similar to what we did with ifconfig, which would be sudo IP ADDR, and then you're going to add this particular IP address with the / of 24 to the ETH0 interface. And then there's going to be the breakdown of this. So I'm not going to try to explain all of it on this particular screen, but what we're doing is that we're assigning this particular IP address with a subnet mask, which is 24 bits. So meaning the first three right here, the first three octets are assigned to the network, and then the last octet is assigned to the host itself. And then so you're assigning that particular subnet mask to this particular piece. Actually, so we can actually see this right here. So instead of showing the 255.255.255.0, this is the piece right here that tells us what the subnet mask is. So in this particular case, it's saying that the network is assigned 24 bits, which would be 3 octets, which is what this represents right here, okay? So breaking it down, you have the sudo command that runs it as an administrator. You have IP address add, which indicates adding an IP address. This is the IP address that we're adding, and we're putting it with a subnet mask of 3 octets, which would be 24 bits. And then we're going to add it to the interface, which is this particular interface, the ETH0 interface, which is typically, for the most part, also what I've seen is that is the interface name that is assigned to the very first IP address that you get assigned on your particular computer. And the overall concept of bringing an interface up or down, basically activating or deactivating an interface, it also applies here. It's just the command is a little bit different. So it would be IP link set ETH up or IP link set ETH0 down. And this is how the whole thing breaks down. So up obviously activates, down deactivates it, but you're talking to the interface a little bit differently. And you're saying, link, I want you to set this particular interface up or down. I want you to activate it or deactivate it. And these are the examples of what it would look like if you wanted to bring something up or deactivate it and put it down. So displaying the routing information is mostly done so that you know what the paths that the network traffic is taking to reach various destinations. It includes the information about the default routes that it will take, the specific routes that it will take, and the interfaces that have been used. This is to try to troubleshoot any kind of connectivity issues and see if there is any individual connections that are being made along that particular path that the traffic takes to actually reach its particular destination. If any of those things are glitches, this is also information that can be used for security analysis and pen testing as well, but it's mostly used for network connection troubleshooting. So it displays the routing table, which shows the paths that the network traffic will take. And so this is what it looks like. This is the sample output for this piece. So you'll have this whole thing right here, and I'll actually break this down in a little bit further detail for you so you kind of understand what is going on. It's not, I don't think this is actually inside of the scope of the Linux Plus studies and the examination, but just to give you a good idea of what you're looking at when you're looking at the routing information so that your networking knowledge is a little bit stronger. So let's actually look at what this piece right here means and what all of these different elements represent. Okay, so now breaking it down in particular segments here. So the first portion was the default via 192.168.1.1 dev ETH0. So the default indicates the default gateway, which is used when no specific route for destination is found in the actual routing table. The via 192 yada 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 specifies the next hop address. So it'll go from the default gateway to the next address, which is going to be the IP address of the default gateway router that the traffic will be sent through. So it's going from this, it's technically just doing this. It's going to go from the gateway, but it's going to go as this IP address instead of the default gateway. And then this is going to indicate the network interface that's going to go through the traffic that's going to be routed through, right? So the default via, so this is going to say this gateway via this IP address on this particular interface is going to start traveling, right? So it tells the system to send any traffic that doesn't match a specific route in the routing table to the default gateway at this particular IP address using this particular interface. Now the next line is this piece right here, and we're going to just break this down. So we have this portion that represents a specific route for the IP address range, which goes from 1.0 to 1.255, where the 24 is the subnet mask, which would be this piece right here. So you should already know this. Now, dev ETH0 is the associated with the network interface ETH0 itself. Proto-kernel signifies that the route was added by the kernel, and we should know what the kernel is, right? So the kernel usually as a result of configuring the network interface. So it was added by the kernel. This particular route that we're looking at was added by the kernel. And scope link indicates that the route is valid only for directly connected hosts on the same link, which is the local network. So this particular piece, what we're seeing in this line right here, is only available for people who are actually connected to the same Wi-Fi, the same internet that this particular device is connected to. And then this is the source IP address. So this is the IP address to be used when sending packets to this particular subnet. So if we looked at it from the very, very top right here, you have the gateway saying that this is going to be my IP address for communicating. And then it's going to say the rest of it for this particular device that's connecting. So it's saying that this represents a specific route for this. So it's going to go from any of these to any of these. And then it's going to say that this is my interface, this is my actual device that's going to connect to it. This was done by the kernel, and it's going to be on the same exact internet that we're connected on. So the local network or Wi-Fi, this is what we're going to be located on. And then this is the IP address of the actual device, right? So it's not to be confused with this IP address, because this IP address was for the default gateway. This is the IP address that is for this particular device that is communicating with the internet. So when we combine both of these lines, traffic for any unspecified destination, so the default route, will be sent through the gateway at that address via that interface, and traffic that's specifically destined for this particular subnet will be routed through this particular interface using the IP address that was assigned to this interface. Again, this might be a little bit confusing. It might be a little bit overwhelming. We're not talking about networking. We're not talking about Network Plus, or at least not in this depth. I just wanted you to have this just so you can kind of see what this particular output right here kind of represents. And this is just a sample of what would happen when you run the iproute command. So in summary, even though ifconfig is supposedly deprecated, it remains a widely recognized tool for managing network interfaces. On Unix-based systems, it allows you to view the interface, so on and so forth, very similar to what is done with IP. Next on our list of tools is the Network Manager Command Line Interface, so nmcli. It's a command line tool, as the name implies, and it helps you manage the network connections on Linux systems. So it'll interact with the Network Manager, which is a system service for managing the interfaces and the connections to the interfaces. It's commonly used in desktop environments and provides a convenient way to configure and control network settings without a graphical interface, because the name is implying this is a command line interface. So nmcli interacts with your network manager, and it helps you manage the interfaces as well as the connections and so on and so forth. These are some of the commands. So if you want to look at the active connections on your particular network, you just type in nmcli connection show, and it'll show you all of the active network connections on your system, and then it'll show you the UUIDs for them, the connection name, type of the connection, device associated with each connection, so on and so forth. And then you have the particular output as an example here. So if we do the show, this is typically what it looks like. You have the name, so this would be the interface, right? So this would be the machine itself. This is the Wi-Fi router, and then you have the UUID for both of them, and then you have Ethernet for this guy, and then you have Wi-Fi, and then the device itself, and then the device name or the device ID in this particular case. So it's going to be Eth0, and then this is WLAN for this particular set of devices, the set of network connections here. So if you want to configure a static IP address using nmcli, you would go through this. Now, static IP addresses are IP addresses that don't change. So this is going to be a permanent IP address, right? So sudo nmcli connection modify on this particular interface is going to be an IPv4 address, and this is going to be the IP address that's going to be assigned, and it's a subnet mask of 255.255.255. So it has 3 octets, right? The command assigns a static IP with a subnet mask of 24 to the network connection ETH0. And this is our breakdown. So we have sudo, we're running it as an administrator. nmcli connection modify is indicating that we're modifying a network connection. It's going to be for this particular interface. So this is the network connection that we're going to configure. And then we're going to have the IP address and subnet mask that we're going to assign to it. And we're using an IPv4 version of the IP address. And then we're going to add it to this particular subnet, which is the 24. So the 24 represents the number of octets, right? So 24 divided by 8 would be 3, which means 255.255.255. I'm just repeating a bunch of things that you should by now know. So if you want to enable or disable connections, it's very similar to everything else we've done. So we are using the up and down keywords. In this particular case, we're going to say sudo nmcli connection up for this particular interface, or connection down for this particular interface, and we're going to bring the connection for that interface either up or down, activated or deactivated. And this is what that looks like right here. So nmcli connection up ETH, nmcli connection down ETH, yada, yada, yada. So if you want to view the status of the devices, now you would look at the nmcli device status, and it'll display the status of all of your network devices, whether or not they're connected, disconnected, or unavailable. And this would be what the example output for that look like. So the device you can see right here. So this would be the internet, this is the Wi-Fi, this is the loopback or the local host. And then the Ethernet is connected, the Wi-Fi is connected, and the loopback is not being currently managed, right? So if you want to list available all the Wi-Fi networks that you have for your particular connection or for your particular device. And this will probably be a really big list depending on how big your building is or who's around you. And then you'll just do nmcli device Wi-Fi list, and it'll list all the available Wi-Fi networks, like their SSIDs and the signal strength and security type. And this is what that output potentially looks like. So this is the SSID, which is the name essentially of the Wi-Fi. So you have my Wi-Fi and other Wi-Fi, and then there'll be AT&T, yada, 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 Spectrum, yada, yada, yada. The mode, right? And then the channel that it will be on, the rate, the speed of it, the signal. So if it has a signal of 70, it has a stronger signal and a stronger connection for what you have. Bars would be another version of looking at the signal. And then you have the security, which is WPA2 or WPA2 in this particular case. But these are the Wi-Fi securities, the Wi-Fi encryptions. And WPA2 is one of the more common ones that are modern and most secure compared to all the legacy or outdated versions of Wi-Fi security. If you wanted to connect to any of those networks, you would run a sudo command with nmcli, and you want to connect to the device Wi-Fi, and you want to connect to it, and this would be the SSID. I guess that would be the name in this particular case. And then the password would be password, because most often than not, you actually need the password to connect to a Wi-Fi. And then it'll just connect to that Wi-Fi using the provided SSID and password that you have given to it. And this is the particular usage here. So you will replace SSID with the actual name of the Wi-Fi, and then you'll replace password. So in this particular example, you're connecting to this particular interface, which would be, for example, my Wi-Fi in this case. And then from there, you will provide the password that would be inside of the password quotation, and that'll be the actual password for that Wi-Fi network. So in summary, the nmcli provides a powerful command line interface for managing network connections on Linux systems. It allows you to view and modify connections, assigning static IP addresses, control connection states, and of course manage the Wi-Fi networks. So that is the power of nmcli. Now on to troubleshooting. So ping is a very useful utility. It's used to test the reachability of a host, so a computer or server. So you basically ping the IP address, or you ping the website. And you can also measure the round trip time for the messages that are sent to that, to just establish how strong the connection is, or how quick that particular host is to respond to you. And when you send it, you literally just say ping, and then you give it the IP address. And then what it does is it'll send a bunch of Internet Control Message Protocol packets. So ICMP packets. Anytime you see ICMP, think ping. So it'll send Internet Protocol packets, and there's something called the ICMP flood, and this is actually a way that you can do a DDoS attack, or a DOS attack, which is a denial of service attack, by flooding that particular host with a bunch of requests with ping. And because it's getting so many requests, you may take it down and it may go out of service. So this is something that you can see regularly. ICMP will be associated with ping. So just keep that in mind. If you see ICMP, that means they're trying to ping it. So it'll send the request to the specified destination, which is either the host name or the IP address of that host. And then the receiving response will tell you whether or not that thing is up. So typically, if it's not up, it'll respond with some kind of a host is down or something similar to that. If it is up, it'll just say connection was established and the amount of time that it took for that connection to get established. The round trip time, so the RTT, is where the measurement of the time that it takes for the echo packet to actually go to the host and reply back to you. So it's the round trip. Very, very simpler. Very simple to understand. Packet loss is the number of packets that were sent, but then they got lost somewhere in the process, right? So the network connection or other issues. So if it sends a packet and it didn't come back, or if it sends a packet and it wasn't received, it was lost in the process, in the transition, in the transport, so to speak. If that happens, it'll also report that back to you, and this will help you understand the strength of the signal to that particular host and how reliable that signal is. The basic usage looks like this. So you just say ping the host name or the IP address. So ping google.com. That's an example. And or ping, 15 whatever. I'm just coming up with some kind of IP address. But you basically just put in ping and then either the host name or the IP address itself, and it'll ping it for you just to tell you whether or not it's up. For the most part, the reason why we use ping is just to see whether or not that host is actually up. And when it is up, this is what the result looks like. So it'll just say 64 bytes from this particular location was sent, and meaning that actual host, right, the host IP address, there were 64 bytes that was sent back to you. And this is the response time, which was 12.3 milliseconds, and the next one was 11.8, 12.1. But essentially, this is exactly what it looks like when a host is up. When it's not up, you don't see anything like this. It'll typically just say connection was not available, or host is down, something along those lines. But if you see this, and then if you just see this every second or every 1 or 2 seconds, and it just keeps coming, because typically what happens is that unless you stop it, so you would have to do Control C, which is actually, I think, on the next slide. So we have the breakdown here for what we just saw. So we have the 64 bytes from the IP address, which was the reply that we received from that IP address, which was Google in this case. The sequence of the packets, so it starts at 0 and it'll just increment by 1. And then we have the TTL, the time to live value, indicating that the maximum number of hops that the packet can take before being discarded. And then you have the actual time. This is the round trip time for that packet to be received. And so if you want to stop it, right, so you would do Control C, which cancels that request, unless you actually say that you wanted to send out 10 packets, for example, or 5 packets, just to make sure that it's up, which is, I think, would be done with the -C for count. And then you would do that so that it'll run, and then after 10 packets, it'll stop running. But if you just do ping Google by itself, it'll keep running until you stop it, and you would have to do that with Control C. Additional options. Oh, there we go. This is the count right here. So -C is the actual count. I just keep getting ahead of myself. So specifying the number of packets that you want to send, and then after 5 packets, it'll stop pinging. And then you can also set the interval between the packets to be sent, and that you would do that with the I option. And it'll be the number of seconds that it's gonna wait. So if you don't want it to show up on their intrusion detection system that you're pinging them, and if you want the pings to wait 5 seconds or 10 seconds, you can do that just to make sure that you still have the connection and it's a live connection, but it won't show up on their IDS or their network intrusion detection system as somebody's massively pinging us and trying to see whether or not we are up, whether or not we have service. You have some additional options here. So we were talking about flooding, right? So if you wanted to flood this particular case, what happens is that you are trying to potentially do a denial of service attack. So if you do an F option, so if you do the -F option, it'll flood, meaning it'll send as many packets as fast as it possibly can. And that, the milliseconds that you saw will be much, much smaller. So it'll be a massive flood of packets that will be sent to google.com. And in this particular case, I don't think Google will even care. But this is typically done to slow down the actual host that you're trying to reach, because you want to either test their ability to handle a flood of traffic, or you want to actually do a denial of service attack and stop them from operating. In summary, the ping command is a vital network troubleshooting tool because it actually tests the connection between devices and makes sure that the device is actually up. It also tests the amount of time that it takes for packets to go back and forth to see how reliable that connection is. And if you have any kind of a network issue, it'll provide information to you about packets that were lost in the process, the length of time that it's taking for the packets to be sent and come back, and of course, if there is a status of the connection, meaning if the connection is actually up and whether or not you can send a ping to it and receive something back. Traceroute is the type of tool that helps you track the route that some piece of traffic is taking or a packet is taking to go to a particular location. So when you run it, it'll send a series of packets to whatever the destination IP address is, and it'll gradually increase the time to live values. And what that does is that it determines the maximum number of hops or the number of internet routers that the packet can traverse, right? So when you send something out, it'll go through multiple Wi-Fi routers or multiple internet routers before it actually lands at its particular location. And it's rarely ever the same number of hops. So it could be 1 hop, it could be 10 hops, right? It just depends. When you increment the TTL value, it'll start at 1. And then it'll travel only to the first hop before it gets discarded. And then with each packet that goes after the fact, the TTL value is going to be incremented by 1. So meaning it'll take 2 hops on the second run before it gets discarded. And then it'll take 3 hops on the third run before it gets discarded. And the number of hops, again, will be the connection to the routers, the connection to the destinations at the kind of the intermediary connections before it actually lands at its final destination. It'll send ICMP packets, ICMP messages. So when the packet is discarded due to the expiration of the TTL, it'll handle the packet sent as an ICMP, which will give you the time exceeded message back to you as the source. So it'll include information about the actual router that it was trying to connect to, allowing traceroute to identify the hop that did not make it, the hop that was discarded along the way. And then when it completes the path, it'll keep going, right? So the process itself will continue until it actually reaches the destination and completes its path, and it'll tell you what the maximum number of hops that it took to actually get there. When you get the information from each hop, traceroute will actually construct the route that was taken by the packets. And this is for, again, to try to measure connectivity and to try to measure the strength of a network and the strength of your particular host trying to connect to another host, the strength of the internet connection that you have and the routers that you have, and how long it'll take for something to get through. If something has been discarded along the way, that is something that you think about. If there are too many packets that have been discarded along the way, that's something that again is kind of like a red flag that is like, okay, we need to troubleshoot this connection because for whatever reason we're dropping a lot of packets. A lot of packets are being discarded. And if the paths are completed, then traceroute will actually record that information for you, and it'll show you how many of your pings that were sent out, how many of the packets that were sent out were actually reaching its destination. If you want to run it, it's very similar to running the ping command. So you just do traceroute google.com for this particular example, or you could say traceroute and ipaddress.com. And it'll start sending packets out, and it'll start tracking the number of hops that it takes and whether or not those things are going to be discarded and the connection is actually being established, or whether or not those things are going to reach the final destination that you want it to take. And then when it does, it'll show you the route that it took and how many hops that it had to take in order for it to get to that particular destination. So when you run it, this is the kind of output that you're going to see, right? So the very first one is the very first packet that was sent. So this is the TTL, right? And so it went and it took a millisecond, and then the second attempt it took 0.789 milliseconds, and the third attempt it took 0.699, and then it'll send 2, and then in this particular case 1.62 milliseconds, and it incremented. It was a longer time, obviously, because it's sending longer packets. The third one, it sends 3, right? And then obviously the time in response is going to be longer because more packets are being sent out, right? And so this is what that actually means. So this is kind of the breakdown of what we just saw. So the very first one that we saw, the IP address that we see at the beginning, that's the IP address of the first hop router. And this is the first hop that it took. The response time the round trip time for these 3 packets that were sent to that first hop were the shortest that we got because it was a single packet, right? The lines after the fact were the IP addresses and round trip times for each of the hops that we had along that particular path. And if we wanted to let that keep running, because that ultimately it'll just keep running. So this is, in this particular case, it took 3 hops and it stopped running. That's what we can kind of assume. But more often than not, you'll see a few dozen, maybe it'll be like 20 something hops that it'll take. And then the data points for each of the routers that it was connected to before it finally landed at the location that you wanted it to land, which is in this particular case, the 142.250.74, etc., etc. This is the IP address that was the first hop that it took, and then it got back to this particular guy, and then this guy responded back to us. In this particular case, there was only 3 hops that were taken. It went from us to them, and it was only 3 hops, which is very short, to be brutally honest with you. More often than not, it doesn't take only 3 hops to go from where we are to where this particular location was. So it just traces the route that your particular gateway took to get to the actual IP address of Google in this particular case, right? If you want to try to specify the maximum number of hops that you want the traceroute to take, it'll be the M option for maximum, and you can give it the number of hops that you want it to take before it gets to google.com. And then you can also set the number of packet bytes, the size of the packets that you can declare, which can in this particular case be done with the -P option right here. So if you want to dedicate the maximum number of hops, you would do it with -M. If you want to dedicate the size of the packet, you would do -P. In summary, we have the traceroute command. That's a powerful tool to diagnose network connectivity issues by identifying the path that packets take to reach a destination. It helps to pinpoint where the delays or failures are along the route by looking at the actual timestamps and which packets were actually discarded. And then it makes it very valuable for you to to troubleshoot your network connections, because you will see how many packets were dropped, what was taking the longest amount of time to get to a location, and the specific routers that were responsible for those network connection drops or the delays in the connection. Netstat, short for the network statistics, is another command line tool that'll display network-related information like the actual connections that you have, the routing tables, the interface statistics, masquerade connections, this is a really fun word, and multicast memberships. It's used very regularly for monitoring and troubleshooting network issues. And the basic usage would be to run it with a variety of flags. So if you want to view the active listening ports using netstat, you can run it with these various flags that you have right here. So T would be TCP ports and TCP connections. U would be UDP ports and UTP connections. L would be only the ports that are in listening mode, and then N would be the numerical addresses instead of the host name. So you would get the IP addresses instead of the host names in this particular case. So if you just did T, it'll only show you TCP connections. If you just did U, it'll only show UDP. If you didn't include L, it would show if it's listening or not listening, right? So this is essentially looking for all of the connections, TCP or UDP, that are in listening mode, and then you want to see the IP addresses for those particular connections. So this is what the output potentially would actually look like. So you have the protocol, which is TCP, TCP6, UDP, UDP6. So whether or not it's TCP or UDP, this would be right here. Received and send queries, the local addresses that are assigned to them, as well as the ports that are assigned to them. So this is port 22, this is port 80, which is the HTTP server. This is the secure shell server. These 2 ports, I don't know, actually, they are UDP ports, we can understand that, but I haven't memorized what they would stand for or what service they would stand for. And then these are the foreign addresses, if any, and the state that they are in, which would be listening state. So the TCP ports on these particular addresses, on our local addresses, are actually in listen mode. These UTP ports are not in listen mode. SS is the socket statistics, which is the modern alternative to netstat. So it'll provide essentially similar information, similar functionality, but supposedly it has better performance and it has a more detailed output. So it's also part of the IP Route 2 suite, which was very similar to what we dealt with IP itself. And it's preferred in a lot of Linux distributions, and you run it like this. So very similar to what we just did, right? So you just do, instead of netstat, you would do ss, and then you would give it the flags that you want it to run, and exactly the same that we had before. We have the TCP, UDP listening ports, as well as the numerical addresses that would be resolved for them, and this is what the output looks like. So similar to what you saw previously, except instead of the listen or unconnected state right now that we see here, that was previously at the very end right here, it's at the very beginning right here. It'll give you the send number of packets that was sent to them, the addresses and the ports that are connected or listening, and then you have the peer address and ports that would be on the other side. So this is the example output for the ss command, the what is it called again? The socket statistics command that we use. So to get some additional options here, we can look at established connections. So these would be TCP connections, show active established TCP connections. This would be all TCP connections listening and established, which is right here. So you can, again, you can do singular flags or options. You can combine the flags and options. You can also look at process information. So TCP, UDP, give me the network, so name, resolution, deny it. So I just want to see the IP address. I want to be in listening, and then I want to see the PID, the process ID, and program name also as well when it comes down with this. So you get the process information that would be connected or running in this particular case. So we got everything. We just added that last flag to it as well so that we can get the process information. In summary, we have both netstat and ss, which are very powerful tools for monitoring and troubleshooting our network connections, and they'll give you a lot of great details, whether or not it's been connected, if it's in listening, with the IP addresses, so on and so forth. Netstat is technically older. It's very well known. SS is the modern version, but they both offer essentially the same information that you're looking for. I did like the output of SS a little bit better because it seemed a little bit more friendly to the eye, but for the most part, they give you the same information that you would need. And finally, we have arrived at our network fundamentals conclusion here, which is going to be our firewall settings. So the UFW, which is the Uncomplicated Firewall, this is the most common. It's like the firewall management that is the simplest that it possibly can be via the command line. So it's straightforward, and it creates and manages iptables firewall rules, and it's particularly popular on Ubuntu and all of the derivatives because it's simple and it's very easy to use. So this is just an example here. If you want to enable the firewall, you just do sudo UFW enable, and so it activates the firewall, and it enforces any and all of the configured rules that you have for this thing. So once it's actually been enabled, it's going to start running, and it's going to filter any of the incoming or outgoing traffic based on whatever the rules that you have that's been set up. So if you want to disable it, you would do the same thing. Sudo UFW disable, and it will just deactivate it, and any of the traffic that you previously were filtering is now not going to be filtered anymore. If you want to allow a service, so in this particular case, SSH represents port 22. So you would do sudo UFW allow SSH. So it allows traffic for that specific service, which is in this particular case SSH, which would be port 22. And SSH stands for Secure Shell. So it allows for somebody to connect remotely to the particular device that this UFW is running on. If you want to deny it, you can do it via the port number as well as the service. So you could say deny 80, which would be the HTTP traffic. And in this particular case, it'll block HTTP traffic on port 80, which prevents access to web services running on this particular port. Then you have the status of the firewall. So if you wanted to see what the current status of it is, whether or not it's actually running, and what all of the active rules are. So if there are any deny rules, if there are any allow rules, you can see all of those things by just running a simple status command on this. And I'll just show you which one of the rules that you just try to apply, for example. So if you apply a deny port 80 or deny SSH, if you did those things and you run a status, you can check whether or not those things are actually active and currently running. You can do a port allowance in this particular case. So similar to what we did with the service, right? We can do the same thing with a port that's associated with it. And then you can say allow 443, which is HTTPS, so this is for like the internet, and port 80 is HTTP, but HTTPS is just a secure version, meaning it has TLS or SSL traffic, so that it's actually encrypting all of the communication with your browser, and it would be a TCP traffic port, right? So it'll allow all of the 443 TCP traffic that is typically for the communications with browsers. UDP traffic is usually for viewing video. So if you don't allow UDP, or if you don't specify that you want UDP, or if you actually deny 443 UDP, you may deny any kind of video viewing that may happen on that web browser. But in this particular case, we're allowing port 443, which is for web browsers, secure web connections. We want those things to be allowed, and then we're going to allow the TCP protocol associated with them. If you wanted to deny the UDP traffic of port 25, which is used for the simple mail transfer protocol, it's typically used for mail. It would be done by just doing a simple deny command and then doing 25-UDP, and then it denies all the UDP traffic on that port, which is used for simple mail transfer, for emailing. Basically, that's what port 25 has done. It's the emailing port that is typically used on our network. And then you can delete rules, right? So if you had previously sudo ufw allow SSH, and now you want to delete that rule, you can just say delete allow SSH. It's very simple, right? It's very intuitive. The syntax is actually quite easy to use. And then you can delete the deny rule in a very similar way as well. So if we denied port 80 traffic, then we would just say delete that particular deny 80 rule. And that way, now you have deleted that rule, which means that now you're allowing the port traffic, the port 80 traffic, right? And then you have logging on. So if you want to enable the logging that's being done from the firewall, which highly recommended that you log everything that happens with your firewall, you would just enable the logging. So you would say logging turned on, and it'll log all of the firewall events that are happening. And this, I mean, I can't imagine that you would run a firewall without actually collecting firewall logs. So it's very important to have the logs of the traffic that's being coming through. And if people are trying to access your port 22, for example, your secure shell port, when you've done a deny access to that port, and then you keep getting attempts to hack into your port 22, or maybe you have allowed port 22 traffic to come in and somebody's trying to log into your port 22, but they keep using the incorrect password to log in, so you feel like you are now a victim of a brute force attack against your port 22, which is for remote connections and remote control. So it's very important to turn on logging, and then you can of course disable logging by just doing logging off. And now there's a version that's kind of an all-encompassing rule, which would be a blanket type of a rule, which would be allow all incoming. So it's actually not allow all incoming, it's just allow incoming. But what it does is that it allows all of the incoming traffic to your particular network, or I would say in this particular case, your device, your computer, right? So you want to say, hey, I want you to allow all of the incoming traffic, which means anybody and anybody could try to communicate with your particular computer on any port that you have open, which includes your port 22, it includes your DNS server, and it includes all of the other 65,000 ports that would be available. If you want to deny all of the incoming traffic, you could do the same thing, except just use deny instead of allow, and then it'll deny any connection that's supposed to come to your particular device. This is kind of difficult to do because then you won't be able to connect to the internet, for example, via port 80 or via port 443. You won't be able to get any of the responses from Google or from YouTube if you're denying all of the incoming traffic. So just keep this in mind. It sounds like it might be a good idea, but you can say deny all and then go and do allow of specific ports because you want to access specific services, right? So you can dedicate, the port 80 allowance and dedicate the port 443 allowance and then deny everybody else, right? And in the same way that you would deny all incoming or allow all incoming, you can do allow all outgoing traffic. So any request that you make out to the world, we want to make all of those requests allowed. And then same thing, deny all of the outgoing requests. And this is something that maybe you don't want people to be able to connect to the internet, for example, because they shouldn't be able to connect to the internet. All they need to do is just work on their local computer. Schools sometimes do this because they don't want people to be able to connect to the internet, and they just want somebody to just use the computer for their schoolwork. So this is the type of stuff that they would put. So you're denying all of the outgoing traffic that's going to come from that particular computer. So in summary, it's a very simplified process of managing the firewall rules for traffic, and you can have very intuitive commands like we just saw, which would be enable or disable or allow or deny, and then you can do it based on the service name like SSH, or you could do it based on the port number like port 22, which would be the same port for SSH. So you could allow port 22, you could allow port 443, so on and so forth. iptables is another command line firewall utility that will allow admins to configure network packet filtering and address translation and a lot more other things. So it's a little bit more complex version of the uncomplicated firewall that we just went through. It operates with the Linux kernel to provide detailed control over how packets are routed. So the core tables in iptables can be filter. So this is one of the main ones. So it filters packets, right? So you can handle all the incoming packets by input. You can handle the packets that are routed through your device by forwarding. And then you can handle all outgoing packets by using the output chain. So you have the input chain, the forward chain, and then you have the output chain. And these are all done through the filter. And then you have the network address translation, which is for masquerading and port forwarding. So it doesn't show your actual IP address. It'll use a different type of IP address so that the world doesn't see your actual IP address, which is actually very useful for masquerading and essentially kind of disguising your IP address. And then the chains would be pre-routing, so altering the packets before actually routing them out, post-routing, altering packets after routing them out, and then you have output, meaning altering all of the packets that are generated by your device itself and being sent out to the world. And what it does is that it essentially changes the source IP address in this regard. It'll change the source IP address when it gets sent out to the world to whatever the masqueraded, the disguised IP address would be, so that when if it's ever intercepted or your traffic is sniffed by somebody, they don't see your actual source IP address. They see some other IP address that wouldn't be you, so they can't particularly attack you. You have Mangle, which is used for specialized packet alterations, like changing the type of the service that's being requested. For example, SSH or UDP or TCP or something like that, or marking of the packet. So you can again pre-route the alteration, so you can alter the incoming packets before it's been actually routed. You can alter the outgoing packets by using the output chain, and then forward, input, or post routing would be available for other types of modifications as well, and that's what Mangle does. So if you want to look at what the current rules are, you would just do the sudo iptables with a capital L flag, and it'll list all of the current rules for the filter table. It shows the rules for the input, forward, and the output chains. And so this is what the example output would look like. This is a little bit, it's kind of one of the more shrunken displays that I have on my screen. So hopefully you can see what I'm doing. You can also just zoom in a little bit on your screen. But so we have the chain input here, and the policy itself is to accept it, and then we have the chain forward, and the policy is to accept it, and the chain output, and the policy for that is to accept it. And then it gives us what the destinations would be if there were any, and then the accept all in this particular case from anywhere to anywhere these are the particular rules. So this is the current display of what it would look like if we just listed this with the iptables command. So this doesn't necessarily mean much because there isn't very much data that is reflecting on these exact rules that we have over here, because with the exception of this one right here, there really aren't any rules. It's saying from anywhere to anywhere except everything. That's basically the rule that we have over here. So the basic commands that we can run would be to allow the traffic. So in this particular case, we have iptables -a, and then input, and then the protocol would be TCP, and then the destination port would be 22, and then the accept would be the rule. So it adds a rule to the input chain that'll allow TCP traffic on port 22, which is used for SSH. Then you can have the explanation of this mofo right here. So you have the -a input, which appends the rule to the input chain. You have the -p-TCP, which specifies the protocol as being the TCP protocol. D port would be the destination port as 22. And remember, this is an input rule. So this is actually all of our incoming traffic. And the J accept would jump to accept the target, allowing the actual traffic. Okay. If you wanted to block something, then you would just do the drop as the rule itself. So everything else exactly stays the same. So in this particular case, they're doing it on port 80, but the final rule would be to drop the traffic that's coming. So in this particular case, this is again input traffic. So it's incoming, and it's on the TCP port 80. And the very last thing is the big piece right here. That is the actual rule itself, which is to drop the target, blocking the traffic that comes through for port 80 as the destination port. If you wanted to delete something, you would do the -d, which is the deleting of the input rule from the input chain, right? So in this particular case, it's the TCP protocol on port 80, which is the drop rule. So the same exact rule that we just actually added, we are now deleting it by, instead of appending, which was the -a that we were doing, we're just deleting it from the input chain, and everything else stays exactly the same. So the rule was to drop all the traffic from port 80. Now we want to delete that rule so we can allow the traffic on port 80. And so if you want to save a rule, you need to save it to the configuration file that is stored inside of the etc directory. And you would do that etc iptables. So assuming that you have iptables installed, and then there's the rules.v4, which is the actual configuration file. So you will take everything that you just did, and then you will do sudo iptables save, and then you would forward that. So you should remember what we did with this operator. It sends this particular output, and it sends it to this specific path, this particular file that we have, which is the rules.v4 for iptables. If you want to restore a rule that was deleted, you can then go ahead and pull it from the rules.v4 file that you just did, and you're restoring. So this one was saving, so you're doing iptables save, and you're sending it to that configuration file. This one, whoops, wrong direction. This one, you're using iptables restore, and you're restoring it from the iptables rules configuration file. If you wanted to view a specific table, you would just use the T, which is for the table, the NAT table, which is our network address translator table, and then it's going to list all of the rules for our NAT table. So you would do iptables again, and then you just want to list the table. So that's what -t stands for. And we want the network address translation table, and we want to list all of the rules for that particular table. So it's a powerful, flexible tool. So obviously it's a little bit more complex than what we just saw with UFW. It has a lot of rules that work for a low-level environment, providing extensive control over the actual network traffic handling. You can also configure the rules for filtering packets and translating network addresses, modifying packets, so on and so forth. So those are the features that are expanded upon that are not available in UFW. So UFW doesn't, protect your IP address by changing the IP address on its way out, which is the network address translation. So UFW doesn't do that, right? UFW doesn't do the mangling that is available on iptables. So it is a little bit more complex to work with, but it also has a lot more functionality than UFW does. All right, now on to a very important chapter, which is the security and access management chapter. And the very first section of this is going to be on file system security. The first portion of file system security is going to be chroot and the concept of the isolated environment and something called the chroot jail. So first, chroot stands for changing root or change root. It's a powerful Unix command, and it changes the root directory for any current running process and its children processes. So we're talking about the parent process and its children processes. When you change the root directory, effectively you're isolating a subset of the file system, and you create what's known as the chroot jail. That subsystem, that isolated version of the subsystem, ensures that any process that's running within it can't access files outside of that specific isolated environment, which means that it enhances the security and the control of that specific system, as well as the directory or the file system that has been isolated. So essentially what you're doing is you're taking one specific file system, or let's say one directory and all of the contents within that directory, and what you're doing is you're isolating it so it's separate from the rest of the file system hierarchy. And then from there, you're going to ensure that not only is the rest of the file system protected from what goes on within that isolated environment, but everything that's inside of that isolated environment is also protected from what's going on outside of it, inside of the rest of the file system. So essentially the isolation component from it, just that specific isolation component, guarantees security for the isolated environment as well as everything that's sitting outside of that isolated environment. A better way to break this down is to look at the question itself. So why would we use this? Because when you isolate something, when you isolate an application in a chroot jail, which is that isolated directory and everything inside of it, what happens is that it limits the damage that any potential untrusted or compromised programs can do, and vice versa, because those untrusted programs can't see or interact with the broader system, right? So I'm going to show you a visual of this real quick. Okay, so here's the example that we have, the visual that we have. So this is the standard hierarchy right here, right? So this is our actual system root, as well as the binaries, the home, the system, so on and so forth, right? And then inside of the home, we have this one particular user who has all of their contents. But what has happened is that we've done chroot, we've put all of their contents inside of a chroot jail, so to speak, and we've imprisoned them. And now what's going on is that everything inside of this red box is completely separate from the rest of the system. Meaning, if this particular user downloaded something that they shouldn't have, if they clicked on a link they shouldn't have, whatever they did in their particular environment is protected. It's isolated, right? It's isolated from the rest of this environment, meaning our actual root and the binaries and everything else that's inside of our main system is not affected by what's going on inside of this jailed portion. And that's really the big significance here. Essentially, we've created a sandbox type of an environment, which anything that happens for this user in their isolated environment, it might affect their system. I mean, it probably will affect their file system. They probably might lose the contents inside of that, or the hacker or somebody who got into their file system may have access to everything that's going on inside of this isolated area, but they won't be able to leave this isolated area and go inside of this root portion, which is very important because this user, maybe they don't have elevated privileges, and we don't want them to, if they do something wrong and if they get hacked, if somebody exploits this particular user, we don't want that malicious attacker, that malicious actor, to be able to get out of this environment and actually go inside of the main environment that has root privileges, and they can do some serious damage, get access to certain materials that they otherwise would not have had access to. So this is the whole this is the visual concept of what it means to create a chroot jail. There are also other reasons why chroot is actually useful. So apart from security, if developers want to create something and test it in a controlled environment before deploying it into the production environment or deploying it to the rest of the company, so to speak, they can do that safely inside of a jailed or imprisoned type of an environment. They can test their applications and any configurations that they want, and really testing out the software that has different dependencies or libraries that it needs for upgraded versions, so on and so forth. So it's actually very useful in the development context as well. And finally, the access and repairing of the systems from a rescue environment, meaning if something has happened in incident response and the main system is unbootable, administrators can use chroot to access and repair those systems from the rescue environment because something may have happened and there's a crash or some kind of a something that they need to recover from, essentially, so that they can go back to what's known as business as usual. So there's a recovery point, and usually they take those images every time that they do a backup, where they would have hopefully frequent backups of the most recent recovery point, and then administrators can actually use chroot to be able to access the system itself from what is known as the rescue environment, which is essentially a jailed environment, a chroot jailed environment, and then they can hopefully recover the system. So the use of this command first requires that you actually create a directory that will serve as the chroot jail. So we've already covered how to make a directory. So you would make a directory and you would need to use sudo because you're going to use this particular directory in an elevated privilege environment so that other people can't interact with it without having sudo access. So you would create the directory using sudo, and then whatever the path of the directory is, this is what we're going to use as our actual jail environment. And then you're going to populate that jailed environment by either copying or installing the necessary binaries, libraries, and files into that particular environment. So you would create the environment, and it could be what we saw from that visual example. It could be something that belongs to a user, and then you would populate the contents of that directory with the libraries, the files, and binaries, everything else that would be necessary for that particular environment to run. And this is the basic population of it that happens, right? So in this particular case, they're copying bin bash to that directory. They're copying recursively everything that's inside of the library and library 64, and everything that's inside of the user. All of that is going to be copied to the new directory that's been made, which is the jailed directory, right? The imprisoned directory. I like saying imprisoned for whatever reason. But so all of the contents of everything that needs to be used for that specific jailed environment, it needs to actually be copied into that environment. So it's this part is very simple. The R command is a recursive command, meaning it's taking everything inside of the library as well as all of the subdirectories and the contents of those directories. All of those things are going inside of the jailed environment, as well as all these other examples as well. So what you want to do is ensure that the directory structure within the chroot jail mimics the standard Linux directory layout, essentially meaning that you would need the binaries as well as the system binaries, all of those other things to be able to make sure that this actually works. So essentially, whatever you would need in a regular environment, in a standard Linux directory layout, whatever you would need in that standard layout for your particular environment, you need to make sure that it also exists inside of this jailed environment, because it is being isolated from the rest of the system. Once you've transferred everything inside of the jailed environment, then you just use the chroot command to change the root directory for the current process to the specified directory. So what you would do is just run sudo chroot, the path to the actual directory that we've created, and all of the contents inside of it, right? And so what that does is just changes the root directory for the current session to that particular directory, meaning for when you're logged into the current session inside of that Linux machine, once you've created this jailed environment and you put all the binaries and everything that you would need in order for it to run, then you change the root to that particular directory. And for the remaining session that you're logged into, it's going to act as if this directory is your actual root directory. And if you want to run anything and test any particular development upgrades, or if you wanted to open up a file attachment, for example, to see whether or not it runs properly or if it's malicious or malware or anything like that, you would do it inside of this particular directory to protect the rest of the system from it, or to test whatever you need to test without affecting the rest of the system. And this is a full workflow from beginning to end. So you have creating and populating the directory itself. So you have the make directory, and then this is going to be the name of the directory, and then you're going to copy everything that you need for that particular directory into it, which is going to be, in this case, these are all the various options that it can possibly be. So you're going to have my chroot, and then inside of my chroot, you're going to take the bin bash, put it inside of the bin. The lib is going to go inside of the root, and then the other piece is the 64 version of it is going to go inside of the root as well. And then you're going to change the environment that you're in to that particular environment, right? So you're going to do chroot, my chroot, and then you're going to run it, and that's it. And then once you're inside of the chroot environment, you just want to make sure that everything is actually running as it should. So you can run something like ls and the /, which means that you're trying to list the contents of that root environment. So when you do the /, you're essentially listing the contents of the root directory. And if you have done everything correctly, you should only see the contents of this new root environment instead of everything that you would normally see when you look inside of the root directory. So it should technically only just be these pieces right here, right? Because we copied all of these things, so you should only see the bin and the lib and then lib64. Those should be the only things that you see once you run this ls command to see what's inside of the root directory. Some considerations and best practices to keep in mind. So you want to keep the chroot environment, the jailed environment, as minimal as possible, making sure that you only have the stuff that you actually need, all the necessary binaries or libraries or software, anything like that, to just make sure that you've reduced the attack surface. If you copy everything that's inside of your normal environment inside of the jailed environment, it's kind of defeating the purpose of creating this isolated environment. So you only want to use the things that you actually need for that exercise, because again, it's only for that session anyways. And once you're done with that session, you can reuse it. It's not like you can't reuse it. But for that particular session, you should just only be using the things that you actually need. Make sure that all the file permissions within that jail are set correctly to prevent any privilege escalation attempts, and the escape prevention tool to make sure that the person, if in case anybody has actually attacked that particular jail directory, to make sure that they can't escape, essentially. You want to avoid running any services or granting access to tools that can allow processes to escape the chroot jail, which goes back to the very first point, which means only include the necessary binaries. So you don't want to give access to, or you don't want to copy any binaries inside of the jail that would potentially grant the attacker an escape route, right? They don't want to have a vector to get out of the jail and then get into the rest of your system. In summary, chroot is a very valuable tool for creating an isolated environment in Linux, essentially creating a sandbox for yourself, which enhances the security by restricting programs to a specific part of the file system, and is commonly used for running potentially untrusted applications, like we said, development and testing, as well as system recovery. So this is actually a very useful little strategy that comes embedded within Linux, and you can essentially turn any new directory that you've created into this little sandbox environment to protect the rest of your system from anything potentially that may go wrong, or just if you wanted to test something. So you don't even necessarily need to worry about hacks or anything like that. A lot of times you just want to test a new development or a new upgrade in the code, or a new upgrade in the software, so on and so forth. And you just want to make sure it doesn't affect the rest of the system and wipe something on the system, or crash the system, or accidentally delete data, so on and so forth. So it's a very useful tool to create an isolated environment, also known as a sandbox type of an environment. All right, now we're going to take another look at file permissions and ownership, and this time we're going to dive a little bit deeper into this particular concept. So as you should already know, there are different levels of file permissions that we can apply to something, and there are different groups that can have ownership as well as access to any of the files or directories or anything that exists on a particular system. The three different categories would be the owner, which would be the user, or any other user. So it falls under the other category as well. But there's the particular owner, which would technically be a user. There's the group, and then there are others, and then the others would also considered to be users, and they could also be considered to be the group that may have access to it. So we have these three levels of ownership or access, okay? And then these three levels also have three levels of permissions, which is the read permission, the write permission, and the execute permission. And so if we remember, the read permission has a numerical value of 4, the write permission has a numerical value of 2, and the execute permission has a numerical value of 1. So if you had all of these turned on, you would have a value of 7, right? If you only have the read and write, you only have a value of 6. If you have the read and execute, you have a value of 5, so on and so forth. So these are the permissions, and then they can apply to any of these particular ownership categories, okay? So the first one that we want to think about in this case is just looking at the breakdown of what these things are again, and then looking at what these particular breakdowns are again, just to kind of give you an idea here. The very first character, which is represented by this dash right here, if it is a dash, it is a regular file. If there's a D right here instead of that dash, it means that this particular item is a directory, and then an L would be a symbolic link, so on and so forth. So this particular item, this very first character, represents the type of the file that it actually is. The next three characters represent the owner's permission. So in this particular case, there's a read, write, and execute permission that has been attached to this particular item. And then the following three characters represent the group permission. So it is read, no write permissions, but only execute. And then this would be the other category, which is read, no write permission, and execute. So the group as well as the others category both get read, no writing permissions, and execute. And writing represents modification or writing to the file, so on and so forth. So you can read the file or you can execute the file. You can read the binary, you can execute the binary, so on and so forth, but you won't be able to write to it. You won't be able to modify it, okay? That's what this particular example represents. Knowing this, now we can look at what it means to change the permissions of something, right? How to change the permissions of something. And we can do this with chmod, also known as change mode. And in this particular example, we're doing it with the symbolic version. So instead of using numerical values, we're actually using the symbols, which is read, write, execute, so on and so forth. So in this case, we're looking at this particular example again. What we're doing is we've given the user read, write, and execute permission. So u plus read, write, execute, and then group plus read and execute, and other plus read and execute, and then the name of the file name. Usually this also requires a sudo right in front of it, so it would be sudo chmod, yada, yada, yada. And so we've given the user these permissions, we've given the group these permissions, and we've given the others category these permissions as well. And then there's the numerical value, the numerical mode of changing permissions, which happens with the actual numbers themselves. And so the first number represents the user, the second number represents the group, and the third number represents the others category. And as we already established, the read, write, and execute permissions total 7. And so in this case, they only have read and execute. So read would be 4, execute would be 1, which totals 5, and then read and execute would again total 5 in this particular case. So this is what it looks like to change the permission numerically for that particular file name. And this exactly is representing what we did in this previous case, which was we were doing this whole spiel right here. So everything that you see here actually turns into 755 in this particular case. Now, if we wanted to change the ownership of this particular file, we would do it using the chown command. And so you can see that they've used sudo in this particular example, and we're doing chown user and group, and then for this file name. And so what you would do is you would just replace these two fields right here with the actual user and the actual group that you would want to dedicate to this particular file name. So it would be, user1 for the developers group, and that would be for this particular file name. So you change the ownership of the file to the specified user and group, and you replace user with the username and group with the group name, and then it would change the ownership of whatever this file is to those entities that we have declared. And this is what that looks like. So we've assigned it to Alice and the developers group, and that would be the ownership for the example.txt file in this case. Then we have changing of the group. So you can change the group ownership, and you would just do it with the chgrp change group command, and you would first use the first assign the group itself that you want it to be changed to. So let's say again developers, and then you would give it the file name, and again they're using the sudo command to allow the sudo or administrator type of permissions to this particular command, because you're changing the actual group of a particular file, the ownership of that particular file. So that should require an administrator's privilege. And this is what it looks like as the actual example, right? So we're doing the example.txt, and we're assigning the ownership of this particular file to the developers group using the change group command. So here's a sample workflow here. So we have the file that's been created. So by using touch, we created this file. Then we did change mode to change the permissions of it. And so the owner has a permission of 6, which represents read and write. And then everybody else has a permission of just read, which is represented by the 4. And that's pretty much it. That's the permission that we have over here. And then if we do LSL for this particular file, it should show us that it only has read write, and then everybody else only has a read permission for that particular file. If we wanted to change the ownership of that file, we could just use the chown command, same exact file name, and then it's going to be, you just saw this in the chown portion of the presentation anyway, so this is literally a duplicate command that we just saw, but we are assigning the owner to Alice. So Alice would actually be the user, and then the group ownership would belong to the developers group, and it's for the example.txt. And then again, you would just do ls and with the -l option, so you can see who the file ownership is, and it'll show you the first column that right after the permissions, it'll show you the name of the owner, and then the very next column would represent the name of the group, and it would be Alice and developers in this particular example. And in this example, we're changing the group, which you've already seen this command already as well, but we just wanted to kind of reaffirm this particular series of commands here. So this is how you change the group. And then if you wanted to see who the new group was, you would just do ls-l, and it would show you that change. So in summary, understanding and managing file permissions is very important to system security, because you don't want people who should not have access control or should not have access to a specific file or directory to actually have access to that file or directory. And to guarantee that, to confirm that you have only assigned permissions for certain items to certain people or certain groups, you would do it with these various options. So you change the permission for everybody, right, according to what should be the permissions for it. Some people should not have any permissions, right? So you can remove the read, write, and execute permissions from every single person by doing a minus instead of a plus. So in the previous example, so if we go and look at just the particular example where we had let me real quick skip to it. In this particular example where we're doing the others group and we're doing plus read and execute, we could just as well do minus read and execute, and it would remove the permissions for that. Same thing with the group. We could do group minus read and execute, and it would remove the permissions for that. So just depending on what the instructions are and what you've been told to do, because they're going to tell you, these groups of the company should not have access to these files or directories. So you need to remove permissions of anybody for this particular directory and all of its contents. And then when you bring in a new employee and they have access to a certain group and all of the assets that belong to that group, this particular subcategory of those assets should not belong to these new employees unless they've hit a senior level level of seniority, And then when they hit that level of seniority, then you can give them access. Until then, they should not have access to it. So you remove access to that specific category of files or folders by doing the owner or group or others, and then just doing a minus command for that. And then if you wanted to do it numerically, then you would change these things to zeros, and the zeros would represent no permission. So it would be 700, meaning that the group as well as the others category have no permissions. They can't read, they can't write, and they can't execute that specific file. So this is what's important about the change ownership and the change mode, which means the permissions of it, and of course the change group, which would change the group that owns that particular asset. So this is a very, very simple series of commands, but they're very powerful series of commands, especially when it comes down to access control lists and making sure that people who should not have access to something don't have access to those things, and then whoever needs to have access to it actually can access whatever those assets are. Which brings us to access control lists. So access control lists are a way to provide more fine-grained control over file and directory permissions, other than the standard Unix file permissions that we just reviewed. So with an ACL, an access control list, you can define permissions for multiple users and groups in a single file or directory, or on a single file and directory, allowing for the specific access levels beyond the traditional group others and owner model. So this is how we would go about doing it. First and foremost, we need to have the entries of the access control list, which means it's basically a list type of a format, and it's each entry specifies the permissions for a single user or a single group, and it consists of the type, which would be user or group, the identifier, which would be the user name or group name, and then the permissions that are set for that, which would be read, write, or execute. So I'm going to show you obviously examples of that. There's going to be the user access control list, the group access control list, there's a mask access control list, and then there's the default ACL. So the user one specifies permissions for a specific user, the group specifies permissions for a specific group. A mask ACL defines the maximum effective permissions for users other than the owner and the groups. So this is the maximum permissions that they have, and everything beyond that they don't have access to. And a default ACL specifies the default permissions that are inherited by new files and directories created within a directory. So anything that's inside of a directory would essentially inherit the permissions of that directory. So if the directory has a permission level of 7, meaning you read, write, and execute, essentially everything inside of that directory would inherit all of those permissions. So it would also be read, write, and execute for everything that's inside of that directory. So the basic command here would be set FACL. So set FACL would set the ACL itself. And in this particular case would be the mask for the user, and then the read, write, and execute for the file name, right? So U represents user, the user itself would be the actual name of the user, and these are the permissions that are being assigned for that user. This is the actual breakdown of the command that we just saw. So the M is not mask. The M actually stands for modify, so my apologies for that. The explanation here is that we're adding read, write, and execute permissions for the specific user on that file name, and then we're using the M to modify the ACL entries, and then this is the actual string or the actual format of how to set permissions for that user, which is in this case the user would be the username. So this could be user, or this could be you, this would be Alice, and then these are the permissions that are being assigned to Alice. Now, if you wanted to view the ACL for that specific file name, you would do get FACL. So the first one was set FACL. This is get FACL, and then it displays the ACL entries for the specified file, which in this case would be the file name, showing all the users and groups within their with all of their defined permissions. So whoever they are and the level of permissions that they have on this particular file would be displayed by doing get FACL. The first one was again set FACL, and now we're looking at the file name permission, which would be get FACL. So this is the example workflow. So we have sudo, because this does require administrator privileges, and we're setting the access control format for this particular file right here by modifying it. And then it's going to be for the user Alice, and then she's getting read, write, and execute permissions on this particular file. So set FACL, modify for the user Alice, read, write, and execute. And of course the U is separated by a colon, and then the username and the permission levels are also separated by a colon. And so sudo set FACL M yada, yada, yada. And this is how we add a user permission for a given file. If we wanted to add a group permission, it would exactly be the same entry. So setFACL still going to be modified. The only thing that we're changing is instead of U, we're doing G for group. And then we're going to assign the name of the group, which is developers. And then they all will have a read and execute permission. So they can't write to the file or modify the file, but they can read the file, they can execute the file. And that would be the example txt file again. So this is how we set permissions for a group in this particular case. And then we have the setFACL for directories, right? So this is the actual directory. And in order to do that, we would need to assign the D flag or the D option in this particular case to designate that we are modifying the access control list for a directory. So sudo setFACL -d to designate that this is a directory, -m to modify, and then again for the same user. And now we're giving the path to the directory instead of the name of the file. And then we're going to view it. So if you wanted to just view the access control list permissions for all of the groups and users that have been assigned to this particular group, you just, or for this particular file, excuse me, you just do get FACL and then the name of the file. Very, very simple. And then if you wanted to view the current example, and then we can view the access control list for this particular file. So we would do get FACL and it gives us the access control list of the groups and the users and whatever permissions they have on this particular file. And this is what the example output for that command would be. So the name of the file would be example.txt, the owner itself would be root, the group would be root, and then this particular user has this permission, and then this particular user has read, write, and execute permission, and then the group has this permission, the group developers has read and execute, the mask itself would be read, write, and execute, and the other group or everybody that falls into the other category only has read permissions on this particular file right here. To remove ACL entries would be done with the X option. So it's still a setFACL command, but now you're doing the X option to remove the particular user from this particular file, right? So you don't have to worry about the permissions or anything like that because you're literally removing that entire user from the access control list on this particular file. So whatever permissions they had is all being removed because we're just removing the actual user from the particular file's access control list. To remove all of the access control entries for any given file, it would be done with the -b option. And again, it's still a setFACL -b and then the name of the file itself. If this was a directory, we would do -d to designate that it's a directory. Then we would do -b to designate that we want to remove all of the entries, and then we would give the name of the directory. But it's still a setFACL command that is going to remove all of those directory entries, or the ACL entries, excuse me. So -x would be for a singular person, for a single removal. So it could be a group as well. So you could technically do -x and then do G right here and then the name of the group. So developers, let's say. So we do G for group and then the name of the group developers, and then we would give the name of the file, but we would do with a -x to just remove a singular entry. If we wanted to clear the entire set of entries, if we wanted to remove everybody from the access control list, we would do a -b command and then we would just give the name of the file. If it's a directory, you would do -d as well as -b, and then you would do the path for the directory, and then it removes every single entry for the access control list on that particular asset. To modify the mask, you would also use the setFACL in this particular case, and then we are using the -m to modify, but what we're doing in this case, we're modifying the mask, which is read, write, execute for this particular file. And what that does is that anybody, any user and group specified by this access control list for this particular file, they all have read, write, and execute permission. So even if you did user Alice and read, if the mask itself is read, write, and execute, then Alice would actually get read, write, execute permissions on this particular file. And then if the developers group is in here and they only have read as the permission, if you do read, write, and execute for the mask, then it would allow it that they would be able to read, write, and execute for everybody that's inside of the developers group on this particular file. So in summary, The access control list is an advanced method for managing file permissions in Linux, allowing specific access levels for multiple users and groups. The commands setFICL and getFICL enable you to set and view these fine-grained permissions easily, and then you already know the various options that we have. So if you do, -m, you're modifying the permissions, and that goes with setFICL. If you do -x, you're removing a singular person or singular entity from the list. If you do -d, you're designating that it's a directory, and if you do -b, as in boy, you're removing every single person and every single entity from that access control list. And then you would modify them, specifically if you wanted to add a user, you would have to have the U in front of the username. If you want to add a group, you would have the G in front of the username, so on and so forth. So I'm not going to repeat all of that stuff because you could just rewind it and just go watch all of that all together. But setFICL and getFICL are the commands that we would use to set the access control list for any given asset and see the access control list for that asset. All right, now we need to talk about network security, which is also a very, very important concept under the security umbrella. And the very first portion of it would be the management of the firewall. We've already done an intro to UFW, which is the Uncomplicated Firewall, as well as iptables, but we're just going to review these things a little bit more. So you should already know that firewalls are very important in network security. They act as a barrier between your internal and external networks, and they monitor and control incoming and outgoing traffic. And these are done with rules that we establish. So both UFW and iptables have sets of rules that you can use to ensure that whatever you're trying to do gets done, right? So the first thing that we're going to talk about is the UFW, the Uncomplicated Firewall. The Uncomplicated Firewall is a very simple firewall, but it's a very powerful firewall. It doesn't require like very complicated commands or understanding a variety of different sophisticated binaries to be able to run it. It has easy syntax and it's powerful. It actually does what it needs to do, right? It gets the job done essentially. To first run it, to actually activate it, you need to run sudo UFW enable. And essentially everything else that we do is going to require a sudo command to preface the rest of the command. So first you need to enable the firewall. You need to actually activate the firewall. The next thing, you want to allow or deny traffic. Now, to be able to allow traffic, in this particular case, what we're doing is we're in the first command. This command right here is allowing incoming traffic on port 22, which is SSH, right? This particular command, you have to, if you want to do outgoing traffic as well, if you want to allow outgoing traffic on SSH, you would need to also say sudo UFW allow outgoing. Excuse the capital S right here, it's a lowercase s for sudo. So anything that you want to set up as a rule that would be outgoing, outbound traffic, you need to put the keyword out in it. So this particular command at the very top, this first command, is only dealing with incoming traffic. So it's allowing incoming port 22 traffic. Same thing with this command. It's allowing or it's denying incoming port 80 traffic. In this particular case, we would be denying outgoing particular HTTP traffic on port 80, right? So sudo UFW deny out port 80 traffic would be denying outgoing outbound HTTP traffic on port 80. If you want to check the status of what's going on with all of the rules that you have, that would be done with the UFW status command. So it'll show you whether or not the firewall is actually active, and then what all of the active rules are that are running on the UFW firewall. This is a new command that we're going through, which is allowing traffic from specific IP addresses, right? So you can say UFW allow from this IP address to any port on port 2022. I keep saying 2022. I don't know why I keep doing that, but it would allow anything from this particular IP address to any port 22. So it allows SSH traffic from this IP address on port 22. You can do a deny that would be on port 22. As long as you have this allow from this IP address, now you've whitelisted this particular IP address, and even though everybody else could be denied on port 22, this particular IP address will be allowed to come in. And again, this is inbound, right? Because we haven't done allow out. We're only doing allow, which means that it's inbound traffic, incoming traffic, and it's coming from this particular IP address on port 22. So this is how you allow a specific IP address. IP tables would be the more complex, or we can call it the sophisticated. It would be the sophisticated counterpart of UFW. It allows more detailed control over the network. It allows administrators to create complex rules for packet filtering, network address translation, which essentially means that it masks your IP address so that people from the outside can't see your actual IP address. So when you send out traffic from your network, it's masked essentially by a different IP address, and that IP address would be what the outbound or the outside world would see, which is a very, very powerful tool actually. And then there's mangling and so on and so forth. So it's very, very useful, but it does require that you have a better understanding of networking concepts. The very first thing would be to just learn and see what your current rules are. So you can just do sudo iptables-l with a capital L, and it will show you all of the current rules for your filter table. So this is the other thing, right? So you have a variety of tables that exist inside of IP tables. So in this particular case, without designating what table we want to look at, the default will be the filter table. So it'll show you the input, forward, and output chains for the filter table. If we wanted to add a rule to our table, we would do it with the A, so capital A, which would be either append or add, however you want to remember it. But it would be a capital A, and we're doing it to the input table. And notice that the input table is also in all caps. So you're doing capital A, input, and then the protocol would be TCP. So this is TCP traffic that we're allowing to happen. And then we're doing on the destination port 22, and then we want to do an accept for it. So the J, I believe, is jump. I think that's what it stands for. And what we're doing is accepting the traffic on destination port 22, and this is for input traffic, which represents incoming traffic that's coming in on our input table, or input chain, excuse me, on the input chain on our particular table. So we're doing adding on the input chain on the protocol TCP, destination port 22, and we want it to be accepted. If you want to block traffic, again, you're adding it to the input chain. Protocol would still be TCP, and the destination port in this case would be 80. And then what you want to do is you want to drop the traffic. So it's not deny. If you want to block something, you're dropping the traffic. So the previous one was accept. This one is drop. If you want to save the rule that you just created, the iptables rules, you would do it with the iptables-save command, and then you need to add it to the configuration file, which is our rules.v4 config file that is inside of the etc iptables directory. So once you have iptables installed, inside of the iptables directory, inside of the etc directory, there's going to be a file called rules.v4, and these are all of the rules that will persist, right? So when you restart the computer, all of the rules that you just created will also be saved so that the next time the computer reboots, all those rules are still active. If you want to restore rules, you would do restore, and then notice the arrow, right? So in this particular case, we have this /, which I guess is the greater than sign. So we are saving the rules that we just created, forward sign, and then it's going to go inside of the rules v4. If you want to restore it, when you use the restore command, you're using the less than symbol, and then you're going to use the same path, which is going to come from the rules.v4 file, and it's restoring the rules from a saved file, just in case for whatever reason, you need to restore your rules. If somebody changed your rules, or if you changed your rules and you want to go back to your previous rule set that you had saved, you would pull all of those rules from your rules.v4 file by doing the restore command. In summary, we have the simplified management with UFW, Uncomplicated Firewall. And then we have the iptables, which is advanced control for detailed network traffic management. You have the network address translator. You also have the mangles and all that stuff, which we covered in the first description of the iptables and the UFW. But we needed to talk about firewall management because we are talking about network security under the security chapter. So it was very important to re-review these files or re-review these tools. But we are going to actually use them when we get to the practical section of this training series anyway. So we're going to run a bunch of commands and we're going to create a bunch of rules and do a lot of things that will be relevant to your labs and ultimately your skill set as a Linux administrator when you want to manage and you want to configure firewall rules for either UFW or iptables. Another really important tool for security is actually SELinux, so Security Enhanced Linux. I'm just going to call it SELinux. SELinux probably. I don't know if it's SELinux, SELinux. I kind of like SELinux because it removes one syllable. So SELinux is a security module in the kernel that provides a mechanism for supporting access control policies, including MAC addresses. It's commonly used in the Red Hat-based distributions like Fedora, CentOS, and Red Hat Enterprise Linux. And the key concept here is that there are policies, right? So we have policy-based security, and the policies inside of SELinux define the rules for which processes and users can access which resources. So these policies are strictly enforced, providing an additional layer of security beyond traditional discretionary access control, which is also known as DAC. So these are an additional layer of security, and they are very strict, right? So these are strict enforcement to set the rules for which processes and users can access which resources. The modes of operation are to enforce, to permit, or to disable. So you have the enforcing mode, you have the permissive mode, and you have the disabled mode. SELinux policy is enforced and access violations are blocked. So this is what enforcing is. Permissive is that the policies are not enforced, but violations are logged for auditing purposes. And then there's the disabled, which is it's just turned off and it's not working. So you actually have the enforcing rules that anything that violates the policy is being blocked. You have the permissive, which is still logging everything, but it's not blocking the actions, right? So if there are malicious actions, they're not being blocked, but everything is being logged so that it can be audited later on. And then you have the disabled version of this. So our very first basic command would be to see the status of what's going on. So to be able to view the status of SELinux, including what mode it's running under and all of the loaded policies or whatever the policy is that's loaded, you just do SE status. So SELinux status, right? SE status. And then you would be able to see the current status as well as the policy that's being enforced. If you want to set the policy to enforcing mode in this particular case, what we're going to do is do set enforce, right? So set enforce, and then 1, I believe, represents true. So 0 would represent false, 1 would represent true. And in this particular case, we're saying that we want the enforce policy to actually be activated. So we do set enforce 1. And it changes the SELinux mode to enforcing. And this command ensures that all SELinux policies are strictly enforced. If you do set enforce 0, it goes into permissive modes. Yeah, so I was actually misguided or misinformed. I misassumed. The set Linux to permissive mode goes into set enforce 0, which changes it to permissive, allowing violations to be logged. So 1 represents the enforcing mode to actually be active, and it is enforcing all of the rules, and 0 represents permissive mode so that it logs everything, but it doesn't block anything. It doesn't enforce any of the rules or policies that may be in place. And then we have checking the status, as we've already established. And then we have the practical example or the rule set to just kind of remind us of how to set enforcing mode, which is in this case set enforce 1. And then if you wanted to set the enforce to 0, you would be putting it in permissive mode. And this is essentially what the SELinux practical examples would be in this particular case. We are going to go into the practical commands when we actually get into the practical section of this training series, so that you can learn how to use this particular tool in depth. Another useful tool is AppArmor. So AppArmor, also known as Application Armor, is another Mac system that provides, and Mac, we're talking about MAC, not Mac as in Apple. So it's another MAC system that provides an additional layer of security by confining programs according to a set of profiles. It's commonly used in Debian-based distributions like Ubuntu, which is what Kali Linux runs on, and so on and so forth. So anything that essentially runs on Debian or Ubuntu is what AppArmor uses, because it deals with applications specifically. The key concept is that there's profiles in this particular case. So previously we had policies, which was in SELinux. Now we have profiles inside of AppArmor. And the profiles define the access permissions for individual applications. They specify which files and capabilities an application can actually access, preventing it from performing unauthorized actions. So think about this as when you try to turn something on inside of your Windows or inside of your Mac OS, and there's a little pop-up that comes up and it says, do you want to allow Google Chrome to access your microphone, for example? And this would be something that's specific to the Google Chrome application, and then it's now you're giving that specific application access to the microphone or your downloads folder, right? So if you download something and it deals with the files inside of your file system, once you try to run that application, there's going to be a pop-up that shows up from Mac OS or from Windows that says, hey, do you want to give this particular application access to your documents folder or your downloads folder or your pictures or so on and so forth? It starts asking for permission to navigate across your computer. And so this is what AppArmor is similar to. And because of the fact that you have applications that are downloaded on an Ubuntu-based distribution, then you are now dealing with the actual app itself, and the app needs to be given permission to do a variety of tasks across your machine. So we have the learning and enforcing modes in this particular case. So enforce profile is authorized to access attempts, and unauthorized access attempts are blocked, So the AppArmor profile is enforced and unauthorized access attempts are blocked. And then complain would be that unauthorized access attempts are allowed, but they're logged for review. So this is similar to the enforce and the passive or permissive, I think it was. It's very similar to those particular profiles that were inside of SELinux. They're just named differently. So in this case, we have enforce, that it enforces the rule and any unauthorized access is blocked. And then you have complain that allows the attempt, but it just logs it for review. The basic command to check the status would be sudo AA, standing for AppArmor -status, and it displays the current status of AppArmor, including which profiles are loaded and their enforcement mode. And then you have setting the AppArmor to enforcing mode for any given profile. So in this particular case, you would do AA enforce, and then you give it the path to, and it's a fairly lengthy path, but it is the path to the specific application that is going to be enforced for whatever the rules are. So the profile for a specific application to enforcing mode, ensuring that the rules are strictly applied to whatever the name of this application is going to be. And then you would need to get the name of the application as it is inside of the user binaries. And it's very different from what you would see for Google Chrome, for example, which is a capital G, Google, and then there's a space and a capital C, Chrome. It's rarely like that. It's typically all one word. It's typically all lowercase. So you need to find the name of the application as it stands inside of your binaries or your optionals or wherever that application is actually installed, and whatever that path would be to that application. And then you would enforce the AppArmor rules upon it. You would enforce the AppArmor enforcing mode for any given profile. If you wanted to set the policy or the profile to complain, then you just do AA complain, and then you just give it the path of the application. Very similar to the previous one. The only thing that's changed in this case has been AA-complain instead of AA-enforce, as we saw over here. And that is how we designate the complain mode for that specific application. Just a couple of practical examples here. So again, you can just do AA status to get the status of AppArmor. You can do AA enforce to enforce a profile for a specific rule or for a specific application. So in this case, it's Firefox, right? So etc apparmor.d user.bin.firefox, and this is the specific application that is now enforced. Whatever the rules are, they're being enforced upon Firefox. In summary, we have both SELinux and AppArmor that are robust security mechanisms for Linux systems through mandatory access control policies. That's what MAC stands for. So you have discretionary access control, which was DAC, and then you have mandatory access control, which is MAC. And while SELinux is typically used in Red Hat's distributions, AppArmor is used in Debian-based distributions and emphasizes application-specific profiles. SELinux focuses on system-wide policies across the entire system. AppArmor is honed in on specific applications. And they're both very, very useful, and they do deal with mandatory access control policies, which are also very, very useful. So MAC, mandatory access control, and that's really what it means, right? So it's like when you go through CompTIA's CYSA Plus, which is an examination that I had the privilege of taking, they give you a lot of situations. They give you like a breakdown of, okay, this is mandatory access control and this is what it applies to and so on and so forth. But you don't really get it until you actually go through some tools that enforce those things. And you're like, oh, okay, so when I enforce Firefox to not have access to my microphone, for example, that is technically a mandatory access control policy that mandates that that specific application cannot access my microphone. And then until if I wanted to access my microphone for a Zoom call or something like that, or for a Microsoft Teams, comes Zoom is actually its own application. So Microsoft Teams or whatever, or let's say this, what is it called? Discord. You can also have voice conversations on Discord. So if you want Firefox to actually finally get access to your microphone when you do those voice calls, then you do need to go and give it that permission inside of AppArmor, for example, if you're running Linux, right? So this is very important to understand that this is actually where the rubber meets the road. And these specific concepts of MAC, that's how you enforce them, by using something like AppArmor, which it could be as simple as a pop-up that shows up on your screen that says, hey, do you want to give this application permission to do this, right? It could be that, or you can actually be going inside of your settings or go and inside of your terminal and use the enforce policy or the enforce profile for AppArmor against the Firefox tool itself. So this is the difference between AppArmor and SELinux. All right, now we're going to switch gears a little bit, and we're going to go into user authentication and configuring secure shell, which kind of actually do go hand in hand. So first and foremost, let's talk about user authentication methods. There's password-based authentication, which is the default mode for authenticating any given user. Everybody gets a password, and you have to enter your password correctly to authenticate yourself, to prove that you are who you say you are. Now, the users are given a username and they're given a password to gain access to a system, to gain access to an application. This is not news. So if you don't know, this and you're watching this tutorial, you're in trouble, right? So it's like to understand that there is a username and a password for everything in this world. Anything and everything has a username and password. YouTube that you're watching this on, most likely you have a user profile with Google that's connected to your YouTube account, and you provided your user Gmail as well as your password. If you're watching Netflix, you get a username and password. If you want to access your phone, there is a passphrase or a PIN number that you have to enter to access your phone. And then when you do your face scan or your fingerprint, that is still authentication, but now it's going into biometrics, which I'm kind of getting ahead of myself. But essentially, you're authenticating yourself in a variety of different ways. And the very first one, the most basic one, is passwords. So you get a password-based authentication. Password-based authentication improves the security of any type of an environment. And to be able to improve the security of the password, you do something like multi-factor authentication, which is also known as MFA. And that could be something like a code that's been sent to your phone or your Gmail account or your email account. They send you a secret code, a one-time code, and then you enter that and you can access the system. The fingerprint scan is a version of the biometric that we were talking about that helps you multi-factor authenticate yourself to be able to get access to that system. And these things are done in addition to the password. So if you're accessing your bank account on a new computer or on a new browser, or it's the same exact browser or same computer, but you've reset the computer, you reformatted the computer, and so all of your caches are wiped, or you just wiped your browsing history from Chrome and your caches and your cookies are no longer saved. When you do something like that, it says, oh, you're logging in from a new browser, we're going to send you a one-time code in addition to the password, right? So you enter your email and password, you log in, and it says, okay, we're going to send you a one-time code. And then when that happens, then they ask you, do you want to save this particular browser for future references? And then that's how you develop new cookies and new caches, right? So this is the whole process of multi-factor authentication, and it enhances the password authentication. And it's a very useful way to reduce the risk of unauthorized access, because sometimes somebody may get access to your password, but if you get text a code saying, hey, enter this in your login, most likely that person won't have access to your phone number or your email, hopefully. I mean, it's scary to think about, but it is possible for people to get access to your email and even your phone. It's just not as easy as somebody running a dictionary attack and finding out your password if you have a really weak password. So I'm going off on tangents and I'm getting ahead of myself, but we can enhance password-based authentication by using something called multi-factor authentication, which is very simple, and you just send a code to somebody. That's one of the most useful ones, and it's very, very useful. The next level up would be a public key authentication, and it's more secure than passwords because it involves the use of a key pair, so a private key and a public key. The private key remains within the user or with the user, while the public key is placed on the server. And this goes into the realm of symmetric and asymmetric encryption that happens typically with transactions that are done with your browser. So a transaction is you viewing something on your browser, but there is the private key and the public key that is available from that website. So the private key is something that you can't see from the certificate authority of that website that they have to authenticate themselves. And then there's the public key that is given to you, the viewer, so that you can verify yourself and you can go back and forth interacting with the conversations or the interaction, the transactions within that specific browser, within that specific website, right? So you have a public key authentication that just supersedes it. It's an amplified version of the password-based authentication. It enhances your security, so it is no longer a subject of brute force attacks because you can't brute force a key, right? And the private and the private key, or private and the public key, excuse me. It doesn't require the transmission of passwords over the network because you're just dealing with those keys. It allows for automated passwordless logins, which are particularly useful for scripts and applications. And this does include at least a one-time login, though, because there is that initial authentication that needs to take place with that password, but then you automate the rest of that process because you now have a public and private key, so to speak, that communicates with that website or that application so that you no longer need to do a password entry. And this is how, when it remembers you, when a browser remembers who you are and you don't need to provide that password anymore, the next time that you log on to Facebook, it just logs you in, right? The next time that you log on to Gmail, even if you've closed the tab, even if you've closed your browser, the next time that you log on, then it'll actually just log you back in without asking for your password because the key is in place. If you wanted to generate a key, you would do it with SSH keygen, and this is a little bit complicated of a process, so we're not going to go too deep into this. We will when we get it to the practical section of this training series and we start doing these things later on. But you do SSH keygen and it actually generates a new key pair, and you'll be prompted to enter a file to save the key to, which is typically the SSH IDRSA. And then optionally, you can set a passphrase for an additional layer of security on that actual key, right? So if somebody wanted to access that specific key file, they would need to enter the password to be able to access that key file. So now you have multiple layers of security. And so you create a key using SSH key gen, and you can even designate the algorithm, the hashing algorithm of the key that you want to generate. So do you want a SHA-1, SHA-1, do you want a SHA-256, so on and so forth, right? So you can designate the hashing algorithm that you want to be used when you're creating this SSH IDRSA. By default, it does a SHA-256 key, which is a very, very powerful hashing algorithm. This is what the output looks like. So when you actually run that SSH keygen, this is what the screen will look like. So these are individual commands that show up, right? So first it says it's generating it, enter the file that you want to save the key to, and then you would say such and such, and then you press enter, and then it says enter the passphrase. So if you don't want a passphrase, you just press enter and it moves on. But I do recommend you actually have a passphrase for your key, and then you verify your passphrase again, and then it's been saved, and then it's been saved, and then the key fingerprint is a SHA-256, as you can see right here, as well as the username and the host. And it's like a long series of characters that comes in after this particular portion right here, and it seems like jargon, and I mean, for the most part it is. It's like you can't make out what it is, because it very much looks like a code, like a long piece of encryption code. So you can't make sense of it with the naked eye. You need to feed it into something at the very least, to try to use some other type of decryptor to be able to get access, or decoder I should say. You need to use a separate tool to try to make sense of what you just found. But for the most part you can't, because it's not designed to be able to be decoded or decrypted without its actual key, right? So whatever is generated, nobody can make any sense of it unless they have the key. They can't unlock the lock unless they have that key, which is why this concept is so powerful. Now that we've generated the key, now we want to copy that key to the actual server. So you would do SSH copy ID and then the user at whatever the server is, and this copies the public key to the server, placing it inside of the authorized keys of the SSH directory for the specified user. And this step allows the server to authenticate the user based on the public key. Copy the public key to the actual server. If the SSH copy ID is not available, you can manually copy the public key by going and finding where it is. So this is the actual key location, right? So when we went over here, it said that it was saved inside of the home user, and then this is a hidden directory, and we'll look at this when we go into the practical section. When you're looking for a hidden file, so if I did a regular ls command without looking at the hidden files, this would not show up. So this is a hidden directory, and then inside of the user's home folder, the hidden directory includes this IDRSA file. So this is actually being saved inside of the home folder of the user. And so if you can't do it automatically using the SSH copy ID, you can do it manually by going through these various series of commands right here. So we can see that we're going to concatenate this plus specific key, and then we're going to pipe. So this is what this pipe is, and we'll talk about this again when we get into the practical section. But what we do is that we take the output of this command. So cat, as you should already know, will display the contents of this file. But when you take the output of this, which is displaying the contents, and you pipe it into this command, which is using the SSH binary to log into this specific user, and then make the directory of this specific directory right here, and then concatenate that. So you should already know what these double ands represent, right? So we're combining a series of commands here. So we're going to do SSH user server. We're going to make a directory for this specific directory inside of the root, and then we're going to concatenate that into the authorized keys. So it's a series of commands. First, we read this, we take the contents of this, and we pipe it into the SSH command that goes and creates a new directory and concatenates the contents of that inside of the SSH authorized keys. This you don't need to memorize. You don't need to know what all of this represents right now. I'm just showing you what a manual version of this looks like, so you kind of get exposed to it, so that as we review it later, at least it was embedded in your head at some point, and then it'll be easier to make sense of it when we go into the later portions of this. So you don't need to memorize this. You don't need to know this off the top of your head right now. You should know what this is, right? You should know what this specific piece represents. Oh, this is a key file for SSH, where we've generated an RSA key file, and it looks like they're adding it to the authorized keys list of authorized keys for this particular user, right? So you don't need to know all of the details, but you do need to recognize these specific points so that you can see what is potentially going on, right? As long as you can make sense of it, you don't need to know the exact details of everything that's going on. That's the main point that I'm trying to show you here. Once the key has been copied into the authorization keys, the authorized keys, then you can actually SSH into that server with that user. And this is a very basic SSH command. So you're just secure shelling as this user into this particular server. That's all you're doing. Once you set it up and copy the public key, you can log in without being prompted for a password. That's the whole idea here. Again, this whole piece requires some kind of authentication at some point, because you can't just add a key to the authorized keys folder without being authenticated at some point. This is assuming that you've authenticated yourself with a password at some point in this process before you started this process. And now the system trusts you, therefore it's allowing you to transfer this key to that authorized keys. And once you've done that, then you can access the server without entering your password. If you have never entered your password and you're trying to access the server as this user, it is going to ask you for a password. I don't care how great you've done the rest of the stuff that we just talked about. If you never authenticated yourself, none of those things are going to work. Therefore, at this point, you're going to be asked for a password. So the summary here is that you can have a password-based authentication, which is the default mode of verifying who you are with any kind of a system. But then you can have multi-factor that enhances that password-based authentication, something like sending you a one-time code or your fingerprint or your face scan, something like that. And then you have the public key authentication, which is a stronger security for using key pair. It still requires at some point you've entered a password to verify who you are, so that you can generate a key pair and then transfer the key pair from where it's currently sitting as your ID RSA inside of your authorized keys, and then you'll be able to enter whatever that server is without entering your password again, right? So it's in some point for this, at some point you do need to provide a password. Otherwise, none of the other stuff is going to work. So just keep that in mind, okay? Now that we've talked about authentication, we need to talk about Secure Shell and configuring Secure Shell. So Secure Shell is a very powerful tool for remote access, and it still is used currently in the modern era in 2024 going into 2025. Secure Shell is still one of the most powerful ways to access a Linux server specifically. So it runs on port 22 by default, and for the most part, the only thing that is required to access Secure Shell is a password, unless you do other things to enhance the security, which is what we're going to be talking about. When you enhance the security of something, you're hardening the security, okay? So we are going to harden SSH configurations to mitigate any potential threats. And these are some of the key steps to do it. Number one, you want to change the default port. So by default, it runs on port 22. Simply changing the port can help you reduce the risk of automated brute force attacks that target that default port, because everybody and their mother, even if you're like a brand new hacker, you know that port 22 is Secure Shell and it is the port for remote login. So you're going to attack port 22 for the most part. So the first thing would just be change the default SSH port, and you can do that through the SSH configuration file. By doing that, or the way to do that would be to actually go into the SSHD configuration file. So you already know that SSHD stands for the daemon of SSH, and there's a configuration file for it. You'll find the line that says port 22, and it's typically commented out because it's not modified. So you need to uncomment it, meaning just remove this hashtag at the beginning and then change it from port 22 to 2222, for example. And then you can also change that for literally anything else. So there's the top 1,000 ports, which are usually assigned to something. So you don't want to use any of those top 1,000 ports. You want to find anything past 1,000 or past 2,000 because it is not going to be a common port anymore. And at that point, you can just use any of the 65,000 ports, or let's say 63,000 ports. If you don't consider the first 2,000 ports, anything past 63,000, you can literally use any of those to be your port 22 or your SSH port, excuse me. It could be the replacement for port 22. And once you've done that using Nano, you can then just save the file and close it out. And now you have reassigned your actual port for SSH. The next step would be to disable root login. So not allowing the root user to actually log in via SSH is a very strong move, because if any hacker is allowed to actually log in as a root user, they get all the root permissions, and I mean, you just figure out what the rest of the problems will be after the fact. So you just disable root login, and then it forces whoever the attacker is, or whoever anybody is, to log in as a standard user account, and then they have to escalate privileges if they need to get the rest of the things that they need to get done. So first, logging in as a standard user is going to be a problem for them, especially if you have really strong password policies that you enforce in your company. Once they log in as a standard user, now they have to find a way to escalate privileges and actually become an administrator or become a root user to be able to do the rest of the things that they want to do. So that would be another really simple move that's very, very powerful. You just disable the root login. Now, the way to do that would again be inside of the SSHD configuration file, which would be with the permit root login portion. So again, you just find this particular line that starts with permit root login, and then it says prohibit password is the default. So you uncomment it, you remove the hashtag, and then you just say permit root login, no. So you remove the prohibit password portion, which means that as long as they have the password, they can get in. It's prohibited unless they have a password. That's essentially what the default is. And what you want to do is you just want to change it from this to no. Nobody can log in as root. Root login is not allowed. And then you just save the file and you exit the editor. The next portion would be to limit the SSH users. So you just designate which users can actually log in via SSH, and nobody else can unless they're on that white list. And this is also another very powerful tool that is very, very simple to do, and it just goes miles as far as security is concerned. So you have a handful of people that can log in via the SSH portal. And this is again done on the SSH configuration file. So you find the portion where it says allow users. If it's not there, you would just add it yourself. And it is case sensitive. So it is capital A, capital U, allow users, and then username 1, username 2, and obviously those are the actual usernames that can log in via SSH. And I mean, I would keep it to a small group of people. I would not go crazy with this. You don't want a bunch of people to be able to log in via SSH. You just want whoever the admins are and whoever the specific IT administrator is, or the CEO or the CTO, whoever those important people are. You just want those people to be able to access SSH, and then from there, nobody else can access SSH, and just close it off to everybody else. If they want to access their file systems remotely, you give them a separate portal that is encrypted, and you give them a different way that they can access a file system remotely. They should not come in via port 22 or the SSH port, whichever port has been designated for that specific service. You do not want them to use SSH. You want them to use a different login mechanism that is encrypted and runs across a VPN and a variety of different authentication methods so that they can access the file system remotely and do what they need to do. They should not be coming in via secure shell. That's the whole point here. Once you have done all of those things, you need to restart the SSH service by just doing a systemctl restart command, and it will restart the service, which means that it'll apply all of the configurations that you just made to the configuration file for SSH. So this part is very, very important. If you don't restart it, then it will not enforce all of those rules that you just added to the configuration file. In summary, you want to change the default SSH port. You do this by editing the configuration file, finding the portion that has the port 22, and then changing it to whatever your new port number is going to be. You're going to disable root login. In the same exact file, you're going to go and find permit root login, and you're going to change it from whatever the current setting is to no, simply no root user is allowed to log in via SSH. And then you will edit the config file by adding the allow users parameter, the allow users option, so that you can designate which which limited number of users should be able to log in via SSH. And then after the whole thing is done, you've saved the configuration file. You need to restart the SSH system, the SSH service, so that all of the rules that we just created will now be enforced. And that way you can actually configure your SSH for secure access. And now we need to talk about encryption and the secure transferring of files, which is another very, very important concept. So encrypting data with GPG. So GPG is a tool for communication securely, right? So securing communications and data transfer essentially. It uses asymmetric encryption, which involves a pair of keys, a public key and a private key, as we've already discussed with our keygen portion. The public key is used to encrypt the data, and the private key is used to decrypt the data. So public key locks it, private key unlocks it. This ensures that only the intended recipient who possesses the private key can read the encrypted message. My accent kicks in sometimes and I'm like, oh my God. So only the person who has the private key is the one that's allowed to decrypt the message or file so that they can get access to its contents. So it's very simple concept, but again, really, really powerful concept. So we're doing it with GPG. So you generate a key with GPG. You do GPG --gen key. It generates a new key pair. You'll be prompted to provide the name, email address, optional comment, and you can also set a passphrase for additional security, which I always recommend that you do. And then once the key has been generated, you select the key type, the size of it that you want it. Usually the default is very useful, but I do recommend if it gives you like a really massive option, I do recommend getting like the largest type of key that you can find, because the bigger the key type is, the more powerful it becomes and the harder it becomes to be decrypted. You set an expiration date for the key if you want to do that, and then you enter a passphrase if you want to protect a private key, which I recommend that you do that. So these are the steps that you would do to generate your key with GPG. This is what the output looks like. So you run the GPG command, and then this is the top portion of it. And it says it needs to construct a user ID to identify your key. So the real name would be Alice. The email address would be this person. Comment would be this. You selected this user ID, Alice, yada, yada, yada. Change, email, comment, or is everything okay? And then you just say, okay, and you press enter, and then it continues to do what it does. This piece is right here for the rest of what we're going to be talking about. So this is essentially the user ID that will be assigned to this key that's being generated. And when we get to the encryption of a file, you need to actually give the recipient to the command, right? So you're going to do GPG encrypt. The R would be the recipient themselves, and in that particular case, it would be this person, right? This is the ID of the recipient. And so when you run this command, you would put the ID of the recipient and then the file name that you want to be encrypted. And then it will encrypt that file name, and then whatever the key is for that specific person, that will be what's used to decrypt this file name. This is what that actual command would look like when you actually use somebody's ID. So same command, right? So gpg yada yada yada, and then we have Bob at example, which would be the user, so the recipient in this case, that's the ID for the person, which is Bob at example, and then the name of the file that's going to be encrypted. And then once it has been encrypted, the encrypted file will have a GPG extension at the end of it. So it still says document.txt. It'll just say .gpg at the end of it, implying that this has now been encrypted. And then this is the file that will be sent to Bob. And then Bob will be the person that has the only key that would be able to decrypt this particular file. Bob would then need to run this command to decrypt the file. So instead of -e, it would just be a -d for decrypt. And then it would be the file name with the extension of GPG. And then that's what would happen to actually decrypt the file. The key would need to be added to their key log, which we'll do in a couple of slides. But essentially, this is how the file would be decrypted. And you run the command to decrypt the file. You'll be prompted to enter the passphrase if there was one. And then that's how it would be decrypted. So very simple. So this is what the actual full thing looks like, right? So you just do GPG -d document text PHP or GPG, excuse me, and then it'll output the decrypted content into the actual console. Instead of doing that, you can output it into a text file or into any given kind of file by using the -o flag. So instead of it being printed onto the console, which is the default, you can just run exactly the same command, just do -o and assign a name, which would be, for example, decrypted document.txt, and then you give it the GPG file, and then it'll decrypt it and it'll output it inside of this file for later use. To be able to import a key, we will use the import command with GPG, and we would do --import and then the public key file, and it'll import the public key from a file into your GPG key string. There you go. It's called a key string or key ring, sorry. Key ring, not a key log. So it'll import the key file into your key ring. And this is what it looks like, right? So this is Bob's public key, and it's going to be imported into Bob's key ring when he runs this, and then he can run the decrypt command, right? If you wanted to export the public key, you would run the export command with the A option right here for the user ID themselves, and then you would export it into a public key file. So it'll export the public key into a file, replace user ID with the user with the email or key ID for the person, and then the public key file would be the name of the actual output file itself, and this would be the file that would be imported into the key ring using the import command later on. And the export of the public key would actually look like this in this particular case. So you have the export of this particular user's key that would be exported into this key file right here. And then this would be the file that you would email them, and then they would need to import it into their key ring, or you would not email them. It would probably be like a secure copy kind of a situation. And then once they have that, they would be able to import it into their key ring and then use it to decrypt a file. If you wanted to list the keys that you've generated, you would just use the list keys command, and it'll show all the keys that are inside of the GPG keyring, including the key IDs, the user IDs associated with them, and the types of keys that they are. So in summary, it's a very versatile tool for securing files and communications using public and private key pairs with the commands for generating them, encrypting and decrypting files, managing them. It ensures that your data remains confidential and secure. And this is, as you saw, it's not a complicated tool to run. The process is fairly simple, right? You generate the key, you encrypt the file, and you encrypt it with the ID of the person that should be able to decrypt it. And then you export that person's key into a key document, a key file. You get them that key file, they would import that key file into their key ring, and then they would be able to use that to decrypt whatever the file is that they're supposed to decrypt. And typically, if you've already added a passphrase to kind of double up the security for that file, then they would also need the passphrase to be able to do that. So if somebody intercepts that individual key file that you generated for them and then you emailed them or secure copied, whatever, if somebody intercepts that key file but they don't have the password to access that key file, then they still wouldn't be able to decrypt the original document, which provides an extra layer of security. And I would recommend that you send the password to the key file in a separate type of a medium. So you text them the password and you email them the actual key file, for example. So there's two different communications that have happened through two different mediums. So if somebody is intercepting their emails, for example, they won't be able to get the password that you texted them or you sent them through WhatsApp or a different method of communication. You could call them and say, this is what it is, write it down, so that nobody can actually, there's no digital layer of evidence for that transfer of information. So there's a lot of different ways that you can secure this, but I would highly recommend that every single key file that you've generated and every file that's been encrypted also has a password that's attached to that key so that it can be decrypted using the password as well as the key. And this is the perfect segue into secure file transferring. And we can do this with SCP, which is secure file copy, or SFTP, which is the secure file transfer protocol. So this is essentially the way that you would transfer those key files that you just generated, as well as the document itself that was encrypted, right? So the file that was encrypted as well as the key that was generated, you can be able to transfer them using either SCP or SFTP. So SFTP is the interactive protocol for file transfer. It is the secure version of FTP, which is a very, very common protocol that was used for a very long time until they found out that it's not secure because most things are clear text, and they developed the encrypted version of it, the SFTP version. And it's more flexible and user-friendly because it's interactive, right? So once somebody has the login for the FTP, the file transfer protocol, they can kind of navigate it very similar to the way that they would navigate any Linux file structure, any Linux file system. So a lot of the same commands that would run inside of a terminal for a file system actually run on the SFTP once the person is logged in. So you can do SFTP user at host, and you would start the SFTP session as such, and then you can put the file inside of this particular server, and then somebody else can log in and then access that file and download it onto their computer. So it'll initiate the SFTP session with the specified user on the remote host, and then you can run the ls command, for example, to list the contents in the directory. You can change your directory into the path of another directory because you're inside of a file system right now. You're inside of a file transfer protocol. So you're literally inside of a file system that is just being managed remotely. And you can download the file, right? You could just say get of this file, and you can put a file inside of it. So if there's for example, the file that you just encrypted using the commands that we just ran through, we can take all of those files as well as the key that we just generated, and we can take both of those and put it inside of the FTP file transfer portion by using put, and then the person on the receiving side would log in, and then they would use get, and they would download those files onto their local machine so that they can decrypt them and they can get access to them. You can do a get R for remote directory, and you would recursively download everything that is inside of that directory onto your computer. So instead of doing a individual file that you would do with get remote file, you would get the entire contents of the directory, and you could do the same thing with put R local directory. So recursively put everything inside of this directory into the file transfer protocol, and then they would be able to get it on the receiving side while logging in. So this is what an example would look like. So the user Alice on this particular IP address, so you just do SFTP Alice at this particular IP address, you would be prompted to enter the password for Alice. So this is not just going to immediately let you to run ls. That's simply not how it works. So once you run this command, you are going to be prompted to enter a password. You enter the password. If you have the right password, you now are inside of this particular server as Alice, and then you can list the contents of that home directory, so on and so forth. So once you're there, let's say you want to transfer contents to somebody else, you would first do put project zip inside of this particular server, and now it exists inside of that file hierarchy, and then from there somebody else can log in, or you can log in. Alice, for example, can log in from a different computer onto this exact server and then get that exact file onto the machine that they're now logged into. So You can download a file name example from the file system using this. You can put the file inside of the file system using the put command. So it's very simple. Secure copy would be the quick and straightforward file transfer over SSH, which is essentially the streamlined quick version of doing this particular command, which is the SFTP command. And we're going to run through some examples for running secure copy as well. But SFTP is logging into a file system. Secure copy is just transferring the file from one host to another one. And this is what the SCP example looks like. So the command is SCP, and then this is transferring from our computer to the remote host. So you would do SCP and then the path to the actual file that you want to transfer. And then you're going to do the username at remote host and then the path to where it's going to land. And this essentially you kind of can designate wherever you want it to land. This part is very, very important. And what happens as soon as you press enter, you're going to be asked for the password of this particular person at this host. So this is not just going to transfer the file willy-nilly, right? You need to still have the password of this particular person at this host, and then it'll just transfer where this file into this particular location. And it's really as simple as that. There is no logging into a file system, running ls and getting and putting and all of those extra commands. You're simply just doing a secure copy, very similar to a copy command that you would do locally on your computer. You're just doing it from your location to their location. So this is going from your computer to their computer. This version is coming from their computer to your computer. So essentially you've just reversed the order of this particular command, and then you're doing secure copy, the username, and then the path to that actual file, and it's coming to the path on your current directory or on your current computer. And again, as soon as you press enter, you're going to be prompted to provide the password for this username at this remote host so that you can copy the location, or you can copy the file from that location. What's important is that in this particular example, this is actually very important, right? So in this example, it wasn't really that important because you can just transfer this into wherever you essentially want on their computer. That you just need to tell them where you put it so that they know where it is. The path of the local file is important in this version because you just need to know where it is and what file it is that you want to transfer out. In this example, this path is very important because you need to know exactly where the file is that you want to transfer to your computer. And then this part of it isn't as important because you could just put it anywhere as long as you know where you just put that file. So this is what secure copy is and how you can transfer a file securely. And it's, again, very simple command. It's one command that does the job instead of having to log into a file system and do all the rest of the stuff that we did with SFTP. You're literally just doing a secure copy from one location to another, except you're just doing it across a secure port, which is actually port 22 or whatever your port is for secure shell. So this is going across that secure shell port and is copying the file either from their location to your location or from your location to their location. And that's basically what secure copy does. So very, very, very powerful tool to be able to transfer files. You just need to know the password for the actual username on that individual host that you want to either pull the file from or send the file to. And that's basically it for secure copy. Okay, so now it's time to talk about troubleshooting and system maintenance. And the first part of this is log files. So how to analyze and interpret log files. And the very first command that we're going to go over for this is journalctl or journal control for system logs. And journalctl is a very powerful command line utility for viewing and managing logs that are generated by the systemd journal. So this is the more modern versions of Linux that run systemd as their init processes. So it's particularly useful for system administrators and developers to troubleshoot and maintain system health on Linux systems that use systemd. So that's what journalctl is. Now, to be able to view everything on the log, you just run journalctl and then you press enter. and it displays all the logs recorded by systemd journal, starting from the oldest entry to the newest, so chronologically going from the oldest to the newest, and it includes system messages, kernel logs, as well as application logs. The filter by boot, so if you just wanted to see logs from the current boot that's going on, or the current boot session, so to speak, you would run journalctl-b, and this is particularly useful for diagnosing issues that occur during system startup. And then we have filtering by boot, and then you have the -1. So this is logs from the previous boot. You can adjust the number to view logs from earlier boots. So if you go -2, it'll go prior to that, -3, so on and so forth. So -b would be the current boot just by itself, and then -1 would go back to the previous boot, and then you can keep going back further to be able to find all the boots prior to that are still inside of the log. So at a certain point, the log will have most likely stopped recording the boots. So from there, you can kind of just try to figure out how many you have in store in the log, so that you can try to troubleshoot if you need to, or go as far back as the logs will allow you to go. You can filter by a service name by using the -u option, and then you would provide the service name to it. So it'll display all of the logs that are related to a specific service, and then obviously replace the service name with the name of it. So you would need to run the one of the previous commands that we went through, for example, top as an example, to see what all of the various services are that are running, and then from there you can look at the logs that would be relevant to that specific service by using journalctl-u and then the name of the service. And then we have the SSH as the example in this particular case. So -u SSH would display all the logs that would be relevant to the SSH service. If you wanted to view real-time log updates, you would look at journalctl-f, which would be similar to the tail-f command that would be applied to any log file, essentially, because tail would show you all of the bottom entries at the bottom of the log, which would be the most recent entries that have been appended to that particular log file, the entries that have been added to that log file. So it's similar to running tail-f command on that particular log. In this particular case, we're doing journalctl-f, and it'll give you real-time log updates as the entries are added to the log and as the system log or the log itself is being updated. So you could combine this with any of the various log options that are available, so that you can see the most recent or real-time additions that have been going to that particular log. So it's very useful for looking at live system activity or diagnosing issues as they occur. Then you can filter by time. So you can do journalctl-since, and then you would provide it the time as you see in that particular format. And I think that's the universal time standard, I want to say. I'm not exactly sure, but it's in the format that you see on the screen. So I don't know what the technical term for that format is, where you see the year, the month, and the day, and then the hour, minute, and the second. You can say since that time, I want you to show me all of the entries that have come from that time. Filtering by time will look like this if you wanted to provide the actual time into it. So you can see that they didn't provide the second in this example. We didn't provide the minute in this example. We just said from 8 o'clock on November 15th, 2024, I want you to show me all of the entries that have come through this particular log, right? So that's essentially what it will look like. You don't need to give it the time, the minute, and the second, unless you really are trying to narrow down on a specific incident that took place, so that you can get the results that you're looking for to provide further context for your investigation, so to speak. But usually you can just say at 8 a.m. on this particular day, I want you to show me everything that happened since that particular time. So if you wanted to filter by priority, you would just use the -p and then the priority. And the level would be needed to be provided to it. So if it's a level 0, which would be emergent, meaning emergency, to a level 7, which is just a debugging kind of a priority level, you can say what you want that priority level to look like. So it'll say if you do -P0, it's going to show you everything from 0 on up. If you do I guess it would go from 7 on up, so it would show you 765432110, 65432110, so on and so forth. So that's what it would look like if you wanted to go by the priority level and show essentially every event that happens from that level that you've assigned all the way up to all the other levels. You can also do by an error type of a message or an error level message and higher. So still priority flag, so -P and then ERR would be all of the logs that have the error priority and higher, and then it just continues on from there. If you wanted to filter by unit and time, so we're going by the service name as well as the time, you can combine them. So this is all of these commands are able to be combined together. This is not to say that you get to use one or the other, and this is the example that we got in this particular case. So you can do -u SSH and then since November 20th 2024 and on, you know what I mean? So you can combine filtering by services and time, or a variety of other options. So you can service and time and priority, for example. You can combine these various options to filter the log files so you can get the information that you're looking for. So this is what the example itself would actually look like, right? So -u SSH since November 15, 2024 at 8 a.m. It'll show you all of the log items for SSH since 8 a.m. on November 15, 2024. So in summary, you can look at journalctl as a tool for system administrators that are using systemd-based Linux systems. So it won't work for sysvinit because it doesn't exist on sysvinit. So journalctl will only work with systemd-based Linux systems. And then from there, you can look at a lot of different options for viewing and filtering logs. And of course, we're going to go into all of those options and run a bunch of different formats of the journalctl command as we go into our practical portion of this training series, so you can get a good understanding of how to use it and all the different filtering options that are available for journalctl. Until then, this is going to serve as your little cheat sheet so you can view the entire log. You can filter by the boot, you can filter by the service, filter real-time log updates, filter by time itself, and filter by priority. Or you can combine all of these to create a very specific filter to look at a very specific series of incidents that have taken place or a series of log items. So you can combine all of these options to create a very specific viewing rule with journalctl. But this is just a kind of a sample of the common commands that are run with journalctl for looking at system logs. As we discussed in the file system hierarchy standard portion, where we were looking at the main hierarchy of the file system in Linux, we figured out that the logs are stored inside of the var log directory. So a lot of logs are in this particular directory, and this is the central location for log files in Linux, basically. You can get system events, service activities, application behavior, security incidents, and everything in between. Analyzing these particular logs, sysadmins can troubleshoot issues, monitor system performance, and enhance security. And in a lot of cases, you don't even have to do it manually. You can use a security appliance to do it for you, or you can you take all of the logs that are in this particular location, feed it into Splunk as an instance, or you can connect Linux into Splunk so that it gets live updates from your logs, and then from there it can help you analyze the events that are going on in your logs. If you don't want to pay for something like Splunk, you can always use Wazoo or a variety of different tools that we have. Kibana from Elasticstack, that's another really good one that you can use. That's an open source tool that can be used to look at log files. So very, very useful location because it holds all of the logs that have to do with everything that goes on with your system. So some of the key logs inside of the verilog directory would be the syslog or the messages log, so to speak. So these are the general system log files that record a wide range of system events, including kernel messages, application logs, and service activities. So it could be either the syslog or the messages log. And so there's the distribution differences that would be relevant to these particular types of logs. So when you see syslog, it's for Debian-based systems like Ubuntu. When you see the messages, that's for Red Hat-based systems like CentOS or Fedora. So the usage again would be to use tailf, for example, or just use journalctl, for example. But in this particular case, since you're looking at an actual log, you wouldn't be using journalctl because journalctl has its own series of logs. So in this particular case, we're going to be using tail-f to look at the last series, the bottom portion of this log file. You would look at the last 10 lines, for example, which would be the most recent entries inside of the syslog file. Same thing with this one, where you would look at the most recent entries inside of the messages file. Another one would be the authentication log, the auth log. And this file contains information related to authentication and authorization. So anybody who's trying to log in, any login attempts, whether they were successful or unsuccessful, user authentication processes or privilege escalation attempts, all of these things would be stored inside of the auth log. So anything that has to do with authentication or authorization would be stored inside of the auth log. And the view, again, would be tailf to look at the most recent additions that have happened to this log, and it will show you everything at the bottom of that log file by using the tail command. So this is very important for unauthorized access attempts and anything that is also security related. So the authentication file, or the auth log, I should say, this is one of the key files that security analysts will constantly look at and keep an eye on, especially in a large environment, because you want to see if there are any failed login attempts or repeated failed login attempts or successful attempts that have come in during odd hours of the day, or anything of the sorts, just to figure out if people who should not be logging in are actually logging in or trying to log in. Then we have another one, which is the DMESG, so D-message. I kind of look at it like that, but DMESG could be the one. It records messages from the kernel ring buffer, which contains information about hardware components and the status of the hardware. So the initialization of the device itself, for example, or the drivers that may be connected to your system for your printer, or anything that is a physical connection to your computer, or any other hardware error that may go on with your individual machine. And again, it would be used as the tailf command to look at the most recent entries that have gone into this particular log file. So it's very useful for diagnosing any kind of a hardware issue that's going on and understanding the state of kernel activity. So if you remember, the kernel is the entity that connects the user and anything that we use as the user to the actual hardware. So it's the bridge that connects the hardware and everything inside of the actual physical computer to us, the user, so that we can communicate with it. So if there's any kind of a kernel issue or any kind of a kernel hard troubleshooting that you need to do, you would do it with the D-message log. And then we have the secure log, and this is specific to Red Hat-based systems like Fedora or Red Hat Enterprise Linux. This is the file that records security-related events, especially those related to secure shell as well as other secure services. So SFTP, for example, or SCP that we just recently covered in the last chapter. So this is where anything that has to do with secure versions of a specific service, all of those things would be logged in this particular file, and this is for Red Hat-based systems. So it wouldn't apply to Ubuntu, for example. It would be CentOS, it would be Fedora, and everything along those lines that would be considered a Red Hat-based system. And this is the viewership. So this is just a command, and by now you should have memorized this. So sudo tail-f, and then you would give the path of the log file, and then it would give you the last 10 or 20 or however many lines that you would designate on this particular log, which would be the most recent incidents that would happen inside of the secure file. So for example, failed login attempts and changes in user permissions, which all have to do with security. So anything that has to do with security and everything that we covered in our security portion of this training series, most often than not is going to be inside of this particular log file for Red Hat based systems. So this is our first example here. So if you want to monitor a general system log, you could look at the syslog that would be on a Debian-based system, or if it's on a Red Hat-based system, you would look at the messages. If you wanted to look at recent authentication events, you would look at the authentication log or the auth log. That would be anything that has to do with authentication or authorization. And again, the tail would give you the last 10 lines or the last number of lines that have been entered, which would represent the most recent. If you just wanted to look at everything inside of that file, you could just open it up with nano. You would still need to do sudo nano, but then it would open up the entire file, which is a very massive file, most likely. So it will be very overwhelming. You can search through it with grep, right? So the various tools that we've covered. And then we're going to do a lot of these things as well when we get into the practical section. But typically you would look at tail, or you would use tail to look at it so that you can see the most recent authentication events that have taken place. Another example would be kernel messages. So you could do dmesg, and that would give you all of the kernel messages. Or you could look at the most recent entries to that in real time, for example, which would be the tail-f, which give you all the recent entries that have gone into the dmesg file. And then you have looking at the secure file, so security-related events on a Red Hat system, which could be anything that has to do with secure shell, secure file transfer, anything that has to do with changing permissions or ownership, for example. All of that stuff would be inside of the secure log file itself. So in summary, we have the var log, however you want to pronounce it. We have this particular directory that is a treasure trove of information. It contains logs for everything. All of the logs are inside of this. And when we actually look at the log file, when we go into the practical portion of this, and I'll do an ls command for you so you can see the number of log files that are inside of this thing, it's massive. The ones that we went through are key log files that everybody should know about, but there are literally dozens of log files that are inside of this particular directory, and you can get a lot of different information from those log files. So it all just depends on what you're looking for. And in a lot of cases, individual applications that you install will also get their own log entries that will come inside of this exact directory. So there might be something for MySQL, there might be something for Apache, and a variety of different software services that would be installed on that machine that they get their own log files as well. So they're just important location for you to consider, right? So anything that has to do with security and security administration or troubleshooting would all be done from these log files that are stored inside of our var log directory. And these are some of our specific logs that you should keep in mind just as a screenshot. So you've already seen all of these, so I'm not gonna go through all of them, but if you wanted to screenshot this, 1, 2, 3, and time's up. Okay, now we need to look at the usage of the disk itself and any cleanup that would need to be done. So we've already looked at this particular command, which is the df command, and df and du kind of go hand in hand, and they help you look at everything that has to do with your disk. So disk usage analysis and cleanup is very important for maintaining system performance, because a lot of times clutter tends to add up inside of the system, and you just need to make sure that you are good with your storage, right? Especially if you're managing a bunch of different users and they have a bunch of different files and media and everything that they're downloading and using. There needs to be disk usage processes in place to just make sure that you are good with storage. This is more important for storage than really anything else, in my opinion, but it's also a security issue as well. So you just want to make sure that there is no, you stay ahead of it so that there are no issues and the system doesn't crash because it doesn't have enough storage, or the RAM doesn't slow down, or any of these things, because there's just too many things for the system to be taken care of. So the two primary tools that we have are df and du. So df is the disk file system, as you should already know. And it's a command line utility that displays information about the available and used disk space on our file system. And this is just one of the simple commands. So the -h option with df is human readable. That's what it stands for. So it formats the output in an understandable way, meaning that it'll give you kilobyte usage, and it may give you a tree breakdown or like a tree format view of it. So you can kind of have a good understanding of what you're looking at on the terminal. So df-h will give you the disk usage as well as the memory usage and all those things in a human readable format. So this is what the potential output might actually look like. So you run it, and then you can see that for this file system, which is our primary SDA file system, partition 1 has a size of 50 gigabytes, 30 gigabytes has been used, there's 20 gigabytes that's available. The percentage would be 60% of this total space has been used, and it's mounted on our root directory. And then the second partition has 100 gigabytes assigned to it, 70 gigabytes has been used, 30 is available, which means that there's a 70% usage, and it's mounted onto the home directory that's inside of the root. And the home directory specifically is for all of our users. So it makes sense that there is more usage that has been done over here, because most likely there's multiple users that have files and media and everything that's being stored inside of that directory. So it's using up a lot more space. So that's what the disk usage, the df command, helps us find. And du itself is the disk usage. It stands for disk usage, and this is a command line utility that estimates and displays the disk space used by files and directories. So it's actually very similar to what we're doing with our disk file system command, right? So it's really not that different. The intention of it is the same, just a different command, and it gives you a little bit of a different response here. So you would do disk usage du-sh, and then you have to give it the path to the directory. So -s stands for the summary of the total disk usage, and then the H stands for the human readable. So same thing as the disk file system portion. So the human readable, and then give me a summary. And so the example command would actually be this. So disk usage -sh for the home user directory, and it just gives you that there's 5.2 gigabytes on the home user directory that has been used. So disk usage, 5.2 gigabytes on that particular directory that has been used. If you wanted to look at the full directory and then do a little bit of sorting and give you the top 10 lines, for example, so this is what this entire command is doing for us. So we're looking at a human readable format for this particular path, and then we're going to take this result and we're going to pipe it into the sort command, and then we're going to take the top 10 lines from all of the output that we got. So disk usage H will give you the disk usage for the specified path in human readable format. Sort RH will sort the output in a reverse order. That's what the R stands for. And then based on human readable sizes, which is what the H stands for. And then the head N10 will show you the top 10 largest directories. If we did tail N10, it will give you the bottom 10 largest directories. So we're sorting it, and typically when you use sort, it's in ascending order, so it'll go in alphabetical A to Z or numerical smallest to largest. So if we want to see the largest first, we would do it in reverse order, which is why we have the -R, and then H would be the human readable portion of it, and then now it gives us the top 10, which would be the top largest file. So this is potentially what the output itself would actually look like. So we're looking at the var directory that has all the logs and everything in it, and then we're sorting it in reverse order, and we want the top 10. So it says the log directory, understandably, because there are so many log files and they take up so much space. So the log directory would have the largest portion that it's taking. It takes up the most amount of gigabytes, the biggest size, right? And then you have the cache, which is also understandable. So 1.8 gigabytes. The library has 1.2 gigabytes, and then the www, that has to do with HTTP, or typically it has to do with the Apache server or any kind of a web server, that is holding up 900 megabytes of data. So some practical examples here. We have the df-h will give us the human readable disk file system command that will break it down for you by the file system and show you how much of it is being used and how much is free. Disk usage -sh will show you everything that's going on this particular path, and it will give you the summary as well as the human readable format version of it. And then this would be the full thing if you wanted to look at everything for the home directory and then sort it in reverse order in human readable format and give you the top 10 results from this particular command. So that's how you would analyze all of those things. So as a summary, you have the disk file system, the DF, that provides an overview of the disk space usage by file system. It makes it easy to see which partitions are filling up, and it gives you everything on a line by line, as you already saw. And that's the command df-h. And then you have the disk usage that gives you detailed insights into the actual usage by directories and files. So you can identify which areas are consuming the most space. This would be the summarized version for a given directory, the summarized -s and then -h for human readable on this particular directory. And then you can analyze it by using the sort command in reverse order and then giving you the top 10 results. So those are our summaries. But again, we're going to be running this as we go through our practical section. So you'll get a lot of opportunities to actually run this and use it. And that doesn't mean that you can't run these while you're watching this. So this is going to be, this is technically the lecture format, as I say it literally at the end of every summary section. So I just want you to keep all of that in mind. So you can definitely be running these as we're going through the lecture, but we're going to do like a deep dive on all of these things when we get into the practical section. So let's talk about disk cleanup tips. So disk cleanup, it helps maintain the system performance, ensures that you have adequate storage for new data. There are also essential tips and commands that we're going to be going through to make sure that you accomplish all of those things. Disk cleanup is a very important concept, and it's something that you should be thinking about all the time as a Linux administrator. So why do we do it? We want to remove any unused packages because they accumulate over time, they take up a lot of space, and it kind of messes with your overall storage. They can also include dependencies that are no longer required by any installed software. So you just want to make sure that you get rid of all of those things because they're literally just taking up space and there's nothing that is actually using those dependencies because they could be outdated, they could be upgraded, a variety of different reasons why they're no longer relevant. And you just want to be on top of this. You want to do this routinely. You want to do it in a scheduled manner so that it doesn't run away from you. You just want to kind of stay on top of this. So to be able to remove unused packages, you would use the apt package manager command. So we would do sudo apt and then you just do auto remove. And it removes packages that were installed as dependencies and are no longer needed by any installed packages that are currently being used. So auto remove removes anything that was installed as a dependency and is no longer actually being used by any other packages, which is very, very useful. You don't have to go through the list. You just run sudo apt auto remove and it automatically removes anything that is irrelevant. And then we can do it on a Red Hat based system. So same exact thing, except you're just using DNF as your package manager. So DNF instead of apt. And then you just do auto remove, and then it removes unnecessary packages and dependencies that are not being used. The second reason why you want to do this is to clear all the temporary files, which can also accumulate inside of the temp directory, which take up disk space. So for the most part, it's safe to delete all these things, but you just got to be sure that there's nothing that you actually need or any applications that may be using any of these critical temporary files, for example. So for the most part, you can delete all of these things because if they weren't meant to be temporary, they wouldn't be inside of the temporary directory. So that's my approach to it. If they were not important to be put inside of the key directories for the actual library for that specific application or the optional directory or any of the other directories that can be used, if they've been put inside of the temp directory, for the most part, they're good to go. The command would be remove, so we're using the rm command. And then you would do the rf option, which is recursive. So you're doing a recursive to delete all of the files for the temp directory. Now notice that there's an asterisk at the end of this particular path, which means asterisk, it stands for a wildcard character. So it's going to remove literally everything that is inside of the temp directory because it can be anything. The asterisk stands for anything. So TMP/* means that anything that comes after this path, it can be removed recursively and all of the files and directories will be removed. So this is a very powerful command. Again, it'll permanently delete everything. You just got to make sure that none of these things are relevant. But again, this is just my process, my philosophy around it, if it's inside the temp folder, most likely it was going to be deleted anyways, because it typically does get deleted on reboot. So most likely it was going to be deleted anyways, or at least deleted after a certain amount of time. Otherwise, it would not be placed inside the temp folder. So for the most part, I think it's good to go. Then we have removing older journal logs. So this happens with a lot of log entries that have to do with the system, for example, because it'll log everything on the system, even if it's just informational, even if it's nothing that is critical or nothing that needs to be addressed. It just keeps logging everything. So over time, it'll be a lot of log files, massive log files that take up a lot of space. So it's important to periodically clean these, or set up some kind of a script to periodically clean these specific log items, so that they're only maintained for, let's say, 6 months, or they're maintained for a year, or however long is relevant to you. But after that 6-month period is over, if it's older than 6 months, it should be deleted and you should move on from it. Or maybe if it's older than 6 months, it should be transferred out of your system and put into an external drive or something like that. And that's the way that you would manage your log files. So in a lot of environments and a lot of enterprise environments, and based on regulatory environments or compliance issues, based on regulatory compliance, you may be required to keep logs for longer than 6 months, but you can transfer them from hot storage, which is what's on the computer and it's accessible all the time, to warm storage, which could be an external drive that's easily accessible. You could just plug it into the computer and get access to it. Or if it's super old, you can put it into cold storage, which means it's now sitting inside of a warehouse somewhere, and then somebody would have to go retrieve it in order to be able to access that information. But it's being placed in storage. It just depends on what the compliance environment that you're in and what they require. But typically, usually if it's 6 months or older, especially if it's just you on your computer, if it's like older than 3 to 6 months, you can just wipe it and move on from it. In an enterprise environment, it's a little bit different. But for your computer, for a specific personal computer, you really don't need to hold on to log files that long. The way that you could do this is by using the journalctl command, and then remove the stuff that is older than 2 weeks, for example, by using the vacuum time. So this command removes journal logs older than 2 weeks. And you can adjust the time frame as needed. So you could do 2 days or 1 month or whatever, and journalctl will remove those items based on the time that they were in. You can clean up packages by doing the sudo apt clean or sudo dnf clean all, which will clear the package cache, freeing up space that are used by downloaded package files. That one's pretty self-explanatory. And then you can do a local purge, which would remove unnecessary localization files according to the local machine. So the purge command is kind of funny to me, but it removes unnecessary localization files for languages that you don't use. So you got to install it first if it's not already available, and then you would run it, and it would purge. It would purge all of the languages that aren't being used from your local machine. We can do find and delete of large files. So if it's larger than 100 megabytes, for example, in this particular case, you're looking at the find command, which we've already kind of been introduced to, and it's looking inside of the root folder for the file type. So type F would be a file that has a size of 100 megabytes or larger. And then once you find these files, you can delete them if they're no longer of use to you. And then analyzing disk usage with GUI tools, which are graphic user interface tools like Baobab disk usage analyzer on GNOME, or KDirstat on KDE. And then you would have to install them, obviously. And then once you have them installed, you can sort through your computer and browse the computer to find anything that would be larger than a certain size or anything that's older than a certain period, and remove all of those files and folders if they're no longer applicable, or at the very least transfer them to an external storage. So in summary, you can use a variety of different tools to clean up your disk. And just doing this regularly in a scheduled manner will help you avoid any kind of storage issues. And so it could be done as easily as using the apt package manager and auto remove. It could be done with using the DNF manager and doing auto remove. You can remove recursively anything that's inside of the temp folder. You can use journalctl with the vacuum time to 2 weeks to delete anything that's older than 2 weeks or anything of that sort. All right, now we need to talk about backups and restoration strategies. And one of the big pieces about this is going to be the command known as tar. And tar is a command that is used to create archives. It's an acronym for tape archive. And it's a command line utility to create and manipulate archive files. It compresses the multiple files into a singular archive file. It can also work with directories as well, which makes it easier to store things and to transfer them, to manage backups, so on and so forth. It can support various methods, for example, the gzip, bzip, and xz, which it's separate from the zip command, which is another command that can compress data or compress files and directories into a singular zip file, a compressed file. It is separate from that, but it's technically not considered creating a zip file. It creates an archive file. So that's, I would say, the key difference. But I mean, it does compress the multiple files into it. So it does essentially the same activity. It serves the same purpose as creating a zip file. So to create an archive, you would do it with the tar command, and there's a variety of options that we've attached to this. So I'll explain them in the next slide. And then you create the compressed file, which would be this in this particular case, and then this will be the path to the files that you want to compress. So if we want to break this down, the first portion of those options would be the C flag, which is to create. So it creates a new archive. The Z flag compresses it into a gzip, so a zip folder, a gzip file. V would be verbose, meaning the files that are being processed are going to be displayed onto the screen. So this is not necessarily, it's not necessary for the function of tar to work. It's just going to display onto the screen what's actually being processed and how it's going. And then the F portion is specifying the output file name, which in this particular case is backup.tar.gz. So this is necessary for the function, this is necessary for the function, this is necessary for the function. If you leave this out, if you leave the -f portion out, what it's going to do is it's going to create its own name, and then you would have to rename it after the fact. So if you just add the -f, you can designate what you want the name of it to be, and then the path to the file would be the actual file and directory that you want to be archived. So in this particular case, it's just one path that's been provided, and then everything inside of this path is going to be archived into this backup.tar.gz compressed file, right? So you use -c to create, -z to turn it into a gzip, and then -f to designate the name, and then -v is just a verbose output so that it displays everything onto the screen as it's being processed. Then you have the backup of these documents. So for example, again, you're creating another archive in this particular case, but now it's going to be a backup that is being created of the user documents. So pretty much the same exact command that we just ran in this particular case, in this case right here, except now we've actually given the path that we want in this particular case, and it's going to be, it looks like this, right? So we're creating a backup of the home user documents, and it's being placed into this particular backup file right here, which is again same exact options that are being assigned to it, and it's creating a gzip file for us. So if you want to extract the archive, now you're going to do similar options here. The flags are a little bit different, and the very end right here where you actually create the destination, the path to destination, also requires a flag for it as well. So if we were to decipher that, or if we were to, what's the word that I'm looking for? Not decipher, not splice. I'm drawing a blank, but it'll come to me. So if we were to break it down, basically, what we're going to do is the first piece, instead of C, we have X. So instead of creating a file, we're now extracting a file. So the first option, the first flag is the X. And then the Z would to designate that we're decompressing the archive using gzip. So this would have to be a gz extension right here in order for this to work. If it was a different type of an extension for this archive file, you would use a different option inside of this. So the Z represents gzip, meaning that we're decompressing a gzip compressed file. The V is still verbose to display everything that's going on. And then the F would specify the input file name, which in this case would be the backup.tar. And then we have the C for the directory, meaning the destination directory for the extracted files. So everything here looks almost identical to creating an archive, except in this case we're extracting it, and we're going to use the X flag here to extract. The Z is still the gzip, and then the V would be verbose. The file would be the name of the file that's going to be extracted, and then we've added this capital C flag over here that would give us the path to the destination of where it's going to be extracted to. So extracting the archive as an actual example here, where we have the backup tar that we just created from the documents, and then we're going to designate the place that it's going to be transferred into once it's been extracted, which is going to be the home user restored documents. And this is essentially the same exact command that we just saw with actual content filled in. The actual path has been filled in this particular case, and then the name of the backup file has also been filled in. So if you want to list the contents of an archive, you could use the tvf. So V and F you should already be familiar with. So V is going to be for verbose, F is going to be to designate the file name in this case, but then you're using the T flag, which stands for list. So list T. So it's going to list the contents of the archive without actually extracting the contents of the archive. So we don't have an actual breakdown of those commands. What we're going to see in this particular case is that this is literally the closest thing to the breakdown of the command. So you're already familiar with V for verbose. F is going to designate what the file is that you're going to try to look at, and then the T flag is going to list the options or list the contents of this particular archive file. Now, if you want to exclude files from the archive, then you're going to use very similar set of commands here, except there's this last piece right here, which is going to be the piece inside of this directory that you want to be excluded, right? So you want to archive everything inside of this piece with the exception, so excluding this path. So notice that path to files is still here. So we're still trying to archive this piece right here. The only thing that we're doing is that this exclude me portion is not going to be included in this archive file. So you can actually create an archive and then exclude a certain portion of this directory from your overall archive that you're creating. So exclude is the command here. So -- exclude, and then you need to give it the full path of the directory or the file that you want to be excluded from this backup file that's being created, from this archive file that's being created using tar. So to append a file to an existing archive, you can do this as well. So you can do the R option to append. Now this unfortunately is not R in any way, doesn't equal append, or it's not included in the word append, so you kind of have to learn this one and kind of memorize this one, or just save this, right? Save this command for future use. If you're not going to get the documents or the slideshow from Hackaholics Anonymous, I hope you're creating your own file with these commands inside of it. So at the very least, I hope you're doing that. But again, you can just come to the video at this portion and just look at the archiving function with tar. So there's a lot of different ways that you can come back and refer to this. But anyway, so we do have the V for verbose. We have the F to designate what the file is going to be. And then in this case, we're using the R flag to append something to this backup file right here, to this archive file. So it'll append the additional files to an existing archive, and the R option stands for append. So this is going to be our existing archive, and then this is the path to the additional file that you want to be appended into this archive. So this is actually very neat. It's very useful because when you create a zip file, you can't append something into the zip file, but you can do it using the tar command, which is actually very handy because sometimes you want to just add things to an archive file without creating new archive files. You know what I mean? You just want to keep the same archive file and then just add something to that archive. So for example, new versions of a log file inside of the var log directory, instead of creating new archives, you just keep adding those same log files as the time arrives. You just add them to the same archive file. So you could just have one archive file for the authentication log, for example, the auth log. You can have just one archive file for that, and then anytime that you do a backup, you just add the new archived file or the new log file that's been created. You just add it to the same authentication backup archive, which is, again, it's very, very handy. It's very useful. So this is an example that we have over here that we're now going to kind of go through to create a backup. So it's very similar to what you've already seen in this particular case. We have all of the same flags as we had before. And in this backup file, we actually have the date that's been attached to it to kind of give us an understanding of what this backup represents. And then we have the documents folder that's being backed up. So backup of 11/15/2024. And then it has all of the documents or all of the contents of the user's documents that's going to be backed up inside of this file. So very, very handy little command. And then now we have the extraction of that backup. So same exact archive file, except now we're extracting it and we're using the capital C flag over here to designate where we want it to be extracted to, and the X flag right here to designate that we're extracting instead of creating. So the rest of it is exactly the same. It's a gzip file, it's verbose, and then you're designating the file name that you're going to be working with, and then it's going to be extracted into this particular location, which is going to be the new location for those restored documents. And the third example that we have is to list the contents of that backup file. So this should have probably been example number 2, where we list the contents of the backup file and then we extract the backup file. But T would represent list. So you're listing the contents of this backup file or this tar file, this archive, without extracting the contents of it. And that is it. So our summary here is that it's obviously very versatile. It's very powerful, as you just saw from the examples that we saw. By mastering just a few key commands, you can efficiently back up and restore files and honestly create a lot of really good scripts, because now that we know that we can append something using the R flag, for example, when you can append something to an existing archive file, that means every time that that script runs, and it could be a scheduled task that you schedule with cron tabs and cron jobs, and every time that that backup file or that archive script runs, it's just going to append the contents of whatever it is that you're trying to do inside of the same exact archive without creating a new archive file, which is honestly, I actually love that. It's very, very useful. It's very handy. And as I'm going through this, I'm like, okay, well, why haven't I created a script for that? So you better believe that I'm going to create a script that's going to use the tar command to append the contents of my logs for my own machines inside of the same exact archive file, which again is just super freaking handy. So incremental backups that can happen with rsync will be our next piece. So it's a very useful, versatile, efficient utility for synchronizing files and directories between different locations. It's particularly well suited for backups because it transfers only modified files, reducing the time and bandwidth that's required for the operation. So it essentially detects which files inside a given location have been modified, and if they have been modified, then it'll back it up, which is again very, very useful. So you have the key features here, which are the incremental transfer. So only modified portions of the files are transferred. So think about what it means to sync something, right? So if there's one new addition or one new modification that's been made, it's just going to get resynced. It's very similar to what happens when you have iCloud, for example, and your iCloud storage will detect any new additions that have been made to your phone's contents, and then it'll back it up to your current cloud, and it won't take everything that you previously had. It's only going to take the new additions that have been made into your phone and then just add those into your iCloud backup. So it's very, very useful. It only detects things that have been modified, right? It's very versatile. It can be used for local backups as well as remote backups over secure shell, which is freaking badass. It preserves file attributes, so it maintains permissions, timestamps, and any other attributes that were originally created on the original file as it synchronizes to the new backup location. So very, very useful little tool. So the basic command structure here is we have rsync with the AV flag, and then this is the source location, and then the destination directory. So A to archive, and then it enables archive mode, preserves permissions, symlinks, everything else that's the attribute for this source directory and all of its contents. And then verbose to provide a detailed output of the synchronization process onto your screen. And then the source directory is the path to the source, and then the destination would be the path to the destination. So very simple command, not complicated to understand at all. And we're just running rsync with the two flags right here. You got to give it the source directory and then the destination directory, and then it's going to do exactly what it should. A basic sync, as an example, using actual directories here. Again, same exact command with the archive and the verbose flags attached to it. Now we're just saying the home, the documents from this particular user is going to go into the backup documents, and that's pretty much it. Syncing over SSH, which is the one that I'm most interested in, would be something that the flags, the initial flags are staying the same. So you still have the archive and the verbose flag, but now you have this E flag for export, I would say. That's really the thing that I would attribute the E to. And it's going to use the SSH protocol to be able to transfer it. And then source directory. And then you have something very similar to what we did with secure copy. If you remember the instructions that we went through secure copy, that you would have the user at the remote server, which would probably be an IP address, for example. So you'd have the user at the remote IP address, and then you have this colon and the path to the destination that this backup is going to take place. Once you run this, okay, you need to probably provide a password for this user, unless you generated a key that has been attached to the key log, not the key log, I forget the technical term, but essentially it's the storehouse of the local keys on your computer that would not require you to enter a password every time you did this. So if you want to run this as a part of a scheduled script, for example, inside of your cron jobs, then you would definitely need to take the actions that we took when we generated keys, so that you can have a passwordless authentication for SSH, and then this would run every single time without needing the password to be entered for this particular user, so that it can back up this directory inside of this destination. So it's not complicated to do the backup. It's actually quite easy. You would just need to designate that you're going to use the SSH protocol, and then you have to have the credentials and the location for where this is going to go. And then if you have used a key-based authentication method, you won't be prompted to enter the password for this particular user. And then from there, it'll just run like clockwork. So syncing over SSH is a very, very powerful tool. And then this is it right here, right? So we have Alice at this particular IP address, and then it's going into the backup documents for this particular IP for the Alice user. And then that's it. And this is assuming that we already have Alice's key inside of our keyless authentication, or not keyless, passwordless authentication, or we know Alice's password. So as we run this, we would enter Alice's password, and then it would just back up everything inside of this location on Alice's user profile inside of this particular server. So very, very useful little command is rsync. So if you want to back up something with deletion, so if you want to delete, right, it ensures that the destination directory mirrors the source directory by deleting files from the destination that no longer exist in the source. This is very useful, right? So if, for example, you no longer need the contents that you deleted from the source. So let's say you had 100 pieces, 100 files. You had 100 files. You have updated 50 of the files, and you deleted 50 of the files, okay? This destination still has those original 100 because you already did one backup. When you run this flag right here, it's going to sync these two destinations, and all of the files that were deleted from the source because you didn't need them anymore are now also going to be deleted from the destination. So it's going to sync them, and make sure that they match exactly, and only the files that exist inside of the source are going to be the files that exist inside of the destination. So it's very, very useful command, and this is something that you can of course combine with these commands, as well as if you wanted to run it with the SSH command, you can combine all of those options together and just add this delete portion, so that anything that would be a duplicate or anything that no longer exists in this source location will also be deleted from the destination location, ensuring that you're not holding on to old files that are no longer relevant. So that's very, very useful. So this is actually what it looks like using the delete command and some actual paths here. So we have the home user documents and then the backup documents. And of course, it's going to synchronize the contents of home user documents with backup documents, deleting any files in the destination that are not present in the source. So deleting any files here that no longer exist in this particular location. So here's our example here. So we have the rsync with the AV flag. So we're archiving and we're going to have a verbose output, and we're taking the contents of this and we're putting it inside of this project's backup folder. We have another example that is being done with the SSH protocol. So we have to add the -e flag here to designate that we want to export into SSH. We're taking the contents of the home user projects and we're putting it on Alice's profile on this particular server with the backup project's location. And then we have the delete command that's also being added to this. And again, this also could be added to this particular command as well, right? So you could have the AV --delete and then -e SSH, so on and so forth. And then that would ensure that the contents of here match this content. So it would delete anything inside of this location that no longer exists in this location. It deletes the stuff in the destination that are no longer in the source. And that's our destination, that's our source. So very useful series of commands. We have a couple of additional options in this location. So we have the -progress, --progress, which displays detailed progress information for each file during the transfer. So it's similar to verbose, except I guess it's showing you kind of like a percentage update. We'll be reviewing this as we go through our practical portion, so you can actually see what this looks like. But it's going to display the progress as the transfer for each file is taking place during the overall transfer process. And then we have the preserve hard links command. So this is the hard links portion right here, which preserves hard links in the source directory. So this location, the hard links, if you remember, soft links are essentially shortcuts to a certain file or a command, and a hard link is the duplicated version of that. So if you have two files, the hard link would be a duplicated version of the file, whereas the soft link would just be a shortcut that points to the original file. So in this case, it's preserving all of the hard links in this case, which, I mean, assuming that you want to keep these things, I personally don't know why you would have to designate this. Maybe as a part of the sync process, it sometimes might delete it, but I would say include this in everything. If you want to keep everything that is inside of the source directory and then delete whatever's been deleted from the destination, that's all fine. But just add this, I would say, to every single time that you run rsync to ensure that it's keeping all of the hard links inside of the source directory. That feels like it's an important command that should be run every single time. Then we have compressing of the data during transfer. This is another thing that's very, very useful. So the Z option compresses the file data during the transfer to reduce bandwidth usage and to reduce the space that is taken inside of the destination directory as you transfer the file. So this feels like another option that would happen frequently, especially if you're not going to be transferring this stuff back and you're mostly doing this for backup. So if you're not going to do regular access of the destination directory and you're just doing this to back up your stuff for recovery purposes, for example, then you would add the Z option to compress the data so that it can take less space as well as reduce the amount of data that's being used for the transfer. So the bandwidth usage that's being used during the transfer, that would be another one of those flags that I would say should be ran every single time, unless you're going to access the contents of the destination folder while you get to that location, or you're going to use it from a different computer or something like that, and you want to have uncompressed files, I guess, or like live type of files that haven't been compressed, so that they're easily accessible and you don't have to go through the extra step of decompressing them decompressing them and get access to them, essentially. So you don't want to decompress them and you just want to access them, essentially. But for the most part, if it's just being for backup purposes, so for future recovery in case anything happens and your system crashes or something, I would say that you should compress all of that data. So in summary, rsync is actually very useful to do incremental backups, because what it's going to do is going to update this the destination location only with the changes that have been made in the source location. It's flexible. It has a range of options that make it suitable for a variety of backup scenarios, both locally and over the network, using something like SSH. You have our basic sync command that we've gone through. We have the SSH sync command that we've gone through. And then we have the delete version of the command that's also very useful, that will delete anything inside the destination that no longer exists in the source. Very, very useful tool, which is rsync. Which brings us to system performance monitoring. So monitoring the CPU, memory, and the processes that are running using a tool called top. Now, top and htop both perform essentially the same function. So what they do is they list the processes that are currently running, the services that are currently running on your computer, and they show you how much CPU each one of those things is using, how much memory or RAM each one of those things are using, and the PIDs and certain details about each one of those processes. And it's a dynamic list, meaning that it updates in real time, and if something is taking up more memory than the next thing, it'll go up in the list. And it's a live list, right? It's not something that is just stagnant and then you run it once and then you just get this list with the line items saying exactly the same. So it's a live environment type of a monitoring. So what it looks like is you just literally run top and you press enter, and it provides the dynamic real-time view of what's going on in the system, so the processes that are running on the system and the amount of resources that each one of them is using. This is included in most Unix operating systems and Linux, obviously, and it's actually on macOS as well. So if you just run top and press enter, it'll actually show you all the commands that are running on macOS in a live environment and how much resource each one of them is using. This is used all the time for system administration as well as security. So if you just want to see if like a computer slows down or if a server slows down drastically and you don't know exactly what's going on, you would run the top command to see what is running and how much resources those things are taking. And more often than not, you kind of reverse engineer, not based on the name of the service, but based on how much resource it's using. So if it's using a lot of the RAM or if it's using a lot of the CPU, then you can say, okay, well, this seems kind of funky. What is this particular process? And then you start doing the rest of your investigation that way. The command itself is literally press top and press enter, and then it'll start displaying the output, and it's updated regularly. It typically goes 1 second at a time, but then you can change it so that the incremental updates are done by 5 seconds or 10 seconds or something like that. If the 1 second update is a little bit too much, which I think it has, in my opinion, it is too much because it's kind of hard to notice what the commands are. So you can change it to a 5 second update, and it'll change, or it'll update itself continuously, but it'll do it every 5 seconds instead of every second. When you navigate this, so this is actually something very useful to understand. So you can use a lot of different commands to interact with it while it's running. So when you press top or you type top and you press enter, the output on the screen is just going to stay there until you exit it. So what you want to do is you want to interact with the output as it's going around. So if you press P while top is running, it's going to sort everything by CPU usage. So P, CPU, P, CPU. So you press P, and then it'll sort everything by the CPU usage, making it easy to identify what's going on and what's consuming the most CPU. If you run M, you would be sorting by memory. So that one's very easy to understand. So another way that we can look at CPU would be P for processing. So processing would be the sorting mechanism when you use P. So it's going to use CPU processing power. So central processing unit, think about it like that. So the central processing unit, so P would be for processing. M is for memory, so the RAM, random access memory. So it's going to sort by the RAM usage and how much RAM the process is currently using. If you press K, then you would be ordering top to kill a process. So you would press K, and then it's going to ask you, or it's going to give you the option to enter the PID of the process that you want to kill. So let's say that using P and M, you have determined that there's one specific process that's taking up a lot of resources, and now you want to kill that process. So you would press K, and then you would provide the PID for that process so that it will be killed automatically, or immediately it'll be killed by your system, and hopefully it will not take any more resources from you, and it'll just kill. Sometimes you may need to do force kill, which is a different command, but just K by itself, it will kill a process. If you want to quit top, you just simply press Q, and then it'll exit the top interface. So remember, when you enter tops, you type in top, press enter, you're now inside an interface that is going to be interactable, so you can interact with that interface. Once you're done interacting with it and customizing the display and getting the information that you need, killing a process, doing whatever you need to do, you would need to exit top, and then the way that you do that is by pressing Q, and then it'll exit the top interface. The next one is htop, which is the enhanced version of top that offers a more user-friendly, colorful, and interactive interface, but it essentially provides the same processing, or it provides the same service and utility that top does, except it's just a little bit more user-friendly. It's colorful. Instead of just a bunch of black and white entries on the screen, you actually get color coding that happens with the entries on the screen, and it improves the user-friendliness of it. So you would run install htop if you don't have it. So it's a sudo command. So sudo apt install htop, or sudo dnf install htop, because it does not come pre-installed. So top comes pre-installed with Linux, but if you wanted to install htop, you would need to actually install it, and then you would run it according to the various commands. So for example, run htop, press enter, and then it'll start the tool, and it's very similar to the interaction that you would have with the top tool. So it provides the enhanced user experience with easy navigation. If you want to view processes, or viewing the processes would be the main screen, and it gives you the list of processes similar to top, but with more detailed and accessible information. If you wanted to sort by columns, you would do F6, and this, I don't know what the replacement for this is if you don't have F6 on your computer, or on your keyboard, I should say. So what I'm going to do is I'm going to actually get that information for you now. Okay, so thankfully it's actually fairly useful. So if you don't have the F6 key on your columns or in your keyboard, for example, to organize the columns, then what you do is just use the left and right arrow keys to move through the columns at the top of the interface. And then once you've landed or highlighted the column that you want to sort, you press enter. And that's it. So it's fairly simple, fairly straightforward to organize the columns if you don't have the F6 key on your keyboard, which I do realize that not every keyboard has that. So a lot of keyboards do. My current keyboard, the Bluetooth keyboard that I have, does. But when I'm looking at my MacBook, the MacBook does not have F6 on it inherently. What you can do is you can press the FN key, which brings up the F keys right above my numerical numbers, and then I can use the F keys that way. But sometimes you don't even have that option, and you have to try to work a way around it. So if you have the F keys, that's amazing. If you don't have them, this is how you do it. You just use the left and right arrow keys, and then you press enter once you've highlighted the column that you want, and then it'll organize that column for you. So if we want to kill a process in htop, you would select the process using the arrow keys and then press F9 in this particular case. And the signal to send this, the signal to send in this particular case would be sigterm, which is the default, which is going to terminate. It's the signal to terminate. And it sends the process using it kills the process, using the F9 key. So it allows you to interactively terminate the process. Now I need to find out how to do this if you don't have the F keys on your keyboard. So let me go get that information for you. If you don't have the F9 key to terminate the process, you can kill it using the K key. So you use the arrow keys to move up and down the list to highlight the process that you want to kill, and then you press the K key, the lowercase version of the K key, to open the action menu, which is an alternative to the shortcut to, or this is an alternative shortcut to F9, and then you select the actual option or the process that you want to kill. And after you've pressed that, you'll see a list of signals that you can end the process. The default signal to terminate a process is sigterm in this particular case, which is signal number 15 for terminate. And then you press enter to send sigterm, which will attempt to gracefully terminate the process. If you can't do that, then you would force kill, which would work with the sig kill, which is signal number 9 to forcefully kill the process. So sig terminate is signal number 15, and it's going to attempt to gracefully kill the process. But if it's not killing, and if it's not working, or if it's not dying, so to speak, then you can forcefully kill the process by using the sig kill, which is signal number 9, and then boom, you are done. We have the F3 option, which is the option to search for a process. And this essentially allows you to enter the name or part of the name of a process that you want to search for. And that way you'll be able to find it. And then if you need to kill it or, force kill it or get other information about it, you can go ahead and do it that way. So now we need to find out what the substitute, the alternative for F3 is. If you don't have the F3 key, then you can use the / as an alternative. So you press the / key, it's going to open the search prompt at the bottom of the interface, and then you would enter the process name or part of the process name that you want to search for, press enter, and then you can use the N key to move to the next match if there are multiple instances of the search term. And that way you can search for processes by name if you don't have the F3 key. So there we go. Now we have the alternative to the F3 key. Next would be quitting htop, which in this particular case would be done with the F10 key. But then I'm going to find, of course, the option for you in case you don't have the F10 key. And this one is exactly the way that top worked as well. So you just press Q. And you press Q, and while it's open, this will immediately exit the htop application. So if you don't have F10, you just press Q, and then you are good to go. So in summary, both top and htop are very useful tools for monitoring system performance. Each of them have their own unique strengths. The provided strength, or the strength for top, is that it provides a basic yet powerful real-time view of the processes and resource usage. You have commands like P to sort by CPU, commands like M to sort by memory. For navigation, you can quit it using Q. htop is a user-friendly version of top, and it has enhanced features, for example, interactive process management and intuitive search navigation. And you can do those with either the F keys, as we saw, or by using the arrow keys or the various keyboard shortcuts that you have. You can use F9 to kill a process and F3 to search for processes, or you can use the various options that we actually had to either kill or forcefully kill something. And then F3 would be the / to be able to search for something, and then Q would be to quit it, so on and so forth. So it still essentially offers the same usage that top does, except it's more user-friendly because it does provide color coding in the responses and the output that you get, and then you can interact with the results a little bit better, and you have more options to interact with the results. So that is it for top and htop, and now we can move on to free. Free is a simple and another powerful command line utility that displays information about the system's memory usage, including both physical memory and swap space. It's vital for monitoring system performance and diagnosing memory-related issues. So the command itself would be free-h, and the -h option stands for human readable. So it formats the output in a way that it's easier to read using units like kilobytes, megabytes, or gigabytes. So this is an example output, for example. An example output, for example. Welcome to the Department of Redundancy department. So in this case, we have ran free h, and then we see that we have the memory usage, or the total memory that's available in our RAM, as well as the swap space. and it says that there's been 3 gigabytes that is currently being used by the RAM, and then there's 8 gigabytes that's free. There's 239 megabytes that's shared. There's the buff and cache that's at 4 gigabytes, and then your total actual available after all of these things are considered are 11 gigabytes. And then there's nothing that's being used inside of the swap, so that one is all good. The breakdown that we just see, just to kind of give you another break, we've actually kind of reviewed this already, but we're going to review it one more time because we are now in the troubleshooting section of the training series, but this is a repeated training because we did go over this earlier in our training series. So you've probably noticed that there are repetitions of various concepts that we've gone through, and we've looked at them at least twice. And this is mainly because of the fact that they are relevant for a multiple amount of things. So it's not just for one use. So free can be used for troubleshooting, and it can also be used for swap monitoring and memory monitoring in the context of partitioning and file systems. So you can be using the same tool to serve multiple purposes, as we've established. So the total amount of memory or swap space, the used amount, the free amount, the shared amount of memory that's being used by the temporary file system, the buffering and the cache, so the memory that's been used by the buffer or the cache, and the final available memory after all of those things are considered without the swap space. If you wanted to check the memory as an example, and this is just another usage of it, but it's essentially the same command that you're running, just different output results that we have in this case. And so the total would be 8 gigabytes, 2 gigabytes that are used, free are 500 megabytes are shared. There's 1 gigabyte dedicated to the buffer and the cache, and then the total available after all of these things are considered would be 6 gigabytes. And so this is just checking the memory usage as an example. If you wanted to monitor what's going on in real time, this is a very useful command that we didn't cover before. So what you're going to do is you're going to use the watch command, and then the N1 represents every second. So if you did N5, it would be every 5 seconds, and so on and so forth. So you're going to use the watch command and then run free H every single second, essentially. So this is a separate command from free H. This is not something that is included under the free H tool. So the watch command is by itself, and you can apply it to a variety of different command line tools. So we have watch -N1, which would say, I want you to watch this output every 1 second, which would essentially run free H every second, providing a real-time version of the output. So it's kind of like running top, except when top updates itself, now we've kind of cheated the system and we're running free H every second so that we can watch the output of this command every second, providing a real-time version of free H for ourselves. If you wanted to look at the memory information, you can concatenate, use a cat command against the process meminfo path. And this is not part of free, but it is detailed information about memory usage directly from the file system itself, so from the proc file system. So this technically should not fall under free, but it was included in the course content, and so this is how we're going to look at it. So you can run the cat command and concatenate the content of this particular file, which will display detailed information about memory usage that's directly from the actual process file system, which will act similar to the results that you would get from free. Free-M displays memory in megabytes. -K would display memory in kilobytes, and -G would display memory in gigabytes. In my opinion, you should just do free-H because it'll kind of determine by itself what the best measurement would be, and then it would provide you that measurement in the associated metric. So if it's less than a gigabyte, it would give it to you in megabytes. If it's less than a megabyte, it will give it to you in kilobytes, and so on and so forth. You don't need to necessarily run either one of these things, but if you wanted to, you could. So now you know K for kilobytes, M for megabytes, and G for gigabytes. I was going to say gigabytes, G for gigabytes, if you want to display the output specifically in those measurements. We have free-B, which is the option that displays memory in bytes. So it doesn't even go in kilobytes. It'll go in the number of bytes. So that's the smallest form of measurement that we can feed into free. Free-L would include statistics about low and high memory usage. So low and high memory statistics. And then as a summary, we have all of these commands just kind of output for you. It's basically a command that's used. It's a very straightforward and essential tool for monitoring memory and swap usage on a system. If you use the -H option, it provides human readable output, which essentially gives you the measurements in what it thinks are the best measurement parameters in the measurement. Man, I'm drawing a blank again today. It's weird. The metrics, I guess I should say. It will give you the human readable format in what it determines to be the best way to measure something. So kilobyte, gigabyte, megabyte, so on and so forth. And then it'll also give you the free, the used, the shared, the buffer cache, total memory, and available memory after all things are considered. You would run free-H for that. If you wanted to do real-time monitoring, you would do watch N1, so that it gives you a 1 second repetition of this command. So it'll run free-H every single second, and you'll be able to see kind of a live update for that. And then you can run the concatenate or the cat command on the particular mem.info file so that you can get detailed memory information, which is not necessarily a part of the free command, but it kind of falls into the overall conversation that we've had where we're run with top and htop, and of course now free. vmstat is another tool, so it stands for virtual memory statistics, and it's another tool that helps you look at these system statistics like memory usage and CPU performance and input-output operations as well. So it helps the administrator, which is you, monitor and troubleshoot system performance effectively. So you would essentially run all of these commands to get a variety of different information, or to try to see if there's something that maybe was not caught by htop, for example, and you were able to find it with vmstat. So the basic command would be vmstat 1 and 5. So the first one is the data every second being populated onto the screen for 5 iterations. So the very first one would be a live count every second, and then it's going to iterate 5 times. So you will get 5 entries printed onto the screen, and then you just get the snapshot of the system activity over the specified interval. So this is what it would potentially look like, right? So you have vmstat 1.5, and then this is structured in several columns, so on and so forth. So we have the processes itself, you have the memory, the swap, the input output, and the system itself, and then the CPU that's being used, and then you have all of this data that's associated to every single one of those things. But you kind of do see that there is like an overall column that's associated with this. So under memory, we have the swap memory, we have the free, we have the buffer, and we have the cache that's being used. Under the swap space right here, you have swap in or swap out. That's nothing being used in there. You have the input output, so basic input, basic output. You have 2 that's being input. You have 15 output processes that are working. You have the system itself incrementally in the IN and the CS. I think we have it on the next slide that it actually breaks down. And then you have the CPU usage as well that gives you the data that is being used by the CPU. So these are the key fields as we have them here. So we have the procs column that we saw at the very beginning right here. So we have the procs column. The R represents the number of processes that are waiting for the runtime. So these are runnable processes. The B represents the number of processes in uninterruptible sleep. So they've been blocked, right? So that's what procs is, and that's what R and B stand for under procs. Memory would be swap D. So the amount of virtual memory that's been used, which is the swap space. You have the free memory, the free amount of idle memory. You have the buffer memory, the amount of memory that's being used as buffers. And then you have the cache, which is the amount of memory that's being used as the cache. Then you have the swap column, which has the SI and SO, so the memory that's swapped in from the disk in kilobytes. You have the memory that is swapped out to the disk in kilobytes, so swapped in from the memory. So you have the random access memory that can't handle anything more than 8 gigabytes, for example. So when it goes into 8.1, that 0.1 is going to be swapped in from the disk. And then if there's anything that's being swapped out of the memory to the disk so that it's being used by the disk, that would be essentially the reverse of what I just mentioned. Then you have IO, which is for the input output. So you have BI for the blocks received from the block device, which is in, so it's coming in blocks per second. So this is the input that's coming in blocks. And then you have the blocks that are being sent to a block device, which is the going in blocks per second. And then you have the system itself. So you have the in and the CS. So the number of interrupts per second, including the clock itself. And then you have the number of context switches per second, which means you're switching from the text editor to the internet browser, and you're switching from the internet browser to a video player, and so on and so forth. So what you're making switches between different applications or different processes. That's what's happening per second. And of course, the number of interrupts that are going on per second. And then finally, we have the CPU portion, which gives us the US, SY, ID, WA, and ST. So the US would be the time spent running non-kernel code. So this is the user time running non-kernel code. So this is the stuff that's being done by the user itself. The SI would be the time running kernel code. So this is stuff that's being run by the system, by the kernel in the background. You have idle time, the time that's been spent on idle, time spent waiting for input or output, which is, I guess, a little bit different than idle, because idle would be there's absolutely nothing going on. Wait time for input output would be the computer is up, it's not asleep, it's not in idle or hibernation or anything, but it's still waiting for something to happen. And then ST would be time stolen from a virtual machine. So just to clarify this for you, because it is something that was a little bit above my head as well. So when you see time stolen from vmstat, it refers to the CPU steal time. CPU steal time is the percentage of time that a virtual CPU within a virtual machine is waiting for resources, because the hypervisor is allocating those resources to another virtual machine on the same physical host. So it's the time when your VM's vCPU is involuntarily idle because it can't get the necessary CPU from the physical machine. So you have a physical host. That physical host has two VMs on it, two virtual machines on it, and each one of those virtual machines is requiring a certain amount of CPU, a certain amount of processing power. And so if the CPU is not, if there isn't enough CPU, then you can't allocate to both of the machines, and one of the machines is taking a lot of the processing power, then the second machine is getting its processing time stolen. So the steal time means that the processing power, the processing time, has been stolen from one virtual machine because another virtual machine is overclocking and it's taking too much. So it happens because the hypervisor is managing multiple VMs and has to distribute the physical CPU resources among them. If there are more VMs or higher CPU demand than the physical host can handle, some VMs may experience CPU steal time. So an example would be to just run vmstat1, and so we already established that the first number that we feed it would just be the amount of seconds that it waits before it refreshes the data. So it's just going to continually update the system performance data every second until it's interrupted, using the Control-C to stop. If we were to do 1 and then give the second number as 10, then it would repeat this iteration 10 times, and then it would just automatically stop by itself. If you ran vmstat, it's just a single snapshot, so it's not going to repeat itself. It's just going to give you one snapshot of the system performance at the moment that you ran that command, and then this is what we see right here. So it's going to update itself every 5 seconds for 10 increments. So it's going to, for 10 increments. So it's going to update itself every 5 seconds 10 times, displaying the performance data for 10 iterations. That's what I was looking for, not increments. It's going to do this 10 iterations every 5 seconds. And this is our summary for vmstat. So another essential tool, monitoring and analyzing system performance, provides detailed statistics on CPU, memory, and I/O operations, input-output operations. When you understand and utilize it, administrators can effectively identify and troubleshoot system performance issues. So this would be used in conjunction with top, htop, vmstat, free, so on and so forth. These would be on your suite of tools. It would be in your arsenal of tools when you're trying to troubleshoot system resources. For example, the amount of CPU that's being used, the amount of RAM that's being used, the amount of processes that are running, and how much each one of those processes is taking. So as you saw, you get different results from each one of these tools. So it gives you a little bit of it gives you more context to what's going on within any given machine, so that you can figure out overall what's going on. vmstat, as the name implies, is going to the virtual machine statistics. Free would give you all the free space that's available. Top would give you the processes that are running and the amount of memory or RAM that they're using. So all of these things serve a different purpose, and they can be used in conjunction with each other to give you a full picture, a great idea of what's going on inside of your computer's environment or your network's environment. All right, now we need to talk about virtualization and cloud computing. And this is not going to be on the Linux Plus examination, or at least the version that we mentioned at the top of this training series, but they do upgrade and update their certification exams relatively frequently. So for whenever this does get included as a part of the examination process, I want you to be aware of these concepts. And even if they're not covered in the exam, it makes you a much better administrator when you understand what virtualization is and what cloud computing is. And this is in no way limited to Linux, but I think it is a very important topic to talk about, especially when we are talking about deploying Linux. And this was something that we actually did kind of go over as we went through the installation process in chapter 3, and I was showing you how to boot something from a USB drive and how to install on a USB drive and how to reinstall a dual boot, for example, on your machine so that you can boot multiple versions of an operating system or different operating systems on the same machine. So that all falls under virtualization. And cloud computing is a little bit different, but it's kind of in the same ballpark, obviously. So just as an introduction to virtualization, the first thing that we need to understand is essentially if you think of your computer as a machine, right? Or the computer that I'm recording this on, or even your cell phone. If you just consider all of these things as a machine, and then we talk about the physical version of the machine or a virtual version of the machine. So you could have a Windows machine be on a physical computer, or you could have a Windows machine that would be a virtual computer, a virtual machine. And the way that we create the virtualization or the virtual version of it, we would do it through virtualization. And virtualization is just the technology that allows you to do it, that to have multiple virtual machines running on a single physical machine. And that physical machine could be something as simple as somebody's home computer, or it could be a mega-sized server that was created at Amazon AWS or on Google Cloud or Microsoft Azure Cloud or any of those things, right? So it's overall the same concept. It's just different sizes of physical machines that end up hosting these the variety of virtual machines. So this particular approach, this concept of virtualization, improves the use of resources. It gives you isolated environments for a variety of different purposes. So to create different applications or operating systems or test environments or anything along those lines, it's all very, very powerful to use virtualization for those concepts. So this is essentially what virtualization is. And then there are a few key concepts that we need to make sure that you really wrap your head around. So as I already mentioned, virtual machines are basically simulations of physical computers, right? So you can have a software-based version of a physical computer that could live on a USB drive, that could be booted from a USB drive. It could be booted from a cloud service provider. It could be booted from your actual computer that you're watching this video on. And that it's basically what it is. It's just a simulation of an actual computer, right? The operating system of Windows or Mac OS or Linux or so on and so forth. Each virtual machine runs its own OS and the applications inside of that OS, and they're all independent from each other that would be on the same physical host. So you can have one physical host that has 100 VMs running on it or 1,000 VMs running on it in the case of a mega server that exists at some enterprise locations that they have it in their own building, or they buy it from a cloud service provider, right? There is isolation, meaning that the failure or compromise of one VM will not affect the others. Or if you wanted to test something in an isolated environment, you could boot up a virtual machine, test it on that machine, make sure everything's all good. If it crashes, who cares, because it's that one singular virtual machine, and you literally take it down as quickly and easily as you put it up, and you can just keep testing until it's actually ready, and then you would deploy to the rest of your environment in your enterprise. Or you just isolate each one of these things against each other for security purposes, so in case something happens, one machine crashing doesn't affect the rest of your environment and your network. So this is the overall understanding and the concept of virtual machines. Now, there's something that helps you deploy and create and manage virtual machines, and that is the hypervisor. And the hypervisor is basically a software or firmware, so to speak, depending on the type of hypervisor that you're using, but it essentially serves the same purpose, right? It helps you to create and manage and deploy and take down virtual machines. That's basically what it does. And then with that hypervisor, you allocate the amount of resources that will be designated to any one of these virtual machines, and keep them separate from each other, keep them isolated from each other. That's what the hypervisor does. So it helps you boot them up, deploy them, and then allocate how much resources each one should take on that physical machine that they're running on, and then keep them all separate from each other. The first type of hypervisor is known as the bare metal hypervisor, and I'll give you a visual so that you kind of understand the difference between the two. So we have the type 1, which is known as the bare metal, that runs directly on the actual physical hardware. So the CPU, the motherboard, the RAM, the power source, everything else, right? So anything that is required to build a computer physically, the physical requirements of that computer, the hypervisor sits on top of that. And then from the hypervisor, you boot a bunch of different virtual machines, and it doesn't require a host operating system. So I'll explain what that means when we actually get to the second type. So it doesn't require a host operating system. It just sits right on top of the physical hardware, and from there you can boot all of the operating systems or applications or everything else that you would run inside of your environment, and you would do that through the use of this particular hypervisor. This is more focused on performance. So this is the higher performing version of a hypervisor, because it is sitting directly on top of the physical hardware, and it's very, very common in enterprise environments or environments that have hundreds, if not thousands, of employees that they need to provide machines to, they need to provide computers to. The examples here are, these are the actual hypervisors that are considered bare metal. So the VMware ESXi, or ESXi, I guess, I don't know if that's how you pronounce it, ESXi, whatever. So the VMware version, it's very widely used in enterprise environments. It supports a lot of different features for managing virtual machines. We have the Microsoft Hyper-V, which is also another powerful hypervisor that's included with the Windows server, and it provides comprehensive virtualization capabilities. And then there's Xen, which is the open source version of the bare metal hypervisor, that's known for scalability, which means it essentially you can use it in an enterprise environment if they have limited budgets, and it's still very secure, and it's a notable mention. So it's a good enough a hypervisor that even though it's open source, it's still very useful in a large production environment. Then we have the type 2 hypervisor, which is known as the hosted hypervisor, and this runs on top of your actual operating system on your computer. So imagine if you're watching this on a computer, or let's say the Mac computer that I'm running this on. So the computer that I'm on would act as the host, and then we would install one of the hypervisor softwares on here. And then with the use of that hypervisor, I would deploy multiple virtual machines, and it would all use the same resources that is inside of my MacBook or inside of my Mac operating system, whatever it is, right? So if my MacBook has 8 gigabytes of RAM, all of the various virtual machines would rely on that 8 gigabytes of RAM that's on my actual computer, right? And so this is what it means to have a hosted hypervisor. The computer serves as the host, and then you're using the resources of that computer, and then the computer has its own operating system. So it could be a Mac, it could be a Windows, anything else. It has its own operating system. That computer that's already running as an OS serves as the host, and then on top of that you would have the hypervisor that helps you deploy the various virtual machines or applications, so on and so forth. And this is mostly used for desktop virtualization or smaller environments. So this is not something that you would do with 1,000 employees, right? It's typically a much smaller scale version of running a hypervisor or a virtual type of an environment, and it just depends on the resources of the main computer, that host computer. The VirtualBox would be one of the most common ones. You've probably heard of this because it's an open source hypervisor that's used a lot to deploy guest operating systems. So if you have your computer being the host, everything else would be the guest OS and the guest VM. And it's very easy to deploy it using VirtualBox. You just download it and then you start deploying, as long as you have the ISO image, as we kind of went over inside of the installation process of Chapter 3. You can essentially run as many virtual machines as your computer would allow based on its resources, based on its hardware and the processing power. VM Workstation is the commercial hypervisor version of this, and it basically does the same thing. So it's for a hosted environment, and it runs and manages multiple VMs on a desktop computer. Of course, if it is inside of a commercial environment, you would need a much faster host computer than something that runs on 8 or 16 gigabytes of RAM with a basic CPU. So it does still need to be a strong enough computer. It's going to be, if it's going to be used inside of a virtual environment or inside of a commercial environment, to virtualize over a dozen VMs, for example. The last one would be the Parallels desktop, which is designed for Mac OS specifically, which allows you to run Windows and other operating systems on top of a Mac OS computer. And of course, Mac OS would need its own dedicated hypervisor. So Parallels Desktop would serve as the hypervisor that can work on top of a Mac OS computer. So there are a lot of advantages to doing this. I'm going to go over 3 main categories, or maybe 4 main categories, but depending on who you ask, there's an abundance of advantages to virtualization. The first one would be the efficiency of the usage of the resource and how quickly you can scale up or scale down. So because you can use the same physical resources, it's efficient, right? You're not using a lot of money to buy 25 computers. You can just launch 25 virtual machines from the same hardware, and then from there just connect them to monitors, keyboards, and mouses. And each one of those dummy computers, we call them dummy computers, or you can technically, I think they're called terminals. You can use 25 terminals that don't have any hardware. They're just connected to the main physical processor, which is the massive or the powerful, let's say it's not massive, but it's like a very powerful central computer with all of the physical hardware, and then that connects to the 25 different terminals that 25 different employees can use. And then when you hire somebody or get rid of somebody, you don't have to worry about selling the computer, or if you hired a new person, you don't have to buy a new computer. You can just launch from that same physical resource and just have a keyboard and a mouse and a monitor, you know what I mean? So it's just much more cost effective. The cost of hardware is way less when you do virtualization, instead of having to buy 25 individual computers. So that's the one piece. And then the other piece is the scaling up and scaling down portion, that you fired half of your people, you don't need to worry about getting rid of half of your computers. You can just delete the half of the virtual machines that are currently deployed on your hypervisor, and it's as easy as selecting them and then clicking delete. And it's not complicated to scale up or down using virtualization. The next one would be isolating and the connection of isolation to security. So these two pieces actually go hand in hand. So because of the fact that each virtual machine operates independently, so it's actually operating as its own computer. As long as the usernames and passwords are strong, if one of them gets hacked into or fails, right? So if a computer fails, it doesn't affect the rest of the network. You can just reboot one and launch another one, and you should be all good. If that person gets hacked, as long as their password is strong, or as long as the passwords of the rest of the people on your network are strong, then whatever ransomware or virus or anything else that's installed on that particular VM will not affect the rest of the computers, because it is literally isolated as its own computer. And it's as if just that one, if it's one physical computer, for example, if that one physical computer gets hacked, then the rest of the physical computers in the network won't be affected. And it's literally the same thing, because each one of the virtual VMs, each one of these VMs is essentially a computer separate by itself. So it's isolated in its own environment. And if it gets hacked, if it crashes, if anything happens, then it won't affect the rest of the computers that are on your network. So isolation and security actually go hand in hand. When you can isolate a compromised machine from the rest of your network, that means you're protecting the rest of your network. Then there's the flexibility and agility of testing and deploying and developing. So because you can quickly deploy, meaning if somebody new comes in, literally you just go through the same installation process on your hypervisor using the same ISO and just deploy a new virtual machine. And then you can connect that virtual machine to one of the terminals that already exists and just give that person their own username and password. And, when the other employee that was using that original terminal, if they're not working that day, or if they're working on separate schedules or something like that, they could essentially be running their own VMs from that same exact terminal, as long as they have their own login information, their own dedicated login credentials. And then testing and developing is, again, another one of these easy things, because it's an isolated environment. So if you wanted to test a new product launch or a new software launch, and you wanted to make sure that it doesn't affect the rest of your network, then you would do it with a virtual machine, test it, make sure everything's all good, and do any extra configurations or development that you need to. And then from there, once everything's all good and all your I's are crossed all your T's are crossed and your I's are dotted, once all of that's done, then you can deploy it to the rest of your environment and make sure all the other computers have it. So it's very flexible, it's very agile. You can scale up or scale down as needed very quickly without having to buy new machines or sell the current machines. And if you add 10 new employees for your night shift, then they can all use the same exact terminals, just get their own login credentials, and that's it. It's very, very simple and easy to do. And finally, there's the disaster recovery portion of it that so let's go back to the concept of having 25 physical machines, right? So if you wanted to take a snapshot, a backup of 25 physical machines, then instead of having to plug each machine into an external hard drive and then run whatever software you would use to back up that computer's contents on the external hard drive, you would just go to your hypervisor, you would select all of the machines, and then run the backup within the hypervisor, and then go to lunch and come back, and all of the contents of all of those 25 virtual machines have been backed up on your external hard drive. And if you can think about it, so if we go back to the file system hierarchy that we reviewed at the very beginning of this training series, and you consider that, every computer technically is just a massive file system, and it has the root folder, the root directory, and inside of the root directory, there's a bunch of primary directories, and then those primary directories are extended into a bunch of other directories, and then those directories contain a bunch of files and folders and so on and so forth. So when you think about it as a large file, basically, right? So you have one root file, and inside of that file, there's a bunch of other files and folders. When you think about it that way, it's basically as simple as copy pasting, right? So that's what it's like when you have a virtualized environment. You click on one little line item inside of the hypervisor, and that represents a computer and all of the contents of that hypervisor or all of that VM. would be backed up using that hypervisor, and it's so simple to do. So it's much simpler process than having to back up 25 physical machines. So this is probably one of the biggest advantages as far as convenience is concerned. It's one of the biggest advantages of using virtual machines. And if there's any disaster, or you lose your power, or the building burns down or something like that, it's like all of these things are stored inside of this one virtualized environment that can easily be accessed, especially if you've developed redundancies, which is very important in security and disaster recovery, and you have multiple locations that are connected to that same hypervisor. And then if one location goes through an earthquake, that means they're all good, that you can still launch all of those computers, all of those virtual machines, because you have these redundancies that are essentially connected to the same hypervisor, the same virtual environment. So very powerful concept. And as a summary, really what we need to understand is that there are two types of hypervisors. So if you know what a virtualization is, and if you understand the concept of a virtual machine, you need to understand that there are two types of hypervisors. We have the type 1 and then the type 2. Type 1 sits on top of the physical infrastructure. Type 2 sits on top of a already running computer, which would be the host computer, and then from there you would deploy your virtual machines. But I do want to show you this visual because I really believe that visuals actually help kind of embed concepts into your brain and really drive the point home. So let me just show you this real quick. So this is a very simple visual representation of the types of hypervisors. So we have the type 1 hypervisor on the left side here, and this is the hardware. So the CPU, the motherboard, the RAM, and the graphics card, and the power source, and everything else that represents the hardware that is required for a computer to run. And then on top of the hardware is the hypervisor. So there is no operating system. It's just a hypervisor. That is the type 1, the bare metal hypervisor. And then from this hypervisor, you launch all of the various web applications or operating systems, terminal computers, so on and so forth. So it's kind of simple. And you can see how this is more efficient and more performance driven because there is no operating system on top of the hardware. It's just a hypervisor that is deploying these various operating systems. And then the type 2 would be my laptop, for example, or your computer. That would be the type 2, where it has the hardware. And then on top of the hardware is a Windows operating system that's being used as a main computer, or a Mac operating system operating as a main computer. And then you have downloaded the hypervisor as a software, and that hypervisor helps you launch these various operating systems or these various virtual machines. And that's basically it. It doesn't go any deeper than this, right? So the details from here on would be, okay, what hypervisor are you using and how do you use it? Or are you going to use a cloud service provider to be acting as your hypervisor technically, and then you're borrowing or you're renting their infrastructure from their massive server rooms and their data centers and so on and so forth, and then you're just using their interface to launch your virtual machines, and then you're going to give your employees their login and they'll access it from their computer. Or is that how you're going to do it? Or you know what I mean? That's where the details kind of come in. But for the overall concept, that's basically it, right? So if you are gonna rent services from a cloud service provider, you're technically going to be in a hosted environment, which would be this place, and then you're going to log into your web browser, and that would be done from your operating system, from your current computer. You would log into a web browser, and then you would go into Google Cloud, and then you would deploy 100 virtual machines using the hypervisor that is from Google Cloud. And then from there, for each one of those virtual machines, you would get an IP address or a login link, basically. And then for that login link, there's going to be a username and password that would be given to a person. And then that person from their computer would get access to that particular virtual machine or web application. And that's basically it. That's really as deep as you need to kind of go into to be able to understand how cloud environments work and how virtual machines work. Once you get that, then we can kind of go into the nitty gritty and be like, okay, this cloud service provider does this and this one does this and so on. But it's all essentially the same concept, just in a little bit more nuanced of an approach. So that's it. That's the difference between a type 1 and a type 2 hypervisor. If we wanted to look at different versions of type 1 hypervisors, for example, the KVM, the kernel-based virtual machine, would act as a type 1 hypervisor and is integrated directly into the Linux kernel. It sits right on top of the physical hardware, and it transforms the Linux operating system into a very powerful and efficient virtualization host capable of running multiple VMs with various guest operating systems. And this is typically done in a server type of an environment. So we can integrate the KVM with the Linux kernel. As you already know what the kernel is, it connects the user to the actual physical infrastructure and makes it highly efficient and able to leverage the existing Linux infrastructure. It allows the KVM to take advantage of the features of Linux, like the memory management, process scheduling, input-output handling, robust performance and scalability. All of that stuff falls under using something like the KVM or just the KVM itself. It also helps you allocate the resources very easily and efficiently, so to speak. It uses the hardware-assisted virtualization, which is what a Type 1 hypervisor is, and it's supported by the processors with Intel virtualization or AMD V technology, and these are essentially the hardware. AMD, for example, AMD V, you should recognize AMD just by the name because they create really awesome graphics cards, and Intel also creates graphics cards and computer chips and things like that. So the KVM uses hardware that is supported by processors from Intel or AMD, and we're talking about physical processors, computer processors. So this hardware support allows the KVM to efficiently allocate resources like CPU, memory, and input-output usage to virtual machines, ensuring that the performance and overhead is all matched up as it's supposed to be, and it's all balanced out. But basically, kernel-based virtual machine, KVM, is a Type 1 hypervisor that sits on top of the physical computer, and then from there you would launch a variety of different virtual machines. It has a lot of support for various operating systems, meaning that you can actually launch Windows and Linux and BSD and these various types of operating systems from the KVM. So it is compatible with a variety of operating systems, and it runs its own OS. So each virtual machine would run its own OS basically, and it would be configured with the hardware specifications, like for example, how much CPU will it use, how much RAM is it going to get, how much storage is it going to get, so on and so forth. So again, the same thing that is done with a Type 1 hypervisor. It's just this specific one is of note for what we're talking about because it works with Linux. It is a Linux virtual machine manager, Linux hypervisor, but it is compatible with Windows and Linux as well as any other operating system that you would want to install for your virtual machines. Virsh is the command line tool, the command line interface that interacts with KVM. So this is essentially the interface that you would use to manage the KVM-based VMs. KVM-based VMs. That's like a kind of a tongue twister. It's a part of the libvirt virtualization toolkit, which provides the API to interact with hypervisors, including KVM, as well as a variety of different hypervisors. So Virsh is the command line interface to interact with KVM to be able to deploy your virtual machines. If you want to start a virtual machine via the command line using Virsh, this is basically it. So you would run virsh start and then the name of the VM or whatever the VM name that you've designated previously, and it would just start that virtual machine up, right? And replace it as you can this is like very intuitive. It's a very easy to understand command line. So you run the command start and then you just give it the name of the VM so that it actually starts the VM. For example, this would be something that the name of the computer would be my virtual machine, and you just say virsh start my virtual machine. And then you can list the running virtual machines using list. So virsh list. Very, very simple to understand, right? So we'll list all the currently running virtual machines, displaying the IDs, the names, and the states that they are currently in. And this is what an example output of that would look like. So in this particular case, there's two virtual machines. There is my virtual machine, another VM, and they're both running. Very, very simple to understand, easy to understand. If you want to shut something down, then you would just use the shut down. So the opposite of start, you shut it down. It reminds me of Kevin Hart. Hey, shut it down. So you would use virsh shutdown and then give it the VM name, and then it would just shut down gracefully. I love this portion. It gracefully shuts down that virtual machine, making sure that everything is all good. And this would be the example of it, using the my virtual machine name. So virsh shutdown my virtual machine. These are a couple of examples as, again, just to kind of re-ingrain this all in your head. The start command would start up the virtual machine. So in this case, it would be the Ubuntu VM that we're starting. If we wanted to list the virtual machines, you would use virsh list, and it displays all of the currently running virtual machines on your screen. And then shut down the virtual machine would be done to stop the virtual machine from running. So virsh shutdown Ubuntu VM would stop the Ubuntu VM from running. So KVM is the type 1 hypervisor that's integrated into the Linux kernel. It enables virtualization on Linux hosts, and then you can run multiple VMs with a variety of different operating systems, and these are our basic commands. So start a VM, run the VM, or view the running VMs, and then stop the VM. To deploy the virtual machines using KVM is going to be outside of the scope of this particular interaction. I just want you to know that the tool that is used to interact with virsh would be, or excuse me, to interact with KVM, the kernel-based virtual machine. To interact with that, you would be using the virsh command line, and then from there, the commands are as simple as starting something that's been deployed using that particular hypervisor, which is KVM. So the KVM hypervisor would be the one that would give you the name of the virtual machine, for example. And then from there, you would start it, stop it, list what you have available, so on and so forth. VirtualBox is another really commonly used, widely used type 2 hypervisor. So as we reviewed our hypervisors, this one is going to sit on top of a host machine. It's been developed by Oracle. It's very popular because it's compatible with the different operating systems like Linux, Windows, Mac OS, and it's commonly used for testing and deploying environments, testing and development environments, excuse me. It provides the easy to set up and flexible platform because it's literally like running any software, and you can go through the prompts and the wizard for the installation to run multiple operating systems on a single machine. Some of the key features is that it has compatibility with a variety of platforms, so you can actually run it on a variety of host operating systems, which makes it versatile to use on different platforms. You can run a bunch of guest operating systems, meaning Windows, Linux, Mac OS, Solaris, and others. So it's cross-compatible, right? It's cross-platform compatible. You can run it on Windows or Linux to launch Windows or Linux, right? It's compatible across the various platforms. Very easy to use. As I mentioned, it's as simple as doing a couple of clicks to download the install files and then actually installing it. And then once you have it installed, you would use the GUI, the graphic user interface, to just go through the prompts and click the various buttons that you would need to start up a new virtual machine. And there's a lot of documentation that's available for VirtualBox because of the fact that it is one of the most commonly used tools for virtualization, one of the most commonly used hypervisors. And if you really want to be nerdy about it, you can actually use the command line interface for management and automation for scripting and a variety of different tasks if you really want to get good at VirtualBox and just virtualization in general, which I recommend that you do. I would recommend to go look into it. I'm not going to go deep into the VirtualBox command line and its use case, but there's a lot of tutorials available. And maybe in a future video, I will. If there's enough people that want to see it, I may just create a video using VirtualBox because, again, it's just one of the most commonly used tools to virtualize VMs. Some of the key features here that we have the snapshot functionality. So it allows you to take snapshots of the current state of a VM. So meaning that you actually can take backups of the computer very easily. As I mentioned earlier, it's as easy as clicking on one of the virtual machines in the list of VMs that you have and then just taking a snapshot of it, meaning backing up its contents. So it's very, very useful and very easy to create virtual images, so to speak, or a snapshot of a virtual machine to have it as your backup. You can have guest editions, meaning there are tools that you can use to enhance the performance and usability of the guest operating system. So you can improve the graphics, for example, of an operating system. You can have shared folders between all of your operating systems, or you can have a mouse integration, which is, I mean, that one's kind of a gimme, but the shared folders part is very important. To be able to improve the graphics of a operating system is also very, very cool to be able to do just from your VirtualBox, from your virtualization hypervisor. So that's a very cool little feature. And for the nerds, VBox Manage is the command line interface for managing VirtualBox VMs. So this is basically the platform, the command line interface that you would use to virtualize machines via the command line, or to create scripts for virtualizing machines, which is where the scalability comes in a easy, convenient type of a format. When you learn how to script and you can launch, you know, a dozen machines with the use of a script that was done, it makes it even easier to virtualize VMs. So VBox Manage is actually the CLI, the command line interface to launch virtual machines. So VBox Manage start VM name. So this is a little bit more of a mouthful than Virsh, but basically the same concept, right? So you would call on the VBox Manage tool and then start VM and then give it the VM name, which would be the name of the virtual machine. So as an example, Ubuntu VM would be the name of the virtual machine. So you would just say VBox Manage start VM Ubuntu VM. If you wanted to list them, same thing, list VMs. Very, very simple. Instead of Virsh list, this is VBox Manage list VMs. So it's kind of as simple as just using Virsh, and then it would just list all of the VMs that are registered with VirtualBox, and it displays their names, their UUIDs, and so on and so forth. If you wanted to look at the output as an example, this is what it looks like. So you have the Ubuntu VM and the Windows 10 VM. So we have a Linux VM here, as well as a Windows VM at Microsoft. And then these are the UUIDs that are associated with these virtual machines that we've launched using VirtualBox. So VBox Manage control VM name power off. Again, more of a mouthful than using the Virsh command, but this forces the specified VM to power off. So you would replace it with the name of the VM that you want to turn off. VBox Manage control VM name power off. This would be the example. So Ubuntu VM being powered off, and this is what we would do to do that. So a couple of examples just to kind of review these commands that we have. So VBox Manage start VM Debian VM would start the Debian VM. List the VMs would list all of the registered VMs with their names and their UUIDs. The stopping of a VM will be done with control VM, give it the name of the virtual machine, and then give it the power off command. And in summary, we have the VBox Manage commands for managing VMs at the bottom right here, and we have the reference of VirtualBox, which is, I would say, probably one of the most popular, if not the most popular, Type 2 hypervisor that's super easy to download, install, and then it's very flexible because you can run multiple operating systems on a single computer, and it's used for testing, development, and a variety of different tasks because it's so compatible with various hosts and guest operating systems. So again, it has cross-compatibility between the host operating system and the guest operating system, which makes it, again, one of the most popular hypervisors that exists on the market. Dockers and containers are the replacements that we have for file systems and partitions, essentially. So a Docker is a popular containerization tool that enables us to package applications and their dependencies into portable containers, essentially. These containers can run consistently across different environments, ensuring that the application behaves the same regardless of where it's being deployed. So you have a container, a compartment, so to speak, that includes a variety of different applications and all of the dependencies for that application to run. And then you can launch this Docker within a Windows computer, a Linux computer, or so on and so forth. And this will be all done through the virtualized environment, right? So this is something that a virtual machine would have access to. So a container versus the virtual machine itself, if you have to think about the comparison between the two. Containers are the isolated environments that share the host operating system's kernel. They're lightweight, fast to start, and they don't require a full operating system. Okay? Containers include everything needed to run the application, like the code, the runtime, etc. But it's not an actual virtual machine. So the virtual machine is not the container is not the OS, right? So it's an isolated environment that shares the OS, and then it has the application and the dependencies that would need it to run, right? So the virtual machine is the OS. The container is the environment that is using that OS, okay? So you can have and so as the comparison here, we also have the virtual machine that is running on the hypervisor and it includes the OS, right? So the container would run on the virtual machine. Essentially, that's what it is. So a container hosts the application, it hosts the dependencies, so on and so forth, but it needs to run on something, so it would run on the operating system that's provided by the virtual machine, or it would run on the host operating system that would be your computer, for example. Each VM operates independently with its own OS, which increases resource usage, as we've already established. Containers don't run their own OS, so they're more lightweight and they're faster to run. When you have a Docker container, right, so the Docker and the containers within that Docker, essentially, they run on anything that can actually support Docker, which means that they're consistent across development, testing, and production environments. They're isolated, so you can manage the file system or process everything that goes on within that file system on the variety of different operating systems that they will be running on, which means that you can have multiple applications run on the same host without interfering with each other. So this is really just a fancy way of saying that you can compartmentalize a group of applications or a series of applications from each other. You can separate them from each other, run them separate of each other, but they would be running on the same host, right? So they're portable, meaning that they can essentially be transferred via an email or a file share, and then they can be isolated. They can run on themselves or by themselves, without interfering with each other. And then they will run on the same host. They will run on the same host operating system, and they're isolated, right? So they're portable and they can be isolated. The benefits are many. They're efficient, so they're lightweight, as we mentioned. They don't use as many resources from the hardware or the operating system, and they can start at pretty much like you're starting up a piece of software, because that's kind of what they're like. They're scalable, meaning that they can be easily scaled up or down based on the demand. They can be shared with a variety of different operating systems, and they're ideal for microservices or cloud native applications. And that's really where they come into play, is the cloud environment, because cloud providers offer these Dockers and these containers, and the software that is installed within them, the applications that are installed within them, are provided from the cloud service provider, and you can essentially download it and install it into your virtual machine fairly easily, or download it and install it to 100 of your virtual machines fairly easily, because they're very compatible and they can scale up or scale down. To be able to run one, you would use the Docker command. So the Docker is the tool that will run the image of one of the containers, that would run one of the containers. So the IT option allows you to interact with the container via the terminal. So you say Docker run interact with this particular image name, and then you would replace the image name with the image or the name of the various container tools that you would want to run. So as an example, you run Ubuntu, right? So again, you're running Ubuntu as a software, technically, as an application. You're not running it as an operating system. And that's why it's faster to run. And it's using the resources of the host operating system to run it. So this is not running Ubuntu as an operating system. It's running it as a container, which is using your host operating system, your computer, which is why, again, this is very native to cloud environments, because when you're using a cloud environment, you're technically using a type 2 hypervisor, which uses your computer's resources to launch Ubuntu, for example, right? Then you have PS to actually list the containers that you have available. So it'll list all the currently running containers, displaying their IDs, names, statuses, and more. And this is something that is done inside of the cloud command line. And this is what it looks like. So you have the container ID, the image, meaning what is actually running, the command interface for it, which is a bash interface in this case. It was created 2 hours ago. It was up for 2 hours, and there are no ports for it, and the name is Awesome Wing that's been assigned to it. And that's it. That's what it looks like. If you wanted to stop that exact container, you would just do stop container ID and then give it the container ID or the container image name in this particular case. But what we're talking about is this ID. So this would be the container ID that you would need to give it to stop that container from running, to stop that image from running. This is what it looks like. So docker stop, and then you give it the ID, and just like that, it stops that container from running. If you wanted to pull an image, and so pulling an image meaning downloading the specified Docker image from Docker to your actual computer, to the local machine, your host computer that you're running it on, you would use docker pull and then give it the image name. So for example, pull Ubuntu or pull Nginx in this case. It pulls the latest Nginx image from the Docker hub onto your computer. And the Docker hub is the location where everything is listed inside of the cloud service provider that you can either install on your virtual machines or run from the cloud service provider, or just download onto your local computer, right? So Docker hub is the location where all of these, the variety of Ubuntu and Nginx and all of the different images, so to speak, of these containers are all stored, and then from there you would either run them or download them onto your computer, or you can install them on your virtual machines. If you want to remove something, it's as simple as using the remove command. So rm removes that container or the stopped container, right? So you actually have to stop the container first, and then from there you would remove it from your list of containers. It's fairly simple. It's like very intuitive. You need to give it the ID. So as we already mentioned, this is how you stop one. And when you stop one, you can use the same ID to remove it. And then if you wanted to remove an image of something, you would just use RMI. So if you use the RM command by itself, you would need to give it the ID of the container. In this particular case, if you wanted to use the image name, because it's a more convenient thing to use the image name instead of the ID itself, unless you're going to copy paste, for example. But if you just want to remove it by its image name, you just do RMI and then give it the image name, and then it will remove that specified Docker image. And then the same thing example would be here, right? So Ubuntu is much easier than this ID number, for example. So you just do RMI Ubuntu, and then it'll remove the Ubuntu image from your local machine. So in summary, we have the simplification of creating, deploying, and running applications in isolated containers. That's what basically the Docker does, right? So the application is stored inside a container, and then you would use Docker to deploy it, or to create one, or to download it onto your local machine, or to run it, or to stop it, so on and so forth. So Docker is the source that you use to interact with the various containers, and then inside of those containers could be a variety of different things. So it could be applications, it could be what you saw technically as that Ubuntu image that was running, which is technically not its own operating system because it's still running on top of your host operating system, which is your computer. So it's more lightweight to do it this way. So it's faster to run them compared to traditional virtual machines, because when you actually start a virtual machine, it takes up a little bit more time and it takes up more resources because it's a little bit more heavy duty than running just a container that has that specific series of applications that you're looking for it to run. So again, not an operating system. You're not launching the Ubuntu operating system. You're launching the variety of applications that would be stored inside of that one container that resembles what it would be like to launch Ubuntu as the operating system, right? But again, it's not running the actual operating system because your host operating system on your computer acts as the OS, and then the container has the Nginx server in it and the applications and dependencies that would be connected to running an Nginx server, and then you just launch it, and now you have your Nginx server up. And this is your cheat sheet of the commands that we just talked about. So if you wanted to take a screenshot of this or jot it down, you could pause the screen or take a screenshot of the screen. 1, 2, 3, and moving on. Now that we've talked about virtualization and virtual machines and Dockers and containers and all that good stuff, now we can talk about cloud administration, because essentially this is what virtualization is. You are dealing with the cloud with virtual machines and virtual computers. So cloud computing, it's the technology that provides on-demand access to computing over the internet. So on-demand access to virtual machines or Dockers or containers, so on and so forth. It includes servers, storage, databases, networking, software, and a variety of other things. And you can provision them and manage them with the click of a button. And cloud computing allows businesses and or individuals to leverage these powerful resources without the need for physical hardware or extensive IT infrastructure, which is what makes it so freaking popular. So the infrastructure as a service is the first one. And infrastructure as a service is something that's provided, as it says, as a service, and is provided from a cloud service provider. So infrastructure as a service is the virtualized hardware resources, like which is virtual machines, for example, storage, networks, which allows the user to deploy and manage operating systems, applications, and development environments. So this is infrastructure as a service. The example would be AWS EC2. And AWS has a variety of different services under their umbrella of services. EC2 is the compute capacity in the cloud, enabling users to run applications on virtual servers. That's what their version of IaaS, infrastructure as a service, is. The next one is Microsoft Azure Virtual Machines, which is the essentially the equivalent of AWS's EC2. And it provides a range of virtual machine sizes, configurations, which support both Windows and Linux operating systems. And then we have the Google Compute Engine, which is the Google version of this whole thing, which is essentially offering the same thing, scalable, flexible compute resources for running large-scale workloads on Google's infrastructure. And then you have platform as a service. Platform as a service would be the next level up. So if we looked at infrastructure as a service as the base level, because they're providing the infrastructure, platform as a service is the development and deployment environment in the cloud. So it provides you with the tools and services to build, test, deploy, and manage applications without worrying about the underlying infrastructure. So for example, the virtual machines and the physical hardware that's required, you're just using their platform to develop your applications, to deploy and test your applications, so on and so forth. So it's the next level up from buying infrastructure or renting infrastructure. The Elastic Beanstalk would be the AWS version of this, which helps you develop and scale and deploy web applications and services using popular languages. Google App Engine is the Google version of this that helps you deploy applications on Google's infrastructure without with automatic scaling and management. And then we have the Microsoft Azure version, which is the Microsoft Azure App Service that helps you help developers build, deploy, and scale web apps and APIs quickly with the integrated support for various development languages, so on and so forth. So basically, these three companies essentially offer the same exact thing across the board. The platforms have different interfaces to use. Some of them are more user-friendly than the other ones, but for the most part, they offer similar services for everybody. Then you have the software as a service. So if we were to look at infrastructure as the base level, platform would be the next level, software would be the next level as well, which would be the application over the internet on a subscription basis. So you can access these via a web browser without the need for installing or maintaining anything. You just log into any of these companies. So Microsoft Office 365 is like one of the most common ones. It's access to Microsoft Office like Word, Excel, PowerPoint, so on and so forth. And it's very similar to Google Drive, right? So Google Drive would be another one of those things where it's kind of the software as a service. You get access to Google Sheets and you get access to Google Docs and so on and so forth. And you're using the software now, right? The software is the word editor. The software is the spreadsheet creator editor. And that's what that is. And with the connection with these things to OneDrive and Teams. So Teams would be the sharing portion of Office 365, and OneDrive is the storage portion of Office 365, which again is very similar to Google Drive. Google Workspace is the software as a service that kind of combines everything together, right? So you have the productivity, collaboration, because you're now working with your coworkers and everybody that's on your team. And inside of this would be Gmail, Google Drive, Docs, Sheets, and Google Meet, which would be their video chatting, video conferencing. And then Salesforce, which is a really big one. It's a customer relationship management, so which is a CRM tool, and it helps businesses manage their customer relationships, streamline send processes, so on and so forth. And Salesforce, again, is a software, and it's actually available on most cloud service providers as well, and you can buy a license to it and have it installed on everybody's local computer. So that would kind of be another version of the software as a service. So cloud computing, as we've discussed in multiple instances so far under this particular chapter, it helps you scale up or scale down, right? So based on the demands of your company, you can get a bunch of different softwares deployed to all of your users, all of your employees. You can have a bunch of different virtual machines launched using the infrastructure as a service. You can have the platform launch as well for them to be able to develop code and run or test their cloud resources or test their applications that they've developed, so on and so forth. And you can do this up or down, meaning as your company grows or as your company shrinks and downsizes, you can add things with the click of a button, or you can remove things with the click of a button. Very easily scalable in both directions, and it's cost efficient. So this is one of the big things that companies are like, for one of the main reasons why they go into cloud computing, because literally, I mean, for $20, for $30 a month, you can start launching something for whatever environment, for as much power and processing as you would need, instead of buying a $5,000 computer. You know what I mean? Depending on what you're looking for, depending on what you would need, the upfront cost is so much cheaper. And then, you know, when you don't need it anymore, instead of worrying about what to do with that $5,000 computer, you just stop paying for the thing. And let's say you used it for 6 months and you don't need it anymore, and now you stop paying for it and you just take it down. You know what I mean? It's in the grand scheme of things, it's so much more efficient cost-wise to use cloud computing for a company, especially. Maybe not for a person, just depending on who you are as a person and what you do and what you need it for. Maybe you do need it, but for the most part, for companies, it's kind of a no-brainer to go into cloud computing to use their services. Flexible, obviously accessible. So cloud services are accessible from anywhere with an internet connection. You just need your laptop, and then now you can log into your cloud service provider, your CSP, and then from there get access to whatever it is that you were using from your home office, for example. They're reliable, they're available because they have redundant locations. So AWS, Amazon's web services, they have warehouses all over the globe that house these servers that are connected to the AWS service. And if one of those things goes down, it just defaults into the next available one in that region. And now whoever the person is that's using it never has to worry about losing access to what it is that they need to use. And this is very, very important, because the redundancy portion of this, the redundant server warehouses that exist all over the world, literally all over the world, these redundant warehouses are the main reason why these services are so reliable and available all the time. Disaster recovery, as long as you have enabled some kind of a backup, you will never lose your data. And as long as obviously you're paying your bill, that's the other part. So it's like, as long as you're paying your bill and you've done a scheduled backup, you will never lose your data, and you will never lose your service. Your server will always be on. Your web server, your application server will always be on and running. So these were just the three major heavy hitters we were talking about. There are a lot of different cloud service providers that are also very legitimate, and they have a lot of great resources that are available. So these were just the three big ones, the three heavy hitters that we were talking about. And then you have, of course, the automatic update. So you don't need to update your computer. You don't need to update the service. It just gets updated on your behalf, and you don't have to worry about making sure your IT team is on top of it, or that you, if you're the sole proprietor, the administrator, and the CEO and everything, you don't have to worry about updating anything, because it'll be automatically done for you. The security will be updated for you. All of it is a very, very convenient process. There's a lot of different conveniences that are available for using cloud computing, but this is another really big one, because with updates and automatic updates, there is a lot of security that is enforced, and a lot of convenience that is also enforced, because as things get more streamlined, then you will just get those updates as things get hacked into. So as pen testing is done and they upgrade their security infrastructure, you will also inherit those benefits as well. So cloud computing is a very flexible, scalable, cost-efficient, and just awesome way of going into virtualization. And you have the infrastructure as a service, IaaS, platform as a service, PaaS, oh my God, and then SaaS as a service. And I'll show you what the visual of that also looks like. This is kind of the best image that I was able to find. All the other ones they're similar to spreadsheets or something like that, or like a pyramid that doesn't really give you much. So IaaS, the infrastructure as a service, you can see that this is basically what the web server looks like, or the servers that are inside of those massive warehouses. That's what it looks like. And this is what you're renting. And these things can help you deploy virtual machines and virtual computers for people to use. And then those people can then install their own, for example, operating systems on top of them, or they can install their own applications and develop new applications, so on and so forth. So this is the most base level of service that you would get, which on top of this, you can essentially do anything that you want, but you would need IT people. You would need a team of people to be able to do this for you, right? And then you have platform as a service, right? So they give you the servers, obviously, but then they also give you the operating systems. So you could just launch a Windows machine or a Linux machine, instead of only launching a server and then on top of the server having to use your hypervisor to install the operating systems. You would just launch one. You would just launch the operating system, and then from there you can start developing your code, or you can start running your business, whatever it may be, right? So this one requires the most configuration, because you do need to use a hypervisor to be able to install the virtual machines and then install the operating systems and then launch them. This one, you just launch the operating system with a couple of clicks, and now you have access to a Linux computer or a Windows computer, right? And then the last one is assuming that all of these things are already configured for you. You have to do no configuration, and then you just launch the application. So Google Drive, for example, you just launch Google Drive, right? And that's the most convenient version of this trio, because there is very little configuration that's required from your behalf. You just log into the application and you start using the software. And that's basically it, right? So this one requires the most configuration, because somebody needs to use a hypervisor, install the operating system, install the Linux or Windows or whatever it is, launch the virtual machine, all of those things. This is the most configuration. This is the least configuration. And then this is the middle ground right here, that with a couple of clicks, you're now launching a Linux machine, and then you use the Linux machine and use the applications inside of it, or you launch a Windows machine, so on and so forth. So this is the trio that we have over here, which falls under as a service. There's infrastructure, platform, and then software as a service. It's probably also a good idea for us to talk about some of these cloud providers. These are, again, the big three that we got over here. So Amazon, AWS, Microsoft, as well as Google. They offer a comprehensive list of services, and they're comparable. They're very comparable to each other. It's just, I guess, kind of depends on personal taste and personal preferences, where they would differ, or where somebody would choose one over the other. Maybe pricing would also play into that. But for the most part, they all pretty much offer a similar range of services. So AWS is, the most popular. Believe it or not, Amazon is not just a marketplace. Their biggest profit comes from their web services, their AWS web services, because for the most part, they have the same infrastructure that's set up. And then on top of that, they're just selling access to their resources on a variety of different tiers. And it includes computing power, of course, storage options, networking abilities. I host my website, one of my websites, or actually all my websites, but I don't have one specific that's launched for this channel yet. I did buy the Hackaholics Anonymous domain through AWS, so that's a really cool one. And that's basically it. Like it just offers computing power, storage options, and networking capabilities that makes it great for everybody: individual users, enterprises, government entities, so on and so forth. Their key services are the Elastic Compute Cloud, so EC2, Lambda, which is serverless computing, so you don't need an actual computer or a server, and you can just get access to computing power just using their platform. And then Elastic Beanstalk, which is the platform as a service. And then storage would be the Simple Storage Service, which is S3, Elastic Block Store, and then Glacier, which is for long-term storage. Amazon Web Services databases runs across the variety of different services or levels of services as well. So you have the relational database service, you have DynamoDB, which is NoSQL database, and then you have the Redshift for warehousing, data warehousing, which is kind of falling into cold storage. And then you have networking, so Virtual Private Cloud, Route 53 for DNS services, CloudFront for content delivery network, and this is their list of key services. And then we have the management consoles and the management tools. So the interface for managing AWS resources would be the management console, the AWS CLI for the command line interface to interact with their services programmatically as well as script-wise. And then you have the software development kits, the SDKs for integrating AWS services into applications using programming languages. So Python SDKs are a very common thing to understand when you're interacting with the API of any service. You will look for a Python SDK and you will import it into your software, or not your software, you will import it into your project file. And then that SDK will allow you to interact with the API of that service. For example, in this case, AWS. AWS has an SDK. You can import that into your Python project, and then now you can interact with your AWS management environment as long as you have your token and your API key, so on and so forth, to confirm that you actually have access to their services. Now you can interact with those services using a variety of APIs and software development kits. So very, very cool portion of it. And again, also all of these guys have SDKs, just to let you know. So Microsoft Azure is another one. It's the competitor to AWS. Seamless integration with Microsoft products. Azure offers a wide range of cloud services, including compute, analytics, storage, and networking. You have the compute and storage portion, so Azure Virtual Machines, Azure Functions, which is the serverless computing, Azure Kubernetes Service, which is a really big one. A lot of people actually ask for this inside of job descriptions. You have the Azure Blob Storage, Azure Disk Storage, and Azure Files. You have the databases, which is the SQL database, Cosmos DB, which is the NoSQL database, Azure Database for PostgreSQL and MySQL. And then we have Azure Virtual Network, Azure Load Balancer, and Content Delivery Network, which is for their CDN. And then you have their management tools, which would be the Azure Portal, the command line interface, and of course, PowerShell scripting language. And then they also have an SDK that you can interact with. And then we have Google Cloud, which is for capabilities in data analytics and machine learning. They have a robust set of cloud services that leverage the infrastructure of Google, the massive infrastructure that they have, like computing, storage, application development, Google Compute Engine, the Kubernetes engine, and cloud functions are all under their computing section. You have the storage, so cloud storage, persistent disk, file store, Google Drive, for example. And then you have the databases, Cloud SQL, Cloud Spanner, which is the regional database, and of course Firestore, which is the NoSQL document database, and then networking for virtual private cloud, so VPC, cloud load balancing, and cloud CDN. And then this is their management tool, so Cloud Console, the Cloud CLI, and the client libraries for integrating into applications using programming languages. So the client libraries would be similar to the SDK, the CLI. As you can tell, every single one of them has a CLI, and every decent cloud computing provider should have a CLI. And then the console, which is the GUI, the graphic user interface for management of all of your resources and assets via Google Cloud. So that's what we got over here. Obviously scalable, obviously cost efficient. We've talked about all these things, flexibility, security, all of those things. And the advanced services like the AI stuff, machine learning stuff, and the big data analytics enabling you to innovate and stay competitive. This is becoming more and more required to be competitive in the modern business world, to have some kind of an AI assistant or some kind of AI integration with your infrastructure to make things more efficient and respond faster. Machine learning to just be on top of your competition with the research that's being done and to improve your data sets and your infrastructure, because machines learn faster and better and more consistently than human beings do. And then you have the big data analytics stuff, which is it's very, very crazy that how much data actually exists in the world and how important it is to be able to ingest all of that data and make sense of it. And these things are connected to each other. So the big data analytics connected to the machine learning, which is done by an AI, all of those things are interconnected. And I feel like they're almost mandatory at this state of the modern technology world and how technology has been connected to business. I feel like these things are absolutely mandatory. And if you want to be really, really good as a cybersecurity person, as an administrator, a tech person, IT, you need to really get comfortable with the concepts of machine learning and big data and using AI integrations so that you can just stay ahead of the curve when it comes down to your competition inside of the IT world and the cybersecurity and pen testing and system administration world. In summary, we got these major cloud providers, but they are not the only ones. And I would challenge you to Google what the major cloud providers are and see what you can find out there and how they rank as far as their competitiveness to these big three right here. There's a lot of tools available, as we already talked about. There's infrastructure, platform, as well as software that is available as a service, and they have a lot of great management tools, including the consoles, as well as the command line interfaces, as well as the SDKs, the software development kits that integrate well with programming languages to provide further automation capabilities. And these are the big three, as we talked about. All right, so you got your VMs up, you got your containers and all the things that are provided to you by your virtual environment. How do you manage these things? That's what we're going to talk about. So libvirt would be the first command line tool that is available for us. And it's a toolkit that is connected via API, and it's used for interacting with VMs across a bunch of different platforms like KVM, Qemu, Zen, and VMware. It's consistent because it works across all of these different platforms, and it's a very popular choice. We've already mentioned it, actually. Hopefully you remember as we talked about the virtualization portion earlier, we did mention libvirt already. It offers a unified API for managing the VMs across different hypervisors. It simplifies the VM management as a result. and makes it so that the use of a consistent set of commands and tools would basically work everywhere, depending on, doesn't matter where you are and what you're using as your virtualization technology. Virsh would be one of the key features that comes with libvirt, and then virt install with the command line tool for creating and installing a new virtual machine. So these are the two command line tools that come with virt, and it's compatible, again, as we already talked about. So it works with the various virtualization technologies. It's a versatile tool for various virtualization environments, and this is kind of what a command looks like to use libvirt specifically to create a virtual machine. So there are a few elements here that we need to go over. So virt install would be the command line tool to install a new machine. The name is what you're going to give it, and then this is how much memory should be allocated to it. The vCPUs that would be allocated to it, and then the disk, this is going to be the path that's going to go for this particular disk, and then the variation of the OS that you're going to be installing, which is essentially the OS image that you want to use to complete your installation. So this is the breakdown, the full breakdown of this. We have the virt install, which is to create and install a new virtual machine inside of libvirt. Then you have the name that you're going to give it, so what you want the virtual machine to be called. The allocation of 2048 megabytes of RAM to this particular VM, which is basically 2 gigs worth of RAM that you're giving to this virtual machine, the processing power that it has. vCPU, which is the virtual CPU that's going to be assigned to this virtual machine, which is in this case 2 CPUs that are going to be assigned to it. And then this is the path, so the disk image for the VM with a size of 20 gigabytes. And the 20 gigabytes in this particular case is storage. So we're not talking about the processing power of RAM or the processing power of the CPU. We're just talking about storage for this particular machine, and it's going to get 20 gigabytes. And then, of course, the OS variant, which is the operating system for this particular case, which is Ubuntu 20.04. So this is how you create a new virtual machine using virt install inside of libvirt. And this is the full thing if we were to actually provide some fillers in here. So the name would be my Ubuntu VM, same RAM capacity that we're assigning to it, same vCPUs that we're assigning to it, and then this would be the full path that's going to this thing, and then we're going to allocate 20 gigs of storage to it. And then you have the OS variant, which is Ubuntu, and then the CD-ROM, wow, look at that. There's a CD-ROM image as well that's going to be the path for this particular case. It's being pulled from a CD-ROM. So this OS variant is being pulled from the CD-ROM partition, which is the path to that particular CD-ROM partition. And then this is how you destroy one. I love that word. So you destroy a virtual machine using the virsh destroy. So virt install is how you create one, and then to destroy it, you would need to use virsh. And so again, you just give it the virtual machine name that we got here. So my Ubuntu VM would be the name that we give it, and then it destroys it. It forcibly stops the specified VM with the name that you want and actually destroys it. So my Ubuntu VM in this particular case is being destroyed. If you wanted to list your virtual machines, you would do list all, and it lists everything that's being managed by libvirt, showing their IDs, their names, their current state, whether or not they're running, paused, or shut off. And then this would be an example output for that, which is in this particular case, you got 3. So the My Ubuntu VM, the test virtual machine, and the old virtual machine. And because of the fact that this one is shut off and this one is paused, their IDs are not activated. So the only one that actually has this ID that's associated to it is the one that's currently running. And this would be the output that you would get from listing the all virtual machines with virsh. So this is the flow here that we got. So as an example, we want to create a virtual machine in this case, which is the CentOS. CentOS being one of the Red Hat distributions of Linux. There is 4 gigabytes of RAM assigned to this particular one. There is 4 CPUs assigned to it. The disk location, the path to this virtual VM is going to be here. And then there's 40 gigabytes of storage that's assigned to it. And then the OS variant is CentOS, and then it's being pulled from the CD-ROM partition for CentOS installation that has the ISO image on it. And that's it. This is how you install one with the CentOS. If you wanted to destroy that same machine, you would use virsh. So again, virt install installs this one. Virsh is the one that we use to destroy this thing, and it immediately stops it. And then if you want to list everything, you would do the list all command. So libvirt is the toolkit for managing virtual machines across a variety of virtualization platforms. It's consistent, meaning that you can use those same exact commands across a variety of different hypervisors and virtualization environments, and all of those commands would run exactly as they are. And then you would have virsh for the management and virt install for the installation of the various virtual machines that you got. And this is our summary of commands. So 3, 2, 1, moving on. Okay, so now we gotta manage our Dockers, okay? Dockers significantly, or excuse me, the containers of the Docker, my bad. So the Docker is the tool and the containers are the stuff that we manage with the Docker tool. So Docker simplifies the deployment and management of the applications which are stored inside of these containers. And these are the microservices and the architectures around them and the packages of applications along with all of their dependencies inside their isolated containers, right? So you have the Docker, which is the tool, and the container is the container that houses the applications, the dependencies of those applications, and everything else that would be used in something called a microservice. So basically just running the various applications. For example, that Ubuntu example that we saw earlier, that would just run the various applications and the dependencies that would be inherent, that would become ingrained inside of a Ubuntu environment without actually launching an Ubuntu operating system. So you would pull the image, meaning downloading it from the Docker hub, which would be housed on a variety of different cloud service providers or any other container registry really, and then you would pull that from that location into your actual local machine, your computer. You would download that into your local machine. So for example, we're going to pull Nginx in this particular case and pull that image into our local machine. And then you want to run it, right? So you start the new container in detached mode, meaning that it's going to run in the background. And then you would replace that with the name of the Docker image that you want to use. For example, Nginx, what we had in the previous case. So run the Nginx and it'll run the Nginx container in the background, and then it'll return the container ID for you. And once you have that, you can do a variety of different things with that container, like run it and actually use it. And then when you're done with it, if you want to remove it, you would need to provide the container ID. So we got the container ID by running it inside of the background, in the background. And you can also run the list command, as we saw, to be able to give you the list of the containers that you have, as well as their container IDs. And then you can use the rm command to remove that container ID, or the rmi command to remove the named image that you download, the named container that you downloaded. So remove my container in this particular case. This would be the one that removes the container. This is my container. That would be the name, I would assume, but not the container ID itself. So we have the logs of those containers. So the logs of the specified container, which does not mean that it's displaying the contents of those logs. You would need to access that either with Nano or some kind of a text editor or viewer, or let's say IDS or a SIM tool, something like that. But essentially you can view all of the logs that are associated with that individual container, meaning the authentication authorization log, the logs for any errors that may have taken place, or just regular interactions that were done with that particular container. You can retrieve all of those via the logs command. So logs of my container would be retrieved by running docker logs my container. And then you have the PS, which will list all of the current running containers. So this is how you would get the actual container names, their IDs, the statuses, and any other details. And then this is how you would get the ID to be able to remove it, for example, or to be able to get the logs from it, for example. So this would be the example output in this particular case. I know it's a little bit small, but this is where the container ID is listed. You have the image, which is nginx in this case, the command line entry for this, which is the Docker entry point, and it runs much longer than that. You have the fact that it was created 2 hours ago. It's been running for 2 hours. There are no ports associated with it because it's running on a local machine. And then the name is the Serene Bassi that has been associated with this nginx server. So PSA, not the public service announcement, but PSA as the listing of all of the containers, including all the ones that are stopped. So we had the PS that was running something that is running, right? So it's going to show you the stuff that's currently running. PSA will show you everything that is stopped or deleted, or maybe not deleted, but probably the ones that are stopped, either paused or deactivated. And then you would see what those IDs are and what their names are, so on and so forth. And then you can stop one that's currently running. So if you wanted to stop it, docker stop, and then give it the container ID. These are very, very easy commands to remember, but you already have this video as a cheat sheet as well. So stop Serene Bassi, right? So that was in the container ID. This was the name that was associated with it. The container ID is this piece right here. So there's a little bit of a glitch with these instructions. So my bad, that's my bad on this particular case, but you get it, right? So if you give it the container ID, you would need to give it this information right here, which is the container ID, not the nickname that has been assigned to it, which is Serene Bassi in this particular case. If you wanted to remove it by its image name, then you would do RMI, and then you would give it the image name, which is in this particular case the nginx, which would be the image name right here. So that is the value that we would give the RMI version, which is in this case we see nginx as our example. And so that's it. Docker is the tool that helps you deploy and manage applications that are stored inside of containers. And containers house the applications as well as all of their dependencies to be able to run them. And we already went through all of the key commands, and this is just kind of the cheat sheet for you. So to be able to pull it, meaning download it onto your local machine, you would use docker pull. To be able to run it, you would do docker run. And then to remove it, you would do rm or rmi. You can do ps to list them, psa to list all of them, including the ones that are not running. And that's basically it as far as the Docker itself is concerned. You also do need to learn how to orchestrate or manage your containers to just make sure that number one, they're not past their life cycle, or if they're done being used, you get rid of them, especially in a large scale environment, because it does take up a lot of storage to be able to do something like that. So Kubernetes is something that is done or is used for that, for the orchestration of the containers that would be in that environment. Docker Swarm is another one that can help you automate deployment, scaling up or scaling down, management of containerized applications to make sure that they're running when they need to, they're efficient, everything is all good, and then when they're done, you get rid of them. Kubernetes is a very popular one. It's also abbreviated as K8s, so Kubernetes. It's an open source platform for automating the deployment, scaling, and management of containerized applications, and it's great for really anything, especially in a large environment. So automatic deployment and scaling, because it actually works with a variety of different script templates that come into play, as well as rules and policies that you can assign it. So you can automatically deploy something and say that, for this particular image, for this nginx, I want you to create 100 different versions of this and deploy those 100 different versions. And it's very, very good at automatically deploying something like that. You can load balance and route traffic. So just based on the traffic size of your environment and the company that you're working with, you can make sure that the physical servers don't crash, because load balancing is very directly related to that. So balancing the load of traffic that's coming in and routing that traffic efficiently so that the containers run smoothly, but the physical infrastructure is also running and it's available without anything crashing. That's really basically what load balancing and traffic routing is. Self-healing is an interesting one, because if anything fails to start, so it'll just be replaced or it'll be automatically restarted. If anything that isn't working repetitively will be killed. I love that. It kills containers that don't respond to user-defined health checks, and it doesn't advertise them to clients until they are ready to serve, right? So it'll just do everything that it needs to do, and once it's actually ready for the person who wants to use it, it'll just say this is ready to serve. But until then, in the background, it'll restart something, it'll heal it if it needs to be done, it'll kill it and wipe it, and then go get a version of it that's working, and then bring it up and then give it to the client or the user so that they can actually use it. And then it can help you manage the storage as well to make sure that the persistent storage is actually deployed as needed, it's mounted as it's needed. And this is all something that Kubernetes done beautifully, or automatically, so to speak. Then there's the security portion of this. So if you have sensitive information, which a lot of people do, like passwords and API keys, it helps you manage those things securely, which basically means either it won't display them, or if it does display them, it'll be done as hash values, which is basically encrypted values that look like a bunch of randomized text that nobody can make sense of, and they can't be decrypted without the key that has been assigned to the administrator or to the user. So there's no way to decrypt them or to decode them because it's just a very nice algorithm that's been used for the encryption, and then there's a key that's attached to it that anybody without that key would not be able to decrypt those contents. Docker Swarm is Docker's native clustering and orchestration tool. So it essentially does what Kubernetes does. It's just a little bit simpler, and it helps you orchestrate and manage your containers, especially environments that actually already are using Docker. So simplified setup, management, it's integrated with Docker tools seamlessly, so it actually works very well if you're already using Docker for your particular environment. There's an ability to scale your services up or down, very similar to Kubernetes, by adjusting the number of replicas, as I already mentioned. So you can just say, I want you to create 50 versions of this, 100 versions of this, so on and so forth. Load balancing, same thing, that it'll help with the network traffic so that these services don't crash or they don't overexert the physical infrastructure. It's secure by default, meaning that it actually has TLS encryption, which is the more advanced version of SSL encryption that typically runs on top of port 443 for HTTPS, for web traffic. So TLS is actually a very powerful encryption standard for secure communication between nodes in the Swarm cluster, which is a very fancy way of saying a variety of different containers or tools that are trying to communicate with each other inside of this massive environment. So it provides secure encrypted conversation between all of these various nodes or these various different containers that are trying to communicate with each other. And it does it seamlessly and securely. So to want to do all of these things with Kubernetes, as an example, if you want to deploy a Nginx environment, you would do Kubernetes. So kubectl is the command that interacts with Kubernetes. You would do kubectl, create a deployment of Nginx, and then use the image Nginx, right? So it creates a deployment named Nginx using the official Nginx image. Very, very simple to do. Scale it is very interesting, and a lot of these things can also be embedded inside of scripts that can be running. So you just run the script and it will do this for you. But again, scale the deployment of Nginx and multiply that by 3. So it scales this Nginx deployment to 3 replicas. This deployment would be done in 3 replicas. How easy is that? That's crazy. Then you wanted to get the pods. So list all the pods that are running in the cluster, which essentially contain these 3 replicas or as many replicas as you would have. So you would get them. You would list all of those pods contained in that cluster. And then the Docker version of it would be to use the Swarm initialization first. So you need to use Docker to actually initialize Swarm first. And then that cluster would be that stuff that has been managed, and so you would interact with that swarmed cluster. So you would do service creation and then give it a web. So you're using the web name in this particular case. You're going to create 3 replicas. It's going to be on port 80 and it's going to be Nginx. So it creates a service named web with 3 replicas using the Nginx image in this particular case, and maps the port 80 on the host to port 80 on the container, meaning it's actually what's used for web traffic. So port 80 is for HTTP traffic. So it's only appropriate that we use port 80 for our web service that has been created with the Docker Swarm. If you wanted to list all of the services, you would just use the ls command, which is very intuitive to Linux, because that is the command that we use to list anything inside of Linux containers or inside of Linux directories, I guess. And that's it for the container orchestration. These two tools obviously go much deeper, and there is a lot of documentation and a lot of tutorials that are available for both Docker Swarm as well as Kubernetes. It's just I want you to know about them. So if you wanted to do more homework and self-teaching, you know where to go and what you're supposed to look for. And they're very powerful tools because they both automate the deployment of multiple replicas, as they said, of anything really. So it could be a Linux machine, Linux virtual machine. It could be an Nginx web server. It could be anything that can virtually be deployed inside of a container, and it would be done times 1,000 if needed. And it's as simple as saying, hey, create replicas equals 1,000. And then all of a sudden, now you have 1,000 replicas of that same container. So it's a very, very powerful series of tools, Kubernetes and Docker Swarm. And there's obviously other versions of container orchestration tools as well. These are just the most popular and the most relevant to the conversations that we've had. So I do encourage you to check into orchestration of containers using either Docker, Docker Swarm, Kubernetes, or anything that would be similar to it, because it would make you much more functional as a Linux administrator and overall as just a system administrator. This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today. This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.